Con's about to start.
Hey! So very good to see you.
Oh my gosh, so good to see you. Hey.
Hi.
There's people. Hi everyone, welcome to ShellCon 2021. I'm Sonia, also known as Mermaid, and I'm the Outreach Director at ShellCon.
And I'm Davey, lead director. On behalf of the ShellCon planning team, we are excited to have everyone back again this year. Yay!
Yay! It goes without saying that it's been a challenging year again, and ShellCon 21 is only happening because of the love and support we get from the amazing community they've built up over the last 5 years. We had hoped to be in person as we miss all of you, but we had to make this call very early on in the planning process, though that doesn't mean that we don't have a lot of fun events planned for you.
Here's a quick orientation on the events that we're going to have this year. Our main hangout area is going to be on the ShellCon 2021 Discord. This is also where you can ask questions of the staff and volunteers.
There is a link to the Discord on our main website, as well as a link to the Code of Conduct and our schedule of events. It goes without saying, if you see something, please say something by reaching out to a staff member on Discord or emailing complaints@shellcon.io.
We again have 2 tracks of talks this year. You're currently watching the main channel with our technical talks here on YouTube, run by our CFP lead, Jared. And we also have our Raise Me track for career development and hiring managers, run by Lori and her Raise Me team over on the Raise Me Discord channel. We've got a wide array of talks and workshops for you to attend and are grateful to all of our presenters. You can find out more about them on our website.
If you're looking for career advice or you are a hiring manager looking for tips, please check out the Raise Me channels to talk to a consultant or even sign up for a resume review. There will be a lot of networking happening in the chill out rooms, and who knows, you might find your next job on the job board located on our website. Here's a brief overview of the Day 1 main talk tracks. And here's another quick view of Day 2. The schedule of main talk tracks can be found on our website at shellcon.io/venue.
Comments are going to be disabled on these streams, so if you want to ask a speaker a question about the talk, feel free to use the correct talk discussions channel to get your question in the queue. There's a simple hashtag system that will be announced in the channel used for alerting moderators to your question. With Little Munchkin and Satan leading the volunteer teams, there will always be someone to reach out to. And here's a quick view of the Day 1 Raise Me talks. And here's a second quick view of Day 2. Again, please note that the schedule of Raise Me talks can be found on our website at shellcon.io/venue.
Just because we're virtual this year doesn't mean we won't still have the villages for lockpicking and shenanigans. Plus, we will again be running our CTF.
The village presenters will be conducting the demonstrations over on Discord.
The schedule of events is on the website, as we've mentioned before, shellcon.io/venue. And we'd like to say thank you to Holly and Cannibal for spearheading the lockpicking village again. And we want to give a shout out to B2B for sponsoring the Shenanigans channel.
Our CTF is being run by our very own Zymangs with submissions from the community. You can find more information on signing up in the CTF channels on Discord. Teams are limited to a maximum of 5 people, and prizes have been generously donated by Pen Tester Labs and No Search Press.
Once the main content is finished for the day, we will have ShellCon After Dark, which will host an array of amazing hacker DJs and is being run again by Bod. DJ Ice Train Normal has created an awesome playlist that you'll hear throughout the day, and he is also performing tonight. And Cinnamon Flower, as per usual, outdid herself in creating all the art you'll see during the talks and at the after-hour events.
To find out more info about the DJs and for their play schedule, please visit shellcon.io/venue. Please note, you can also get a link to each of the DJ SoundClouds on our website.
We want to thank our gold sponsor, Teleport, our silver sponsor, Van Pelt Yee and James LLP, Pearl sponsors, SkySafe and Bad to Beef, CTF sponsors, Pentester Lab and No Starch Press, our Saturday night bonfire stream sponsor, Escape, DJ Ice Train Normal for the intermission set, and Bod for hosting the nighttime activities, and to all of our volunteers before con and during con, we're super grateful for your help.
Don't forget to go over to the Teleport Lounge over on Discord channel and talk to Teleport about their speaker raffle for a Sonos speaker.
And on behalf of our entire team, thank you so much for tuning in to the first day of ShellCon 2021.
We really hope that you'll enjoy what we have lined up for you today, tomorrow, and look forward to hearing your thoughts.
Please stay tuned for a word from our gold sponsor, Teleport, and feel free to ask us any questions you have on Discord. Thank you.
High five. Bye-bye.
As your team and cloud infrastructure grow, it becomes difficult to manage access to so many virtual machines and cloud applications. You may need to run your applications on untrusted networks, on the edge, or even on IoT devices. Providing secure access to SSH nodes, Kubernetes clusters, and web applications means juggling multiple complex and proprietary tools that don't always play nicely together. It gets even more challenging if you consider a revolving door of engineers and contractors who need convenient and secure access. And as you grow, staying compliant with new and existing regulations can present its own set of problems. Sounds like you'll need to deploy an army of security engineers. Well, you don't have to. Already trusted by industry leaders, Teleport makes it easy to access your cloud infrastructure and applications, keeping track of your authorizations, and helping you ace your audit. Teleport makes it easy to give your engineers and users the right access for the right duration. Teleport authenticates through your identity provider, offering role-based access to your servers and applications that expires automatically. Teleport gives you activity logging, session recording, and role-based access control regardless of where your servers and applications are running. Plus, it's designed to be compliant with the toughest regulations. You get zero trust access for SSH, Kubernetes, and cloud applications running anywhere in the world, from your cloud account and on-premise servers to self-driving vehicles and edge devices. Find out how Teleport can secure your infrastructure, provide access to cloud applications, ensure visibility into user behavior, and cure your compliance headaches for good. Teleport is easy to install, and best of all, it's open source. Download it today. Teleport, zero trust security that doesn't get in the way.
morning, everyone, and welcome to ShellCon 2021. We hope that you have a wonderful time at this year's virtual conference. And today I've got the amazing pleasure of introducing Tamagna Basu. They're the CEO of Data Secure, a research-oriented company that focuses on innovation in cybersecurity. Today, they'll be talking about how artificial intelligence and machine learning have great potential to be used as offensive mechanisms and another weapon in the toolkit for pen testers and red teams. And without further ado, I give you Tamagna Basu.
Hello, am I audible? Can you hear me? Just give me a thumbs up.
You're good.
Okay, great. Yes, thank you so much. Thank you, Tawada. That's a very nice introduction. And thank you, ShellCon, and all the organizers. It was really pleasure to be here. It's the second year in a row, so I'm so happy and I'm glad that I could be part of your journey and contribute whatever way I can. So yeah, and for the participants, I think this is really a brilliant conference. A lot of good talks I could see lined up, and I'm also looking forward to this. So yeah, I think next 2 days will be it's a great time for all of us. So yeah, so without further delay, let's quickly jump into it. So a little brief about me. Obviously, we can find me pretty much in social media and stuff. But yeah, so I've been in the industry for quite some time, doing various part of security. Started as a developer, then being a techie and all this. But my recent past, I think the favorite area which I've been exploring is the artificial intelligence and machine learning aspects of cybersecurity. And the reason I'm doing it, obviously, initially I started this because we have been building a product around that, and we wanted to use artificial intelligence for cybersecurity, which is more for can I use AI to solve some of the specific problems we have in the industry, in the infosec industry, predominantly from the product point of view, product security, application security point of view. That's where I started my journey. So I'm a cybersecurity guy who learned AI because I wanted to apply AI for security. But eventually what I understood and I realized that there is another part of this entire problem. And that is I can use the same technology for various offensive purposes, right? For various adversarial attack. So there are various kind of attack automation can happen using AI. So that kind of opens up doors to various possibilities, thousands of possibilities, I would say. And we've been seeing tremendous progress in this space. And a lot of researchers doing various brilliant work in this space. I'm not obviously the first person in this. There are a lot of people ahead of me, and also a lot of people actually are doing behind me, coming into this adversarial AI domain, right? So with this there is the context of this is I realized that there is a possibility of create sort of a curriculum, and that's something I try to create and do it. However, the idea here is actually not to think about AI as a single thing, because AI is just a technology. Now any technology can be used or misused, right? So the vision here is obviously all the technologies are meant to be done for the various good aspects. However, there are different dark area, I would say, where same technology can be misused, right? And is there a way we can build a security first mindset by eliminating those kind of risk? And that is the vision of me and our team as part of our organizations. And with this vision, obviously, we're trying towards new age technologies and see how we can do it. Now, there are various data breaches that are happening in the world, and we're seeing tremendous progress, tremendous kind of increase in this kind of attacks, especially during the pandemic time in last 2 years. It was very unfortunate. Obviously, we never expected that the situation will be so bad in the real world as well as in the digital and the cyber world, right? The kind of the increase in terms of attacks was exponential, right? And it's all over every sector, every domain, every area of cybersecurity, and the kind of the defense mechanisms we have, that's being challenged, right? That's being questioned, that's being attacked by various people, obviously with not with good intentions. And obviously AI, ML, artificial intelligence, machine learning, that area is also kind of part of this entire story, right? We're seeing a lot of new age technologies, new category of attacks been happening, which is kind of adding a cherry on the top of what are the conventional way of people used to attack these days, right? So for example, let's say brute forcing, right? Or in any credential, brute forcing is a very common attack, right? Or credential stuffing. Now, what if I say that you can do the same attack, but uh, you don't have to carry any dictionary anymore, right? Why, instead of carrying, let's say, a petabytes of data, a dictionary, which probably you will use, and you create a big data kind of data lake of all those data, those credentials, all this, and you created a super cool scalable architecture with multi-threading, parallel stuffing attack kind of engine, which takes this data, keep pushing it to the server and all this. Instead of that, if I give you a simple AI model, which is a kilobytes of data, right? Not even MBs, right? A KB. And at runtime, that can generate more passwords, which is more realistic, more human-like, and with a track record of probability of getting kind of getting used as very faster than a normal. Probably you're creating a permutation combination based, let's say a Python script or any script, right? So that is the beauty of it. We're seeing that people actually, if you think about the problem statement, it's no longer kind of the same problem being solved in the same way. There are different areas, different techniques can be actually used. We know all deepfakes and all this thing, right? So those are very, very, very popular. However, what is happening now? What if I can say that deepfakes and all this were offline attacks, like people actually generating videos in offline, right? There is, so one of the problem statement earlier was you need a lot of computes, a lot of memories, GPUs, which probably you use to process the data, train the model and everything. Now, what if I could actually take that entire process to a near real time, right? In that case, probably it's like live streaming, right? You don't no longer need to process the data. Entire thing can be happened in near real time in live stream. So that's the kind of advancement, that's the kind of new age kind of attack strategies we have been observing in the industry, and that makes us really concerned. And when I say us, I'm now not talking about as a security researcher. I'm talking about a CXO, right? As a founder of the company, that we see that this is obviously there's a continuous evolution is happening, right? In terms of not only about the defense mechanism but the attack strategy. So these questions keep hunting us again and again. How secure is my company, right? How our data is actually safe? Is it safe or not, right? Now the companies I'm working with, are they actually doing it? So a lot of times what is happening is large companies, small companies, let's say accept it, we all not a super AI expert, right? We may at times probably will be using a third party machine learning algorithms or an engine, right? It may have in the framework. Let's take it as a framework, right? We have TensorFlows, we have Keras, we use all this kind of frameworks also, right? To create various model on our own. What if those frameworks itself has vulnerabilities, right? What if the framework itself has some kind of buffer overflow kind of vulnerability? That means it's like the platform is vulnerable, means everything is gone, right? So the thing is, the way we've been observing, when you say we, few of us, like we're looking into this space, security and AI, is we started adapting technologies, and this is a age-old story. Security always come later, right? It just follows the trend. So when we got these frameworks, we are so excited, so happy about that. This is solving a problem, in such a simple manner. Let's start using it. And then the moment it gets scaled up hugely, that is the point where people actually are now trying to exploit it, and those new vulnerabilities are coming, right? So this is what is happening overall. However, there's very interesting aspect I want to address here also, which is the aspect of overhyping the things, right? So everybody these days says that I have a AI ML solution, right? Everybody says that I'm using AI, I'm using ML and the neural net. I'm using deep neural networks. I'm using one-shot learnings, referential, various kind of other mechanisms. So, but the problem is happening today is if you take a very basic analogy of metaphoric example, cybersecurity world, the script kiddies kind of approach, so scenarios are happening more frequently now in AI ML space, right? Although no disrespect to anybody, but we're all cybersecurity experts, right? Probably, but in terms of AI ML, we're still beginners. But however, we're sitting on a problem statement, which is let's say a big problem statement. You probably have to do kind of some kind of let's say a protection on your production servers, which is having millions and billions of transactions, right? Now time is very critical. Now the common approach we've been seeing, people are trying to just see that what kind of tools and frameworks which is available, built by somebody else, which you can simply use as a library and plugin, and we can actually solve the problem statement that we have in hand. Now, which is similar to, let's say, using a third party library, right? Now the question comes, okay, that is again the standard procedure every company follows, right? Then what's the problem? If we have enough kind of zero trust model kind of thing, a layered security, or probably kind of validations and verifications, I say yes, fair enough. But the problem is, if you talk about, let's say, verification, let's say if you're using third party libraries or any kind of third party source codes, there is a standard process we follow in security, right? So which is basically, if I have a CI/CD pipeline, we can integrate to a DevSecOps kind of thing, a secure code review tools, source code review tools. Anytime a new library gets deployed, or a new code, it gets scanned and all this thing. Now the question comes: does this tool have enough intelligence and maturity to evaluate probably an AI ML based telco solution? Probably not, right? So there are certain scenarios. Maybe they have a basic coding constructs which they can identify, but the moment you talk about probably some sort of very deep and complex frameworks, which could be, let's say, TensorFlow or something, it may or may not have enough understanding of do we really do have enough understanding how to check that framework, is it secure or not. So there is always a gap in terms of knowledge and understanding of the platform. And without addressing that gap, because time is so critical, we're eventually going ahead and making certain assumptions and using the tool. So that is the problem we're seeing. And that becomes a very big concern, because when we see, because of that, some large scale attacks are happening, or maybe the possibility of attacks, because we obviously as researchers, we don't attack, right? The real world thing, what we do is we create it, we actually simulate that and see that this is possible. Then we get concerned. Now, typically, if you talk about kind of how it's being used in the industry, majorly is always used in three categories. One is more from a monitoring, anomaly detection, analytics sort of point of view. So we do log analysis, network analysis, malware analysis, which is more of an anomaly detection or outlier detection kind of approach, right? There's another is called authentication area. Also, we use machine learning, which is basically we use for facial recognition, voice recognition. Those are comes under the authentication aspect. So these are the majorly, kind of, two categories we have been seeing. And third is a prediction. There are certain predictive intelligence also getting built over AI ML, of probabilistic overview, like, okay, so something like a possibility of, getting hacked probably, or something, looking at trend analysis, sentiment analysis, if in some kind of forums, people are talking about something and the sentiment is going towards negative, chances and that there might be some targeted attack towards your infra. So this is the kind of various monitoring, prediction, predictive analysis, and authentication is happening. And typically, if you talk about any problem statement, this is a very generic pipeline which applies to across almost every problem statement, right? So you have supervised learning, unsupervised learning, semi-supervised learning, right? So you get, the moment you try to solve a problem, obviously as a researcher or as an AI analyst, you first look into the data set. With the data set, you kind of train models. And once the model gets trained, you create a wrapper around that to expose certain APIs. And obviously, if you talk about Python being, one of the very popular framework, the language platform people use for this is, use Django or Fast API or probably Flask, any of those kind of, API making kind of, I'm not talking about managed services like AWS, cloud hosted. I'm talking about if you're building something from the scratch, you create using that, you create kind of an API layer, and then you expose those API to the world, and using those API, the kind of the end users or the probably the applications will consume the model and ask the model to do certain things. Now, what are those certain things? Obviously, this is basically some sort of predictions or classifications or clustering, right? So essentially, what you're talking about, if you talk about this kind of loop, there will be a kind of API which sort of a predict API is it's a common pattern which you feed an input, model will look into that, and model will actually go back, and model will kind of let me just see if I can put a laser pointer. Yes, you can actually see model will take an input and it will just give you a prediction. However, a lot of certain times people what they do, they actually expose the training API as well, and sometimes it's actually developers expose it for their internal training purposes. They want to improve the model to train. Probably in forgot staging environment they do it, and production environment they completely forgot to disable that. So if you actually see sometimes along with the prediction there might be a train API also will be exposed, right? Now these are the various kind of recon we do, and with that we try to create sort of various attack scenarios when you talk about an attack. Now when I told so now there are two part of it, if you understand so far, is one is attacking a ML system, right? If I have a AI ML system, there are certain things you can do which can attack that machine learning model, that system. And in a way this is basically bypassing. So if you create a model which is supposed to do certain things and you're bypassing it and making the entire system to do certain other things, right? So that is called that is basically more like you are actually doing various kind of poisoning attack, data poisoning, skewed model, and no adversarial attacks, steal model, and all this. So these are the various possible attacks people do, which is one thing. However, the other thing is you use AI to bypass AI also, and that is another area which people try to do it. Now, what are these various attacks? Obviously, this is a very vast topic and vast subject. There is we'll probably briefly touch upon that, but poison data set is very simple. As I said, whenever there is a possibility we see that a train API gets exposed, uh, let's say think about this is like a object detection model, right? Where it actually given a very simple, let's say given a fruit or probably as a vehicle, right? If you talk about autonomous driving mechanisms and all this, if it's a detection mechanism which detects which kind of vehicle is actually there in front of camera or something. Now, if I see there is a train API exposed, what I could do is I could feed in wrong data, right? I can feed in that this is a truck, and I feed a picture of car, and I can keep sending this data sufficient times so that eventually the model get biased, right? Model gets trained with this wrong data, and then after that, whenever there is a car comes, it will detect as a truck. So that's like a data set poisoning attack, and it actually happens in real time. It sounds like very theoretical, but it actually happens. And if you Google for an experiment called TAY, T-A-Y, TAY by Microsoft, a couple of years back, they have created a Twitter bot. And the idea was Twitter bot was actually people will be supposed to, be able to chat with that bot over Twitter. And then the way Microsoft designed the architecture is the bot supposed to read the chat which is the users are sending, and it should learn from that. It's a very interesting thing, and somewhere there is a group of people realize that, and what they started doing is they started sending a lot of inappropriate messages, inappropriate messages which a lot of abusive words and all this thing. And you won't believe, within probably a couple of hours or a day's time, the bot become a racist bot, right? And there are, if you Google for it, you see a lot of this kind of the screenshots of the bot is giving responses which is very racist and very inappropriate. Now unfortunately, obviously Microsoft has to shut it down, that project. So a lot of times developers or the engineers, they build the model and they think that the real world training can happen if I actually open my training area. So that is actually if we could find that, definitely we can poison and we can actually make the model do whatever we could do. So the skewing model and the poison data set. Adversarial attack we'll touch up in coming slides. Stealing model is another interesting thing. Obviously it comes under reverse engineering attack, but the idea is very simple. If I see there is a solution, it could be as simple as, let's say there's a mobile based application which uses some sort of AI algorithm, and I get a sense that the model is actually deployed locally inside the application. There is a high possibility I can actually extract out the model, and I can try to create a wrapper around that, and I can use it for my fun and profit benefits, right? And if it was a paid kind of application, then in that case I don't have to pay anymore because I have the holy grail with me, right? I got the entire model. So these are the various attacks we see in the industry. Now the question is obviously how do we do it, right? So the way you do it obviously is very age old. The strategy is the same. It's just what you're looking for is different here, right? So we do recons. The moment I see there's an AI-based model, we do an API recon. We look into the API aspects of it. So what are the various APIs are there, which is exposed by the system, and from that we try to do it. We also probably look into research papers, blogs, and product pages, and see that did they mention anything about any specific algorithm they are using, and then see if this algorithm has any drawbacks or not. A lot of time, like me, I'm going and talking. Obviously, everybody would love to showcase their research, right? We can go to talks and demos, social media, and see that what kind of things they have kind of they are doing a research or the kind of algorithm they do. And with all this data we try to create an efficient attack strategy, and which can be used to kind of attack your AI based model. So that's the area where you try to attack an AI based model or AI based solution, and you bypass that. Second part is obviously the adversarial learning, which is basically, is actually my model is learning what they expect to learn? And this is a very simple example of that. So let's say this is a street sign detection algorithm, which is basically looking at the street sign, the object detection, the model should detect that. But there is certain amount of noise in some specific way. If I can feed in that to the image, the image will not distort, right? There is no distortion in the image, at least in the visible, from the look and feel wise, it doesn't look anything. However, from the model perspective, it is completely a different object, right? It actually become mailboxes. So right, so like this, actually we can craft different kind of adversarial attack vectors. That's what we call, and using that we can actually bypass the recognition algorithms which various companies or various researchers are building, right? So how we do this, right? This entire process is actually an optimization problem at the end of that. And if people who are familiar with AI/ML, you probably will be know about gradient descent. So what we do is actually, this is a trial and error. It's like a brute forcing kind of approach. We look into this, we actually start adding various kind of noises and try to see, okay, now am I actually able to deviate or able to actually change the decision making ability, right? So using this optimization problem, we actually calculate that how much is actually we're closer to the target in terms of calculation, the distance, it could be Euclidean distance or whatever it is, and then eventually we see that am I able to hit to the object. So if my intention is I want to send my face, for example, to a facial recognition algorithm, and then I want the algorithm to believe that this is the face of Bill Gates. So then my target is Bill Gates. My attack vector has to be, the source of the attack vector should be my face. And then I will use this algorithm, optimization algorithm, to see how I can efficiently add noises to my face, picture of my face, so that eventually it doesn't look like Bill Gates. However, it will still look like me. But when it goes to the model thinks that it's Bill Gates, right? So this is the entire adversarial AI attack is actually around this entire approach or thought process, right? So these are various specifications of that. Similar thing can do in different ways. This is called one pixel attack. What happens is you can see it. It's very simple. The attackers are able to, or the researchers, let me put it that way. I shouldn't say attackers. They are brilliant researchers, and I have a lot of respect for them. They just able to put one single pixel. Here it's white pixel, you can see. In this here, there's a black pixel, you can here see. And then here you can see there is a white pixel again. And just putting one pixel, the decision making completely, the ship actually misrecognized as a car, horse become frog, and deer become airplane, right? So this is called one pixel attack, right? So this is the kind of very innovative attacks we can do, and I'll do. This is another instances of actually obviously facial recognition attack. So The researchers, what they do, they actually added a sort of, it looks like a specs, but there are a certain amount of noises which has been perturbations has been added, and as a result, Owen Wilson's face, which was detected as Owen Wilson, after that it wasn't detected like that, right? So it doesn't classify as the correct class. In real world, in security, there was one also incident where researchers were able to trick silence antivirus into thinking a malware is a trusted software, right? So now you can understand, right, how this actually, fusing into our cybersecurity world, right? If we are able to, there's an AI based, obviously antivirus, malware detection algorithm, and we're able to bypass that by, doing a certain kind of, adding noises. These are a few other examples, and this is called adversarial patches, which is essentially nothing but, for example, this is detects is it a person or not, and then when, if I could wear something like this as a patch, then this person doesn't get detected as person. So these are all very popular, and if you just read more about it in the internet, is there available. So these are called adversarial patches. People actually sell, print this kind of thing, and they can put it next to each other. This is another interesting example of adversarial patches. So it's obviously a face detection. However, if I put a patch, the face, it doesn't get detected face. This is another kind of sticker, patch sticker. So it was classified as banana. However, if the sticker was kept next to the banana, it actually gets detected as toaster. So this is the kind of various interesting attacks, in the real world also people can do. You just have to take this print out and probably stick to your body. And this is another interesting thing. So misclassify attack without any fancy math, right? So the idea is very simple. We actually, the guy put various a t-shirt, print a t-shirt with number plates on that, and just the algorithm thinks obviously there are various vehicles are coming, to the parking, right? This is a distorted input, so it's the same input. If it gets distorted, let's say it's widened, it actually misclassified as a different person. So sometimes it's as simple as that. You don't have to know AIML and all this thing, right? So these are all very, very, there's a few more examples are there. The whale gets detected as shark the moment there's a baseball picture is put into it and all this stuff. So these are all the kind of, various kind of attacks, detection. This is how we bypass various kind of detection and recognition and attacks. And yeah, this is called misclassification. So these are a few more examples of that. Now, this is another interesting attack, which is the predictions, right? So there are a lot of AI based solutions there. What they do is they try to predict what you're supposed to write next, right? For example, I don't know, I think in Google Gmail, I've seen it. No, when you type something, it automatically try to complete your sentence, right? Now the question is, from where is getting the data? Obviously, from a historical data set you have, right? So there is a research where essentially the point is, if there is a data which has some sort of sensitive data, could be a PII data or probably a credit card data, and if I, for example, what if I type my credit card number is, and if there is a credit card number, that number will simply just get added to that, right? So there's a high probability in theory is, if there is a predictive algorithm, and if you are not doing any data sanitization or data classification, and by masking the sensitive data, this predictive algorithm could highly probable that they can actually get those kind of predicted sensitive data from the historical data, right? So with this, just a time check quickly. Let's see. Okay. I think, how much time do I have? Okay. So so there is some more quick kind of case studies. Let me just touch upon it briefly. And as I said, there are a lot of interesting scenarios and test cases are there. This is about of breaking a captcha. Now, this is a use case of a captcha which is really simple. However, a lot of companies, they use this kind of captcha, and the idea is, can I bypass it, right? So the captcha is like this. It is a little distorted, and we're not using any OCR per se right now. So the idea is, we will get all this kind of, various numbers, and just give me a second. Okay. So various kind of capture, and can I actually predict that with using AI? And if I can build an AI algorithm which is able to successfully predict what is this, then I'm successfully able to create an automation which can actually predict and feed this data back to the system, and I don't need I will be able to bypass the capture, right? So how do we do it? So in this approach, obviously, it was used as a CNN. So this is where we are trying to now build an adversarial AI model, which will do a prediction, and we will misuse this prediction to bypass a security defense mechanism, right? So that's exactly what we're trying to do. We're trying to build a model which will do certain things, and this certain things ideally should, and we will be using it to bypass kind of a bot detection. Capture is all about automated attack prevention, right? So the way it has to be done, and there are different kind of research earlier has been done. People have done using the OCR kind of thing, image recognition, that. But here it's a different approach has been followed, right? And why different approach? Because this is where things get more critical and you get more accuracy, right? So essentially, what happened is using kind of CNN, obviously, you can detect various kind of patterns very easily. So people who are familiar with CNN, anything you related to probably image related stuff, CNN is obviously one of the favorite thing. However, for people who don't know, CNN is actually a popular neural net, which mostly used for any kind of image related computer vision related use cases. And one of the benefit of using it is actually variations and location, it become independent. So if, for example, if I'm writing 9 could be written like this straight line or like this line, or maybe if it's written somewhere sometime in the left side of the page or right side of the page or right middle side. So these are the problems in real time. Obviously it happens, and using CNN, it actually help you to address certain those problems and get the detection more accurate, because now it doesn't impact whether there's a variation or there's a location shift, right? It's a very basic way of explaining how does it work. It's just a sort of a various kind of filters, and filters is nothing but a sort of a pattern recognition. For example, if I have to detect this koala, I need eyes, right? I first want to say, okay, does it have koala's eyes? Does it have koala's nose? Does it have koala's ears? If yes, that means it probably will be a koala's head. Same way it is a koala's hand. Does it have koala's legs? So that means it's a koala's body. And if I have koala's head and body, then together it can be a koala. So it's like a divide and conquer. Obviously, it's the other way, right? So you first do a small pattern recognition, and then you club it together to decide is the bigger pattern, and eventually you finally detect the object. That's a very naive way, if I have to put it a very plain simple English. Now, if I want to put it back here into, let's say, a digit detection, if you see this 9 is actually been defined by various loops and vertical lines and diagonal lines, right? So there's a loop, there is a vertical line, and there is obviously a diagonal line. And if this three things can put together, this could be 9. Now the question you can ask, obviously, if I put 6 also with the similar construct, right? However, the positions are different, right? So that's exactly how it does. So I will have different pattern detection. There's a loopy pattern detection, which will be, let's say, if I have this kind of three things, it will together be a loop. If I have a vertical line like this, it will be a vertical line, and if a diagonal line, and if it comes in this sequences, like top is loop, then vertical this way, or whatever, like this pattern, then it is 9, right? So these are called various filters, in terms of, if you know a little more, go into depth of how it works. And it's sort of a sliding window kind of thing. It slides through the entire image, and it will detect that where is this pattern is there. So if my objective is the loopy pattern detection, I will go through this image with this filter, loopy pattern filter, and tell that, what, out of this image, the top of the image has the loop, right? So like that, you detect that, and eventually you finally say that, this is the digit. Now, why I'm saying this? Because if I do it this way, it doesn't matter if it's upside down like this way, or probably the koala is lying like this, you will still be able to detect, it's the same object. So same way, if the 9 is here in the center or left, you will still be able to detect this is the same number. Now, why this is important? Because if you see capture, right, the way people try to make capture difficult, and again, I'm telling you, this is a simple capture, right? Obviously, we have nowadays more advanced one, better ones. You try to shift locations of the, try to make the letters, closer to each other, sometimes left side, sometimes right. You try to make it a little tilted. So that's how you try to make it a little difficult, so that obviously any basic way of object recognition or image recognition will not work, right? However, by definition, CNN actually fits the bill, right? CNN exactly solves the problem which this kind of capture is trying to use to make us difficult in terms of automation. And that's exactly what CNN is solving. So this looks like obviously the problem, the kind of data structure or the kind of network algorithm which I'll be using to solve this. So the way we did it, it actually instead of feeding this directly, first this entire image gets broken down into small characters, and now with these characters I get two various variations of twos or w's like that, and then this gets trained into the neural network, which essentially means that now the neural network will have a knowledge that whether my w is like this, left tilted or right tilted or straight, I will still be able to detect this as a w, right? So that's how this get treated, and with this kind of training, eventually able to detect the captcha with almost 100%, 99.9% accuracy, and that's brilliant because obviously the accuracy is one of the very important things. So this is the research paper which has been published in 2017 by researchers, and this pretty much work. And the example I've shown here, this is actually called Really Simple Capture. Is a famous WordPress plugin, and it's being used already. Still been have 1 million plus active installation. If you go to WordPress marketplaces plugins, you can see this still there available, and which essentially means anybody who is using this captcha will be vulnerable to this this approach, whatever we build. And this entire research has been open sourced, is there, and this was actually one of the screenshots which is found in the internet who are using this kind of captcha. However, I think this is an old screenshot, so it's no longer valid. But yes, any WordPress site which is using this kind of captcha will be vulnerable, and this source code is available in the GitHub repository, right? So there is some other similar kind of approach done by different other people who have actually taken it further. They have actually tried with even a much bigger player like eBay, Amazon, Wikipedia, Baidu, and all this thing. And you can see the accuracy level, the success rate, which is pretty much 80%, 90%, and all this thing. So this is pretty scary, right? Because now where one side we say captcha is supposed to prevent automation attacks. Now we're saying, okay, that's no longer valid, right? So that's how it happens. Now take another example of, as I said, model stealing, right? Offline model stealing, right? So that is very popular, and obviously, people, we've seen people actually been doing it. So essentially, it's as simple as that. Look into if it's, let's say, a mobile app, probably which is doing some sort of fancy AI thing. Just go look into the files. You can reverse engineer the files, right? If you're a mobile security researcher or a malware researcher, right? You can actually extract all the files, and you can look into the file. Now there is a catch here, right? Unlike, let's say, Java code or something, first of all, there is no standard extension or anything for a model. People sometimes save it, a mobile as a model, sorry, a machine learning model. When people sometimes save it as a .pickle file, however, that doesn't necessarily mean that it has to be .pickle. It could be without even any extension also, right? A binary file you can store. So the challenges come when you have an application which using a kind of machine learning model, but you don't know that which exactly the file which has the model stored, right? So that's the puzzle. There's a needle in the haystack, probably, if it's a big kind of application you are using, you have to solve. Now, how do you do it? So these are the keywords, right? We know that PyTorch or Keras or probably TensorFlow, these are the standard framework used for to build any machine learning model, right? So essentially what you could do is you can look for those keywords, and you can see that, okay, do I have any files which has those keywords actually exist? If exist, then probably there's a probability that that could be the file. And from here, it pretty much looks like, okay, exactly these are the functions we use. And I know, since I'm a probably machine learning developer or engineer, I know these are the standard function which is people are using. And if somebody is building a model using Torch, right? So this kind of confirms the first part of kind of, where this model is. And now then comes obviously the once you get the model, how do you load the model? So you get the, let's say, the file, which is a persisted model, like the stored model, or probably serialized model. Let me put it that way. Now you have to load it in memory, right? You have to deserialize it. You have to parallelly load. So then their problem comes is different model has different versions, right? It's not always the same. You have to figure out which version of the live framework is used, and only that specific version will only allow you to load the model. So over the time you get those expertise, and once you get it, you will be able to write a small code with the correct version of the library, be it by, as I said, TensorFlow or Keras or whatever it is, and it will be able to load the model. And the moment you load the model, then everything is now with you. The algorithm now is at your disposal, right? You can now actually ask them to predict anything. You can do whatever the application is supposed to do. So what I did is I just extracted the model, created a parallel like an infrastructure, and yeah, I just bypassed the entire security mechanism of that specific model. So these are various kind of model stealing attack happens. Now the question is what you can do about it, right? If you are building a AI based product, right, obviously then now you're concerned, I have to do it. So there are some frameworks available. So Foolbox and Clever Hands are actually some open source frameworks which helps you to do this kind of assessment of your machine learning algorithms, right? Machine learning products. So you can evaluate your model and see that are they secure in terms of adversarial attacks or not, right? So that is pretty much you can do using something like this kind of various framework. So yes, I think that's overall, I think all I have pretty much. And kind of, as I said, with all this kind of research and understanding, me and one of my good friend, his name is Nikhil. He's also a famous researcher in this space, adversarial AI. We try to come up with some sort of curriculums and where we try to teach people about all these things, how we can do it. And there are more advanced, future kind of, attacks also is possible. You can bypass facial recognition, bypass a voice-based, ASR, speech recognition system, Alexa, Siri kind of thing, and this thing. And last but not the least, and that's what I think last time I presented in ShellCon as well, which is my one of my favorite passion project is how I created my clone using AI. So it looks like pretty much I can do real time create a bot which looks like me and with whom somebody can have a conversation, right? So the future is like the possibilities are enormous. Like we are actually whether you talk about good or bad, I think there is brilliant possibilities in this space, and we need more researchers in this space. We really request and ask people to get more research done in this space, and together obviously our intention is to make more secured cyber world, right? So with this I'm going to stop here, and I thank you all again for attending and then this conference, and for the next 2 days I wish you all the best. So thank you so much. So that's pretty much from me. Any questions?
Hey there. So we do have a couple of questions in chat. I will grab them for you now. We've got, I've lost it. I had it right here. So we've got Barking Seal asked earlier in your talk. Where did it go? Vulnerabilities are part of the nature or complexity of the code release schedules. Hence, isn't the crux of the issue simply a matter of balancing the available resources and prioritizing efforts?
Sorry, could you please, the voice is, I'm not able to hear what is, can you be a little louder, please? Yeah.
Okay, sure. Is that better?
Yes, it's much better. Thank you.
Okay, great. So Barking Seal asks, vulnerabilities are part of nature or complexity of code. Hence, isn't the crux of the issue simply a matter of balancing the available resources and prioritizing efforts?
Yes, obviously. So I think it's without saying, right, and we all accept the fact, people who are working in this space, right, nothing is 100% secure, right? whatever is since feels secure today, eventually somewhere or other tomorrow there might be something that it might get broken. At the same time, like in real world, you say that, right? You cannot make everyone happy in this world, right? The same way, obviously you cannot patch almost every vulnerability. It's not possible, because the moment you feel that you have fixed all possible vulnerabilities, there would be a new vulnerability might come to your system, right? So at the end of the day, it's a prioritization. It actually just, you have to choose your own fight. You have to see that, whether I want to secure so the product or the infrastructure, or probably the outer layer, in terms of, we can put more firewalls on, probably do more monitorings, to see that I'm not letting other people send any malicious traffic to my system. So yeah, at the end of the day, it's just balance. However, what I'm trying to highlight here is the possibilities that the trend going towards, right? What wasn't possible 3 years back, the kind of attack strategies or attack scenarios, is highly possible today. So until we upgrade ourselves, or upgrade not only our knowledge but our ability to fight, and probably reciprocate, we will not be able to continue and survive through this let's say the fight of good and evil.
The fight of good and evil. I like it. Barking Seal also asked, with the recognition that AI and machine learning does well regarding correlation and prediction, yet has little to no concept of context across multiple security domains, experiences, where do you see the value of human partnership in conjunction with AI and machine learning tech? That's a lot going on there.
Okay, yes. Judgment Day is near. Okay, anyway, so it reminds me of that movie Terminator, right? So basically, the idea is very simple. At the end of the day, so see, the algorithms are nothing but it's just a utility, right? It's a tool, and we are the people, we are the researchers, we are the developers, we are the engineers who are utilizing the tool to build something which gonna solve a specific problem for us, right? Now, at the end of the day, it's us, right, who are building this. We have to do enough due diligence to make sure that, it's not only solving a problem, but it's solving in the right way, so that there is no other possibility of, getting, as I said, the poisoning the data, or probably, stealing the model, and all this kind of malicious things, right? So there has to be a human intervention. There has to be a balance. And at the end of the day, we are the people, as a creator of this kind of product, are responsible to secure them as well, right? So there's, without going there, we will have to be there. I mean, I see that obviously we as the human beings obviously has to be involved both on the side A and side B together.
Barking Seal's very interested in your talk. Another question here, is there such a thing as automated file integrity monitoring for verification of AI models?
So I didn't understand the question. Are you asking how to do that, or asking how to bypass that, or what exactly is that?
Is there such a thing as automated file integrity monitoring for verification of AI models? Barking Seal, I think you're still around in chat, so if you want to clarify a little bit.
So, okay, and let me meanwhile probably try to understand if I'm understanding correctly. You are saying if at all is there any file integrity monitoring solution which can detect a model is queued or not? Is that what you're asking probably?
How to make sure that the models don't change without your knowledge.
Yes. So the model has two parts. Model is at the end of the day is just a file, right? It's just a program. It's a code. Now code can still be in two form, right? Either in memory or net storage, data at rest and data in motion kind of approach, right? And when it has storage, obviously it's a file. Now any kind of file integrity monitoring solution will be applicable to that. It's just another file, right? When it's in memory, obviously then it's a problem. Now, when it's in memory, what we try to do is we kind of, so there is an approach called golden dataset approach. What essentially that means is that at every point you do a benchmarking of your model. You have a fixed data set, which you know for sure is accurate, and you feed in that data to model and revalidate the model that is it actually predicting the right or not, right? So any point of time, let's say if somebody is poison the model, or probably for some reason model gets distorted, you send that data set, golden data set to the model, and study the prediction and see that am I getting the same prediction as I was getting earlier? If not, obviously that means something is wrong. So I have to revert my model back there.
All right. I think that answers Sparking Seal's question. I don't see any other questions in chat currently.
Mm-hmm.
I'll give everybody just a moment to see if anything comes up.
Mm-hmm.
If not, do you want to share where folks can find you for more information? Are you going to be hanging out in the ShellCon Discord server today at all? I know it's really late for you.
It's pretty late, so I think
yeah.
I might be, but I think I'm pretty active in LinkedIn. I don't generally use any other social media, mostly LinkedIn. So you can find me very easily LinkedIn. My name is difficult and unique, so if you can just search my name or my company name, which is a data with a E, so it sounds like a typo, so it is intentional. So we can just search by the name, you will be able to do it, and I just put my email address, so I'm happy to chat, whoever has any interest and all this thing. And I think last but not the least, I forgot to mention that the cloning project I have done, this open sourced, and that also repo is public, so if anybody is interested on that project, I'd be happy to collaborate, contribute, and yeah, take it forward.
If you want to send over the link to be able to find that wherever you've got that stored, so folks can contribute, we'd be happy to share that in the chat.
I will do that. I will probably send you. Do I know to? Should I send you here in the Zoom, and you can post it in Discord?
Yeah, I could do that.
That'd be okay. So
we've got a few minutes.
Right. Let's just give me a second.
And then while Tamagna's doing that, I just wanted to mention a few housekeeping things. Like you've seen, if you've got questions for any of our speakers, please drop them in the main talk questions chat on Discord, and prepend them with the hashtag ask, so we know that you want us to ask your question of the speaker at the end of their talk. And a few other things, the capture the flag should be open if it isn't already. Let me just check the time because I'm doing time zone magic right now. In a few minutes, the capture the flag for ShellCon 2021 will be open at 11 Pacific time. And also we've got the Raise Me Village going on, which if you're looking for cybersecurity career advice, support, want to do some consultations, there's resume review and a bunch of amazing talks there as well, in addition to the lockpicking village that will be going on today and tomorrow.
Great. I just gonna post it here, and this is the code.
All right.
And yes, I think that's it from my side. Thank you so much. And yeah, I would be happy to connect. And not today, but probably late evening your time, and probably early morning. I would love to probably come back and attend the conference and see how things are going. Awesome. And we are hiring in my company, so anybody is interested, I'm happy to talk. Yeah.
There's a job board for ShellCon as well, so we'll make sure to grab that information and get folks at your direction. Thank you so much. It was a pleasure having you, and we hope to see you around sometime.
Thank you. Bye. All the best.
CTF is open. Watch out for worms on hooks.
Hey, welcome back to ShellCon 2021. We are here with Virus, the CTO of Escape, and today he's going to discuss the macOS system management policies, vulnerabilities, and Apple's response to their disclosure. In their talk, macOS policies are more like guidelines. Just a reminder, if you've got any questions, please post them to the main Talk Questions channel in the ShellCon Discord server and tag them with #ask. So we know to ask Virus here at the end of their talk. So let's do this. Take it away, Virus.
Hello. I'm sorry in advance for any random screeching that happens from off screen. I'm working and dadding by myself today, and she just woke up and has not eaten. So I'm sure at some point she'll just start yelling through my slides. But you know what? It's fine. It's very on brand for InfoSec. Okay, so this talk is about OS X policies. Policies, or profiles as some people know them, are basically what makes MDM work. They are the rules that your computer or device is allowed to perform. This is basically the Mac equivalent of like a GPO, right? Like a group policy object or something like that. And if you've ever seen any of these systems, yes, Microsoft's on this board because yes, they actually do have a Mac OS MDM integration for Active Directory. A lot of people don't know that. But yeah, if you've ever seen any of these management systems, that's what they do on the back end, is they add and remove and sometimes let you modify macOS policies at scale. If you don't know what a policy is, you've probably interacted with them if you've ever seen a message like this, because one of the things that policies do is they control the signature verification of what you can and cannot do when it comes to executing software. So like if you work in an organization where Santa exists, or I'm trying to think of another one, there's a handful. I think Sentinel-1 has like a blocker thing. I think CrowdStrike has a something. Anyway, these are all part of like the Gatekeeper system, and like this is how Gatekeeper does its thing. So there's lots of interfaces to the policy management system. It's literally a daemon that is attached to the OS X kernel that accepts and responds to commands. And basically, anytime anything shady, like loading a program or opening a network connection, needs to happen, that subsystem is responsible for making a policy D call, and policy D has this whole chain of things that it uses to make decisions and decides whether or not you can do it. Where the actual policy database lives is it's actually just a SQLite database on your machine. It occurs to me that I probably should have put the location at the top of the terminal output up there. I think it's like /var/db/policies or something. But anyway, you can go Google it. It's not hard to find. But the easier way to do it is if you go to your system preferences and you click on the policies extension. All these are policies. That's it's what your computer is supposed to be able to do and not do. So okay, put a pin in that. What is SIP? SIP is basically the thing that says that when it's enabled, among other things, it turns certain directories off, even from the root user on a macOS machine. And then additionally, it says that you're only allowed to use programs that are signed by Apple and have proper certificates. And this is the equivalent of like turning the TPM chip on in your Windows box, right? So pretty much any organization that's running Macs at scale is going to have SIP on, and it's part of that Gatekeeper system that we talked about previously. So these are some examples of some SIP directories. The big one there is that any application that ships with your Mac is also covered by SIP, and that changes all the time. So like it couldn't really be exhaustive. There's also a handful more because there are symlink directories, which will become important later. But yeah, any directory that is listed here or is tagged as SIP protected when SIP is on, you even as root, you're not supposed to be able to write to in order to make modifications. In terms of how sys policy D as a like an application actually works, there's some really good prior art out there. One of them is this guy named Scott Knight has a blog out there, and I believe his most recent blog post is actually him reading, like going through the source that's in the Apple open source portion of when they used to open source the entire application for sys policy, and then opening the objects involved in a disassembler and like actually walking through the decision-making process through the way that its API is interacted with and the way that it makes decisions. Link to that. And then more recently, Patrick Wardle, his blog just came out with, I mean, I think it's like 4 blog posts ago or 3 blog posts ago now, because they've done some more recent stuff. Has a guest blog up there from Cedric Owens, where there's actually a vulnerability that they discovered, or that Cedric discovered in Policy D, that some malware out there was actively exploiting. And basically it just has to do with jumping the protection chain and how it was not enabled appropriately under certain circumstances. That is a really, really good breakdown of kind of the decision tree and how it can, have drastic effects on application management safety. In general, Policy D is a really big rabbit hole. It's relatively deep and attached to the OS X kernel. There's a significant code complexity. There's significant decision-making trees in terms of when it will let you do certain things and certain not. This talk is not about any of those at all. That is like a whole rabbit hole, and you should totally go look for bugs there, because there are many. But what we're going to talk about today is the fact that if SIP is enabled, it turns out that, remember all those policies that we talked about at the beginning in like the first slide? Yeah, they don't work on any program executed from a SIP controlled directory while SIP is enabled. That's the whole talk. Where's my, and like, basically this video is just proving it to you. So this is a demonstration of a machine that has a USB access read only policy applied. This means that this machine, for all intents and purposes, is not supposed to be able to perform USB write functions. You're only supposed to be able to read from mounted disks. So that's what that's showing on the upper left hand side. So the workflow here is we're going to go into disk utility, right? And we have a USB drive that's plugged in, but not mounted, right? And we have a folder with some data that we want to steal, nefarious. And it's in a folder called My Secret Stuff, right? So what we're going to do is use disk utility to create a hybrid DMG image. Oh, there she is. Yes, I will feed you soon. Calm down. A hybrid DMG image of this folder of stuff we want to steal, right? And then we're going to DD, which ships with the machine, that DMG image to a USB endpoint. And what's great is you'll know it worked because Apple mounts it for you when you're done. Yeah. It only works when SIP is enabled, which is kind of funny. So like only if you want to be safe does it work. But that's the thing. So I was going to have a second demo where I was going to write a very simple application that violated a policy, and then I was going to copy it into. So the reason I talked about symlinks earlier is because all those directories that are protected by SIP, usually you can only write to as root. There are 5 of them where they're symlinked into locations where as root, while SIP is enabled, you can still modify them because you can use the symlink to access the directory, which means that if you have sudo access, calm down. If you have sudo access on a machine, you can write a program that does whatever you want, and you can copy it then into a directory that you're not supposed to be able to write to, and then execute it to violate a policy. That turns out to be pretty useless because 2 programs that are already in those locations are ZSH and Bash, which can do whatever you want. So basically, if it's a command, you can do it and totally violate SIP. Which, like, why would you bring your own binary then? Like, they gave you a shell. So I told Apple about this a year ago, like an actual year, like September of 2020, right? And they very discreetly said, we don't care, go away. And more importantly, and this is really the only reason why I thought this deserved a talk, they not only said that me being able to violate a policy was not a bug, they explicitly said that configuration management is not something that Apple considers a security barrier. Okay, that would be the equivalent of Microsoft telling you that GPO is not a real security barrier, You should use something else for system management if you're worried about managing like security threats at scale. I really don't know that I have an appropriate allegory to show the like to accentuate the ridiculousness of that claim. Like, and then more recently, all of a sudden they got interested again because they found out I was talking about it publicly. And I did not answer them at all because why would I write things down that are just going to be material evidence for a lawsuit for something that you've had a year to fix and told me you weren't going to? So yeah, quick conclusion, basically all of this stuff doesn't effing work because it's all based on a policy model that Apple explicitly told me they do not enforce as a security barrier. All your SLAs are trash. Question.
Okay, so we do have one question that I can see so far is from Barking Seal. Thoughts regarding your preferences regarding macOS MDMs and why?
I've only really messed with Jamf at scale. I've heard good things and have had a cursory interaction with I think it's like Menmalias or whatever. I don't know. I just break things. Like I'm not a good judge of those things.
F Prime wants to know if you'll marry them. You're getting a lot of great feedback in the chat about your talk and how ridiculous this is that it had to get to this point.
Yeah, it's pretty stupid. Jamf absolutely is a dumpster fire, but it's a consistent dumpster fire. And the thing about Jamf is that like it's relatively multi-platform compared to the rest of them. Actually, using Active Directory to manage MDM is actually not that bad. It's just that you have to fully invest in like Microsoft's domain lifecycle, and like that has its own version of trash and pain. But you know, like welcome to InfoSec. That's all I got for you.
Everything's fine. Everything's fine.
Yeah. I mean, one of the things that you can do on Jamf, and you can do this pretty much on all of them, but like Jamf's API actually does explicitly support the ability to run commands on machines, which sounds like it'll turn your fleet into a botnet, which is not wrong. It will. But that also is basically remediation at scale. And like I've actually had to use it for that, and it like didn't fall over on a network at the time of around 10,000 machines. So you know. Take that with what you will.
There's that. What else do we have? You're also on the server, aren't you?
Yes.
Okay, cool. So you can see the questions too.
Yeah. I just kind of tabbed over. See if I can respond to things.
Yeah, I don't see a whole lot in there outside of just excitement and.
Do I care to speak to Apple's security framework, i.e., move from K extensions? The most important thing to know about Apple security framework in October of 2021 is that whatever we see now is not actually the Apple security framework. If you look at what's been deprecated, like the task for PID stuff and all of the like, you know, like Apple's version of like process handles, like basically inter-process communication management is like totally gone, right? Like you have to have, you know, even getting a debugger to work anywhere on an OS X machine right now is insane. And this is because Apple is clearly following the roadmap of, for the stuff that we want to move inside Security Center, which is everything, we're going to turn it off first and then slowly turn it on inside Security Center. So I would expect things to get a lot more robust over the next coming years, but before they get better, they're going to get a lot worse.
All right. Well, sounds like little hacker is ready for some food.
Oh yeah, no, I mean it's Murphy, right? I was like, it's fine, I'll put her down as late as possible, and then hopefully she'll do as much of the talk. And of course, like 2 seconds, literally 2 seconds before I have to try to zoom, she wakes up, screams, and is hungry. I'm like, really? Like
that's the way it goes, right? So yeah, well, thank you so much for a wonderful presentation. Where can folks find you? Will you be able, after we feed little someone over there, will you be hanging out in the Discord if people have questions for you?
Yep, I'm in the Discord 24/7, not going anywhere.
Okay.
I'm also on Twitter. You can try to follow me. I make no guarantees because I do follow random people, but my account is also private and I drink and then just pick people at random. I also have a GitHub where I just recently dropped some Windows stuff, which apparently someone out there is compiling and posting to VirusTotal about 2 days after I post it. But yeah, I'm around. Come find me.
Awesome. Well, thank you so much, Virus. If you've got any questions for Virus, please ask him in the Discord channel, and he's giving you some more information about where you can find him online. And thank you again for presenting.
Bye-bye.
So at this point, the CTF is open. If everybody wants to hop in there, we've got another talk coming up at it looks like 11:30 with F Prime, all about Metasploit. So if you want to join us for that, for now we're going to go into intermission, and we'll see you back at 11:30. Hey, welcome, and thank you for joining us for Go Gadget Metasploit, presented by F Prime. F Prime is an AppSec engineer and penetration tester in the LA area. In this presentation, they'll be talking about how to create a Go program and Metasploit to automatically drive your findings to a shell. Please give a warm ShellCon welcome to F Prime.
Thanks, everybody. Thanks for having me. As you can see, the Inspector Gadgeting is intensifying. So yes, this is Go Gadget Metasploit because it's in Go and it's about Metasploit and Inspector Gadget. Why not? By the way, if you know who this is, it's time to take the medicine for your back. I know because I'm old enough. So, who am I? This is my icon on Twitter. I look a little different in real life, I will admit. I'm an AppSec engineer for a local healthcare company who know that I'm here, but I'm not going to shout out because I didn't want to get this whole talk passed through Marcom. I'm also a senior AppSec engineer and penetration tester for Escape Inc. Shout out to Escape Inc. We're hosting the network for a lot of the stuff for the conference. My hobbies, I love programming. I'm a huge MMO and Souls game gamer. Love cyberpunk stuff. Love learning. As you can tell, I spelled gamer the correct way. Also, disclosure, even though I have shirts on that say "Be gay, do crime," please don't actually do crime. So there we go. Okay, so what are we doing today? We're going to be covering the Metasploit RPC API. This allows you to control Metasploit framework, the exploitation framework from a program, right? We're going to be going through the Go client that I created, and then I'm going to go through a sample augmented program with a little demo. Should be fun. So the Metasploit RPC API. So as I was saying, it allows you to control the Metasploit framework from code. So, anything you want to tell the framework to do as if you're typing it into the console itself, you could do through code, fully automated. It uses message pack over HTTP or HTTPS. Message pack is a binary encoding format, kind of like protocol buffer. I had never heard of it. Luckily, there's already been somebody else that, has created a message pack marshal and unmarshaler in Go. Thank God. So I didn't have to do that part. Here's a brief little blurb about it. They kind of go through, you could use all these other languages to do the RPC API. Now you can do Go. So before I go into the code itself, I want to go through kind of the method groups, right? So there's 7 different groups ranging from authorization to core functions, reading and writing stuff from the console, typing in show options, or whatever, listing jobs, gathering info on current running jobs, that type of stuff. The big one is module. So any module within Metasploit, exploits, auxiliary modules, post-exploitation modules, all of those can be controlled through this. Loading and unloading plugins. I know that some corporations may use plugins, so you guys are covered there. And then interacting with sessions, like after you get a shell, right, and you celebrate and you say, "I'm in," all hacker-like, you've got to interact with it. So that's all in there. So you might be asking yourself, but wait. I'm not a real hacker unless it's hoodies up, and I'm typing 1,000,000 miles a minute and I'm going, well, kind of like this. I don't know. I mean, he doesn't have a hoodie, so maybe he's just a regular person. Anyway, so how can this help me, right? So, big thing is automation. You can automate all of your interactions with Metasploit in code and can control it based off of the feedback that you're getting. Then there's session reporting, how many shells do I have, that type of stuff. You can also technically call MSF encode from the API and give it a program and it can encode that using one of the encoders. I kind of put a question mark at the end of it because I'm like, I could probably see a use for it. It's there, but I didn't really do anything for that for this talk. Okay, so we have the RPC client. Huge, gigantic shout out to Wyatt Dollenberg. He started this project. He did the authenticate, like a couple of methods in the authentication area, and like I think 1 or 2 like session methods and everything, and kind of gave like a good baseline of working with this in Go. So I basically kind of took that and ran with it literally. I'm just kidding, I don't run. So allows any Go based program to interface with Metasploit, right? So I also include a sample client that I'll show you in a second. And then all of the portions of the API are completely implemented. I've unit tested all of them. I don't know how hard they're going to stand up in like a production environment, so your mileage may vary. But they at least like were able to be called and return data, so everything is working. The API methodology so far for the Go heads in the room is everything lives under one package or namespace. Each RPC method has its own calling method. It has its own request structure, its own response structure, and you can get a new RPC client by calling rpc.new. So and in doing so, you pass it the protocol, the host name, so HTTP, HTTPS, and the port number, and that's it. The rest of the whole URL I've got taken care of for you. So here's a sample client. Here's one of the things that you can kind of do with it. So you'll see I gathered up the host name, username, password from environment variables that I had running, create a new RPC client, and told it give me the version, and then also do a module encode of just AAAA in Python. And so when you run this, you get, okay, this is the version of the API that you're connected to, and this is the MSF encoded version of what you just gave me, written back out to you in Python. Cool, great. So are we ready for a sample program? I mean, that was kind of a sample program, but not the real one. I mean, come on, this is ShellCon. We gotta go big. So we're gonna see it. Okay, so I took Nuclei, right? So the Nuclei from Project Discovery is a Go-based, template-based vulnerability scanner. So you take YAML templates and you say, okay, these are the things I want to test for. If the server responds in this way, it's vulnerable. Okay, so I took that and I tweaked it a little bit, tiny bit. But you might be asking yourself, wait. If this is a vuln scanner, and we're talking about automating Metasploit, this is probably your face right now. Oh, okay. Yeah, so I augmented the template engine to take Metasploit RPC API commands. So what we're ending up doing is checking for the vulnerability and then running Metasploit commands if the thing is truly vulnerable. To actually just launch an attack as we scan. By the way, it's really sloppy. I'm planning on cleaning it up, but this is to get stuff ready for the talk and to give you guys a nice demo. So bit janky, but it works. So here's one of the sample templates that I created. This is for the WinRM script exploit within the Metasploitable VM suite. And basically you can see here that if this thing gets ran as a sub module or a sub template, excuse me, then I execute an exploit module of WinRM, exec on the host name that I'm scanning already. Here's his port number, all the different stuff. And then I run a second command within session to get to run a single interpreter command of just get system. Right, so this is going to escalate my privileges. And then the last thing I do is I run an exploit, or run a module, excuse me, to do a hash dump. So, I have a full attack right here, and it'll only run if the system turns out to be vulnerable. So are we ready for a demo? This was creepy. I apologize. But are we ready for a demo? I mean, it's Inspector Gadget. I had to go with it. And he does look thirsty for a demo. So if I go ahead and embiggen this and it gets cleared up, I went ahead and recorded this just because I didn't want the demo gods to smite me. So I go ahead and this is my auto template. Basically, I run several detection scripts to see if the server is vulnerable to certain different exploits. Some of these are true, some of these are not. And then basically I run my version of Nuclei, and I have Metasploit over here running on the right hand side. So now past me will go through the same explanation. So go ahead and launch this. Oh, we've got some gay bombs being launched here. Hold on. Okay, so these are for all of the vulnerabilities that we detected using the detection templates up here. So now these exploits are running in the background. Metasploit is, kind of firing these things off. You guys have probably seen it. Sometimes they take time. Oh, I got to load up, a stager and all this other stuff. So I have, shells are raining in. Oh, sweet. Okay. So then I've got 2 shells out of 3 so far. One of them's already found that it's going to go ahead and enumerate the services. So we got that going on. So that's another post-exploitation thing that says, okay, if you get a session out of this, out of this attack, go ahead and start running post-exploitation stuff. Just give me all the data that I want, and so then I run interpreter get system, and then I do a hash dump. And unfortunately, I didn't get a chance to fix the whole results thing. So it says better luck next time. Don't worry, we have all the luck in the world, because as you could see, the hash dump is actually running. We did enumerate all of the services. They're now in our loot table. Hash dump is still running. Gotta give it a second. Now it's done. And whenever I go to creds, I now have all the creds in the world. So without doing anything other than doing a vulnerability scan, I have hacked into basically every vulnerable service on this server. And, I've even escalated my privileges and started dumping creds without touching the keyboard. So yeah, that's the talk. So I'm planning on, kind of keeping with the nuclei kind of augmentation. I'm not sure if the project discovery team is going to want to roll that into the core version of it. I don't know if that's necessarily their their vision of what they want their project to be. So, in the meantime, we'll just keep it separate. The API client is here at my GitHub. You can follow me on Twitter down here at the bottom. I also stream some of my games sometimes at twitch.tv/John Cutesack. Yes, that is my name. Yeah, if there's any questions, comments, concerns, I guess I should look in the main Chalks chat.
I took a look. I don't see anything coming up, but I do see people typing. So maybe we've got some questions that will roll in.
Yeah, that's me, by the way, just kind of blowing up into a balloon and just flying out for work that day.
Excellent.
Great talk, better Twitch thing. You know what? I agree.
Let's back up to that pain medicine comment.
Yeah. Sorry, Bod. You're probably around my age, so yeah.
Yeah, not seeing much, just a lot of heckling. But
I did invite people to do that, so okay. I'm glad that I'm glad that the heckling is happening.
Can you explain more about using, I think we're missing a word here, as a vuln scanner?
Oh yeah, so So nuclei is basically it takes several templates. Let's see. We can probably try to do this live. Okay, so let me pull up a sample template for you guys. So let's do WAF detect. So let me embiggen this a little bit here. So this is what a nuclei template like originally looks like. It takes this is for HTTP requests, and it just does a raw request to try to submit some XSS payload, and then you use matchers to say, okay, if any or all of these conditions are true, then this whole template returns true. So that answered your question, Linux girl. I have the link to their GitHub is at the top of these slides. So yeah, it's from Project Discovery.
Let's see. Once you own them, then what? Profit, of course. Let's see. Does your template
Oh, yeah.
automatically convert Unicode DNS entries to Punicode? I don't know. And back again for my Gopher targets.
Yes, Wu-Tang. Absolutely. I totally understand what you're asking, and it does do that. Even though in truth I have no idea what you're asking.
Just say yes and go
yes,
for it.
Exactly.
Yes.
I've gone into salesman mode at this point of the talk, so yes, it does do that.
Mm-hmm.
And we'll find engineers to make that happen.
It'll be extra though.
Exactly.
Yeah.
Exactly.
Yeah,
That'll be the premium model. But yeah.
Okay. Well, I don't see anything else going on in here. That was a great talk. Everybody loves you. There's some questions about what the F stands for, but I don't think we need to do that live.
Just go look at my Twitter handle. You'll know.
Oh, somebody's gonna
really old.
dozen.
It's a really old name. I'll buy a dozen. Okay.
Does your code sync with the Zune?
Oh, absolutely. That's the only MP3 player that I know of. It was Walkman, then Zune, and then nothing else. Did anything else even come out? I don't think so.
No, it's not important if it did.
No.
Oh, definitely time for the pain medication now.
Yeah, thank you guys so much. Thank you to ShellCon. Thanks for thanks to all the other hackers that have helped me over the years. Kind of get to where I am. And then thanks for having me.
Thanks for being here. It was a lot of fun, great talk, and awesome projects that you got going on there. So with that said, again, the CTF is open for ShellCon 2021. There's a bunch of great talks. Yeah, there's a bunch of great talks going on in the Raise Me, or did I get that right? I probably didn't. What's it called? Somebody help me. Raise Me. I think it's the Raise Me channel that's got opportunities for resume reviews, different consultations. If you're interested in learning about different career paths in cybersecurity, that's the place to go check it out. Lock picking village is popping, is what I was going to try to say there. I see a lot of activity ahead over that direction. And a huge thank you to our sponsors for ShellCon. Let me go ahead and click on that link and I'll tell you who they are. We've got Teleport is our gold sponsor. Thank you so much. We've got our Pearl sponsors, Bad to Beef and SkySafe. Supporting sponsors, I'm gonna butcher this, but we'll give it a try. Ice Tray Normal, and of course, No Starch Press, Pentester Lab, Xscape Inc., and another sponsor of Linux Expo of Southern California. And if you're interested in sponsoring for next year, there is some information you can grab on the ShellCon website, which is at shellcon.io. Outside of that, I think we've got another talk coming up at the top of the hour, and I'll be back on to give them a warm introduction. And until then, see you again soon.
Samurai sword on my back. You don't know how to act. Maybe you should relax. Maybe you should relapse. Just kidding. Stop, 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 stop. Stop, 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 stop. Stop, 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 stop. Stop, 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 stop. Stop, 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 stop. Stop, 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 stop. Stop.
Welcome back to ShellCon 2021. We're here with Klaus Agnelletti, who is the head of community at CrowdSec. Today, they'll be discussing how they plan to engage the community to encourage the use of a free open source tool to leverage the power of the crowd to fight back against cyber criminals. And again, if you've got any questions for Klaus, please ask them in the main talk questions channel in the ShellCon 2021 Discord server and tag them with #ask so we know to ask Klaus at the end of his talk. Welcome, Klaus. Take it away.
Thank you. Yeah, as Tabata said, I'm head of community at CrowdSec. Kind of funny because 2 weeks ago I was just a community manager, but you know that's how companies work, right? I've been an InfoSec professional for close to 20 years. I've been actively involved in my local InfoSec community for almost that long. I want to talk about what I think is wrong with blue teaming today and how I think it should be done differently. And then I'll tell you about how we created CrowdSec, which is a free and open source threat intelligence tool. And the thing with crowdsourced things is that crowdsourced application is that the more users, the better the experience and the better it works for everyone. So basically what I'm trying to say is that I stand here today to inspire you guys and girls out there to see if CrowdSec could be anything you wanted to invest your time in. And since this is open source, it's really important for us to have a community that is engaged in the tool and the project. So how I plan to do that is to do a technical deep dive into the way it works, the inner workings of CrowdSec, because the thing is that it's kind of hard to get your head around, or to wrap your head around how it works, because the possibilities are rather big. So I plan to do that with examples. Both of what you can do now and what is possible in the future somehow. So I just want to share the perspective and our hope in that. We want close contact with the community because we believe that's how the best software is being made. So as I said, I want to inspire. Let's see if I succeed. First, I'll start with an overview of and start of the problem. Start to talk about the problem that sort of inspired us to start this project, and then afterwards we'll get down and dirty with the details. First of all, cybersecurity. This is a bold statement, I know, but cybersecurity, that's not complicated. That's not a complicated problem, because complicated, that is what one person can do, given that you have enough time, and it's of course that it's the right, genius person who can do that. So unlike something like Einstein's theory of relativity, which is complicated, cybersecurity is not that. Another problem that's complicated, that's like creating a COVID-19 vaccine. That showed us that if you put enough money into that problem, it could be done in no time, really. So, as I said before, this is not cybersecurity. But cybersecurity, on the other hand, is a complex problem. And complex, that's a problem that can be solved if you work as a team and together. And it's not easy. But the point is that we shouldn't treat cybersecurity as a complex problem that can be solved if you throw enough money at it, because it doesn't work. The thing with cybersecurity is that money doesn't solve all problems, and yet we've been doing that for so long. and never actually realized that it was a wrong approach. And why do I say that? That's because, well, let me show you the numbers here on my screen. For example, JP Morgan, they at least at the time of their breach, they had a security budget at around $800,000 a year. That's almost a billion US. That's so much money that, you know, I don't know about you, but I can't imagine how much money it is. And yet it didn't prevent any breach. So as I said, this has nothing to do with resources. The approach is just wrong. So instead of talking about how we shouldn't solve it, I want to talk about how we do solve it. So we suggest another approach, and that approach is simply outnumbering, because we are more people than the criminals, all of us. That is what we could call a hive approach, right? Because nobody wants to fight a beehive. Everybody would run away. So how do we do this in practice? Well, what we have built here is what we call the ways of cybersecurity, because the way ways work and the way we work is by sharing data with the rest of the world. So the way CrowdStrike works is that it passes your log and it identifies attack patterns and it blocks traffic based on those attack patterns, and then it sends all of the anonymized data it sends all the data that it has collected during the attack back to everybody else. And basically that's how it works. And as we're saying, is that cyber criminals has had it too easy for too long. So we want to shift the balance of power so that the hacker changes the tactics, or even better, go somewhere else. So as the way it works, the thing with CrowdStrike is that ultimately it's inspired by fail to ban. But in that we wanted to make a modern version of fail to ban with this crowd-based approach. And what we ended up with was something that was which was much more versatile than fail to ban is. And I'll talk about that later. And as I said, first logs are added, relevant block lists are received from the community, and the CrowdStrike agent detects those threats, and then the bouncer, which is the second part of the software, remediates traffic based on that threat intelligence, and that can be done either on the firewall level, the application, the level 3, or on the application layer on layer 7, and then after that, the information about those attacks are shared back with the community. And basically, what CrowdStrike can do is the same as fail to ban, which is protecting a service. But at least in theory, that's what CrowdStrike can do. But CrowdStrike is a relatively young product, so a lot of passes and scenarios are missing, but that will come over time. But basically, CrowdStrike can handle anything that can be described in a YAML file and passed with grok. And there is an advanced decision engine that takes decisions based on everything what's going on. So it can be used to fight against DDoS on application layer on layer 7. It can also be used to fight resource abuse, like for instance, if you're mass crawling. If your web server is being mass crawled, then CrowdStrike can block those exhaustive crawlings. And also, another thing it can do is that it can block an entire IP class if just 5 of those IPs are already blocked, then the rest will be blocked by default, and much more. And I'll show you the details in a bit. And the thing with the threat intelligence that CrowdStrike collects is that it's real. It's more real than threat intelligence collected by honeypots. So yeah, basically that makes us believe that at least it's in theory a better quality of threat intelligence. And then as an extra bonus, or whatever you want to call it, it's free forever. Everything is open source under the MIT license, which means that it's free and it will be free forever. So that means that the code alone, it would be useless for anybody over time, maybe who would try to purchase a company behind CrowdSec, and would basically effectively prevent anyone from destroying the project that has started. So that means that the code alone is as I said, is useless. It's what provides the value here is the code and the community. So yeah, so that is also part of why the community is so dear to us. All the IP that are banned, they will stay banned for 72 hours, and then in the next slide I'll tell you a little bit about what we call the consensus engine, which is the engine that decides whether an IP should be banned or not. That is a relatively complex decision process, as you may imagine. The consensus engine bases the decision on a variety of things whenever it receives what we call a signal from a CrowdSec agent. It has something to do with how regular does this agent send signals, how consistent has it done so compared to other users' data, and when we correlate with data from other agents, is the IP then still banned or malevolent? And then we can also cross-check with a third-party provider. Yeah. Some may have concerns about privacy. We take privacy very serious. We only collect, or CrowdSec only collects what it absolutely has to collect, which is like an IP, obviously, and a random UID, so that every agent has this unique string, so it can be identified. And over time, the IP that's in our database that we don't think is malevolent, that is being degraded over time, meaning that after 3 months, we would round up the timestamp to 6 hours in this 6-hour time span, and then after 6 months, we'll also round up the IP to a /28 network instead. But that only counts for a non-malevolent IP. Everything that we have deemed malevolent, that won't degrade. Yeah, we're a young product. We aim to be 1 million installs in 2024 or 2025, and right now we're at 20,000. So there's a long way. And now is the more, I guess, interesting part, because as I said before, what I believe inspires this crowd and most InfoSec community crowds is if you go into details and you tell about or talk about how can this then be used, because all this crowdsourced stuff is all good and all that, but if it can't be used in real life, I mean, what is it worth? And given that CrowdSec is kind of weird to wrap your head around once you get to know it. So I'm trying to do something about that by talking about a number of different use cases and scenarios, hoping that you will find something that you find interesting, and so that you may want to try it out or may want to engage somehow in it. Sorry. the diagrams that I'm showing on my slides may not be readable for you. It's actually not the point for you to read them exactly. They're mostly there for illustration and for giving you sort of an overview. But all the drawings, they are from our doc site, which is doc.crowdsec.net. And there you could also find more detailed information about every component in CrowdSec. And speaking of the doc site, that is also open source, obviously. And it's in GitHub, and it's made with Adversarial. So if you want to contribute to that, if you find any errors, feel free to open an issue or submit a pull request. Yes. And this is sort of an architectural overview of CrowdSec and how it works. What you can see on the left, that is where the data sources enter the agent, and everything in CrowdSec is written in Go. So back to the data sources. Data sources, they enter the agent and they're passed, and after that they're being normalized and matched against scenarios. And currently we can accept data sources from files, from journald, from AWS CloudWatch, and from the syslog service. So whenever a triggered scenario triggers an, so whenever a scenario is fulfilled, so to speak, it triggers an alert, and the agent takes a decision based on that, and stores the information locally, and send information about it into our central API, which then will send it out to the rest of the clients if it's malevolent. We also have a CLI, which is used to communicate locally with the agent. And the local API is also used for notification. We can notify to Slack, to Splunk, and over HTTP to something like Elasticsearch, for instance. Then on top of that, we also have Prometheus for observability. So you can use Grafana or whatever you want to use. Bounces, as I said before, they block traffic. And we have a few there like WordPress, Cloudflare, Nginx, Firewall. And what is interesting here is that all of the blocks is communicating using the HTTP REST API. So everything can be fully distributed. Yeah. First, next up, I'll talk a little bit more about data source, because obviously CrowdSec passes log. So if you don't have any log, then we can't parse. So the more log we can parse, the better. And right now, as I said before, we support those 4 data sources, and only having 4 is actually quite a big limitation, as you can imagine, because the more the CrowdSec can read and understand, the more it can use, the more use it has. So if you find CrowdSec interesting, this is really a good place to contribute. So imagine if we could put data from Elastic, from Splunk, to CMS in general, from Azure, from Google Cloud, whatever, into CrowdSec, then it would be much more interesting. So literally the sky's the limit here. What's called one shot. Sorry, in the table, there is one shot basically means that this is a mechanism for processing code logs. This is good for reporting and then postmortems, and that is a useful but often missing in similar products. Agents, of course, agents is what you're running on the endpoint or the server or whatever that is going to have its log sent. So we support Linux, we support Debian plus derivatives, Red Hat plus derivatives, Amazon Linux too, or you can also just compile your own from the top all provided. FreeBSD is what we support now. We probably also support other BSDs, but we haven't tried it out. So feel free to do that and tell us how well it works or not. Docker. We have a Docker container that's useful with Docker Compose. Recently, we wrote an article on how to set up a little environment with the different with various services using Docker Compose, and you can find it on crowdsec.net/blog. Another relatively new platform we support is Kubernetes. We recently released the Helm chart, which then can be used to ensure that CrowdSec agents is running on all pods. OpenWRT is finished, but it's not yet released, and we have no idea when. Hopefully soon. Windows, that is being released in Q1 2022, and it will be a relatively minimal release, but over time it will grow to be a full-blown platform. So if you see anything is missing, such as a package for Slackware, for ArtLimit, for Unraid, or something completely different, maybe pfSense, OpenSense, Home Assistant, or your favorite open source project that needs exactly what CrowdSec can provide, feel free to tell us about it or contribute it yourself. You can get in touch with me, and my contact details are in the end of the slide set. The Linux version of the code compiles on a wide variety of ARM devices, so there are a lot of options for IoT that can be easily, or at least relatively easy, to export. For instance, as I said before, Home Assistant, and because that is often run on Raspberry Pi. This is almost the same overview as before, but you can see where we are using HTTP REST calls, and where process and scenarios are used, and I'll talk about those on the next slides. Collections, what we call collections, is bundles of parsers and scenarios, and they're constantly updated. They're easy to update, and that is really what is the brains of CrowdSec and intelligence. I'll talk more about those in details in the next slides. Parsers, they're YAML configs. They describe how a string should be parsed, and most parsers are grok, but it could also be expression for a specific data like JSON, but it could also be an external method for enrichment of data or whitelisting even. All scenarios, they're YAML. They detect a specific behavior. It's usually an attack. So the way it works is that we use what's called a leaky bucket, meaning that we're defining what is wrong behavior, and whenever that is being detected, it is being poured into the bucket. So whenever the bucket is not overflowing, nothing happens. But once it overflows, once too many failed attempts of something or whatever is put into the bucket and overflows, then a scenario is triggered, and then something happens. Observability, that's crucial, especially for function like blocking traffic, which CrowdSec usually does, at least the way it is now. And so we expose a Prometheus interface which can be used for Grafana, funky Grafana graphs, but also the CrowdSec CLI. It also uses some of the same metrics from Prometheus, actually. The CrowdSec log itself is also contextualized for easy parsing. And we also have a metadata dashboard that can be installed easily via Docker. And as a new thing, we have done a web console that's free to use, and I'll talk about that a little bit later. I even have a video of how it works. Next up, I'll show you some Prometheus and CS CLI examples. So what you can do with Prometheus is create cool graphs in Grafana, like, as I said before. This first one is an overview of the different attacks that's going on your servers right now, or wherever the CrowdStrike is installed. And the second one shows an overview of the log file that has been passed, and how many lines of each, etc. And this is some of the same data that's being exposed in the CS CLI instead. Yeah, the CS CLI it talks to the AD via the local API, and it's used for management and reporting. The backend is SQLite by default, but it could also be MySQL, MariaDB, PostgreSQL, or even Gremlin. And here are some of the stats that we saw before, exposed to Grafana. It's buckets and bucket stats and the log sources. But as I said before, the CLI can also be used for management. So installing or updating all those scenarios and the collections is as easy as just writing CLSI upgrade, and yeah, and it's all being updated. And unlike a project as fail to ban, all the scenarios and everything that makes the product or the software works better is being constantly updated. So yeah, so that is why you can actually update so easy. This is the web console that I'm talking about. It's new and funky, and I'll show you a quick video tour. So let's see if the video works and you can hear the sound. I hope that there will be some music over the video, so I won't say so much as it's playing. Yeah, so basically it's free, and it's been made available this week for everybody to use it. Over time, it will be possible to query any IP from the CrowdStrike database, so you can see whether it's malevolent or not, or at least what information we have gathered about that IP. As you may have remembered from the last time I was talking about, is that a new thing in the latest version of CrowdStrike is that we have notification plugins. So it's possible for CrowdStrike to report directly into a Slack channel or into a Splunk channel, and your Splunk database. We also have a generic HTTP notification push thing that can be used to make notifications directly into Elastic. And what has happened since we released that like a week ago is that one of our community users made a notification configuration so that Teams could be used, and not only that, he also thought of using Shodan to look up that IP so that metadata on that IP is sent along with the notification, and that is really cool. And what's even more cool is that another user saw that and decided to make a similar configuration for Telegram, also using that Shodan interface. So yeah, as a community focused, and especially for me, that was really great to see. It's very fantastic to see the community engagement that we are already having, and of course there are always room for more. I'll talk a little bit about the local API and the central API now. The local API is a core component which pushes alerts and decisions to the database locally. And that's also how the bouncer and the agent is talking together, so the bouncer can get information on blockings. And that is also what the CSCLI uses to view, add, and delete decisions, for instance. And the central API is being used by the local API to communicate with the central Hive mind, really, where it pushes signals data to the Hive, so to speak, and receive community block lists from the rest of the community. I'll talk a bit about the bouncers, because we have the firewall bouncer that can block that works with IP table, NF tables, PF, and also with the firewall in AWS or Google Cloud. We have an NGINX browser that blocks traffic via NGINX's Lua API. And then we have a custom bouncer, which basically only just as it triggers any custom script. So it's very flexible. I'll talk about an example later where it's being used to create a port scanner canary, a device that will react whenever it's being port scanned and send an alert. We also have a Cloudflare bouncer that can block traffic using the Cloudflare API. You can block traffic based on AS number, country, IP, and you can also force a user to go through a captcha rather than just block it. And then we have a WordPress bouncer, which is a WordPress plugin that can block traffic from attackers directly in WordPress. And can also challenge the user with using a captcha. And there's a generic PHP bouncer, which can protect any PHP site. Or you can make your own. We welcome, of course, bouncers from the community, and that is also written in Go. So this is actually the exciting part, because now we're talking about how CrowdSec can be used, because I'm relatively new in CrowdSec. I started a couple of months ago, and what I thought was really challenging is to understand what CrowdSec can do, because the options are so wide, really. So the way I thought was best to do it here is to talk about examples. And all of these examples are relatively simple, and they can be implemented right away. First of all, we can protect services like fail to ban. We're talking to a couple of hosting providers, large hosting providers that want to secure services on their hosting boxes with CrowdSec, so that the customer gets a better experience, and also it can secure insecure web applications. As I said before, you can set up a Raspberry Pi as a canary so that it reacts and port scans in your network. You can use it to secure your WordPress site, obviously, because by default, WordPress is pretty insecure. So that you can, and that means that our WordPress plugin, as it is, can detect attack patterns and also protect your WP admin, your backend interface, so that nobody can brute force this, for instance, which is pretty cool. And also, recently we released a generic PHP bouncer, which means that any PHP site like any CMS, PHP CMS, or that legacy PHP app that you just can't get rid of, you can secure it using the bouncer, and then the risk of it being attacked is much smaller. We just released an article about how you can use the PHP bouncer, and in that article we're using Drupal as an example of how you can use the bouncers both to provide a generic protection against it, but also to patch an insecure version of Drupal using a sort of virtual patching, as you could say. That's also quite interesting. Next up, I'll talk a little bit about more specifically about the possibilities that the advanced decision engine that's in CrowdSec can give you, because these are what you would say the easy examples. usually when I talk about CrowdSec, as I did today, I compare it to fail to ban, because that's easy for people to understand. But in reality, it doesn't do CrowdSec justice, because it's so much more. It's much more flexible. As you may remember, all the data sources, everything that comes in via the data sources is actually an object, and you can do any action on any object. And that object could be a user. And while we don't know exactly what has happened with Twitch leak this week yet, let's just assume for a minute that the data was leaked by stealing someone's credentials to an S3 bucket and abusing those to exfiltrate data. I'm not talking about CrowdSec as a silver bullet here, because we all know that silver bullets don't exist. But back to the scenario. I mean, you could via scenarios and parsers describe a scenario which is normal. And as I said before, one of the data sources that CrowdSec supports is AWS CloudTrail. And for those who don't know, CloudTrail is a user interface to all login within AWS. So basically, this means that CrowdSec is able to look at user behavior in AWS and define what is normal. And based on that, it's possible to detect what is not normal and react on that with for instance the AWS firewall bouncer, and then block that traffic. It's no way certain that this is at all relevant to the Twitch leak, but who knows? A similar use case that is how CrowdSec can detect and mitigate a layer 7 DDoS and Cloudflare by detecting unusual traffic to a Cloudflare-enabled e-commerce site. We wrote an article about that a couple of months ago, which is also available at crowdtech.net/blog. And similar as in this previous example with S3 and Twitch, we have defined what normal traffic to a website is. So in this case, we chose that we chose to pour IPs that has more than 2 connections to our website into the bucket. So once the bucket overflows and our scenario triggers, CrowdSec will start blocking traffic, but it will do it based on country and AS number first. And secondly, once those are blocked, it will block based on IP until that DDoS attack can no longer be seen by the website. And there are 2 cool things about that. First, blocking doesn't necessarily mean a hard block. Via the Cloudflare API, it's possible to force a user to go through a CAPTCHA, meaning that even though we can see a lot of attacks from a big country, it's still possible to for legit users from that country to access our website. They just have to go through a CAPTCHA. But that also means that bots will be blocked in no time. And the second cool thing is that in our example, we were able to kill a DDoS attack in 5 minutes. And the 2 of those minutes was internal lagging within the Cloudflare API from when you are ordering the API and ordering the firewall rules in the APIs until they're being implemented. It takes 2 minutes. So it's surprisingly effective, to be honest. Yeah. But what about the future? Here are a few examples of functionality that we are planning and will release soon, as well as some functionality that's only theoretically possible, at least for the time being. So I really want to inspire you today. So in the near future, we'll be focusing more on the integration of CrowdSec into a serverless architecture, and also write articles about how to do that in reality. Also, we want to help you fight against credentials and credit card stuffing and data theft in general. And we'll do that by creating scenarios and bouncers for various e-commerce systems. And it will be starting with Magento CMS. And in the near future, we also have plans to integrate Apache Mod Security with CrowdSec. And we want to do that because mod security is really, really cool, but it doesn't have contextual awareness. So by adding integration with CrowdSec, we can help CrowdSec to have, help mod security to have that contextual awareness. And what that gives you is actually a WAF-like web application firewall like functionality, simply making both products better. A little bit further out in the future, we have plans on giving some of that threat intelligence back to the community with the console or via separate service. So accessing the threat intelligence with via the web console, that will be available in Q1 next year, while the separate access to the threat data that has not yet been discussed, but and not yet completely planned. But one of the ideas with it is with this API is also that it should somehow be leveraged to make CrowdSec a part of your SOC team's trialing process somehow by putting the data into MISP or whatever you're using. So if you remember my example with detection of unusual behavior in AWS from before, why stop there? Because the same could be done in Azure AD. I mean, once we get data sources, passes and bounces, which we don't have yet, or Google Cloud or somewhere else. The platform is there. It's literally just a matter of writing those data sources, passes, scenarios, and bouncers. So if you have great ideas, and even better if you want to contribute, please let me know. So I really hope that I was able to help you understand more about CrowdSec and that I have inspired you to try it out. So if I have inspired you to engage even more in our product and contribute code, docs, or anything else, that's fantastic. So if there are questions, it would be around now. Else,
thank you so much for that information. I've taken a look in the chat. We don't have any current questions right now. If you want to give us some more information about how we can contribute, if we're interested in doing so, that would be fantastic.
Yeah, but I mean, contributing, everything is in GitHub. Actually, as you can see on the slide, this is the link to our GitHub, where everything can be contributed with a pull request. It's as simple as that. And we are on various social media and forums. We have a discourse and a Jitter, and we're also on Reddit and on Twitter, and a lot of things, basically. And if there is any questions to me, or then you can write me an email there, or find me.
Awesome. Klaus, are you going to be in the Discord for a while? If anybody has any questions, they can reach you there.
Yeah, I'll hang out in the discourse for the rest of the conference. So if there's any questions or comments, good or bad, let me know.
Well, thank you so much for presenting today on CrowdSec. We really appreciate your contributions to ShellCon. And as of now, since we've got no more questions, we'll go ahead and do a little bit of housekeeping before our next talk at the top of the hour. And so once again, the CTF is running. If you haven't joined the CTF, if you're interested in doing that, now is a great time to get in and get those points before more people join and try to get to the top of the leaderboard there. We've also got a lot of talks going on, a lot of great talks going on in the Raise Me village. So if you're interested in powering up your career in cybersecurity, that's where you'd want to go. Get your resume reviewed. Here's some interesting talks about your career path. Maybe if you're new to InfoSec, this is a good way to get a foothold in and understand what your opportunities are. And if you're already in InfoSec but looking to kind of power up, also a great chance to talk to folks that are maybe a little bit further along in their career than you are, and get some feedback on maybe your next steps and some certs or training that you might want to be looking into. Of course, we've also got the lockpicking village if you want to check that out, as well as just general shenanigans happening in the Discord server. So if you're not in the Discord server, you want to join that in order to be able to ask questions of our speakers and join these various villages. And beyond that, we'll be back in about 15 minutes with our next talk. See you then.
This is a great time for snacks.
Check the mic and make sure it sound right, boys. It sound right, boys. It sound right, boys. It sound right, boy.
Welcome back to ShellCon 2021. Right now, we've got the pleasure to introduce Yash and Harini. Yash currently oversees the product security org at Twilio. He's been working in security for almost a decade, working in a variety of roles ranging from consulting to enterprise product security teams. Harini currently manages the product security team at Twilio. She's been in the AppSec space for 6 years, helping secure finance and retail orgs prior to joining the Twilio team. In their presentation, Security Metrics That Count, they will be talking about motivations, challenges, and processes taken to influence teams to move the needle forward on Twilio's security posture. It's now my pleasure to pass the mic to our wonderful speakers.
Thank you. Welcome, everyone. Welcome to our talk, Security Metrics That Count. We've been working over the past year or so on making our metrics better and sort of working on how do we tell our security story right? And that is sort of the crux of the presentation today. The next slide is going to be an introduction slide, but Tabitha already did that for us, but I'll let Harini add anything else she wants to add on top of that.
No, I think everything was pretty much covered, just based out of Denver, Colorado, and that's the only additional piece of information.
Yeah. The other piece I lied about myself is I'm the person that's really, really good with Google Docs and Excel sheets and things like that. And I'm also good at taking credit for all the work that engineers actually do on the team. Cool. Now, with that out of the way, let's quickly go over the agenda. We'll talk about why do we need metrics, then talk about what kind of metrics can we use in the InfoSec world, then sort of give you some context on how we used to do metrics a little while ago, why that was frustrating and what we thought was missing in them. That would lead us to the designing of the new solution, the motivations, the thought process that went into it, and then the implementation, the tech stack, the output, and all of that. And then sort of, did it win? Did this work? Did this not work? What went right? What we're going to improve on? And then sort of the future work that will go into this. And at the end, we'll have a good chunk of time for Q&A. Cool. Why do you need metrics? Metrics is generally something that every executive is looking for. But in the security world, metrics is really important because security is not tangible. You can't say good security or bad security and like zeros and ones. So metrics is sort of the de facto way where you could quantify what you're doing. You could quantify the security posture of your company, how it has grown over the past couple of years or over time. You could also quantify the capabilities you have, how they've changed, what you've added, what you've removed, how left you have moved in the SDLC process. And all of this sort of helps you tell a security story and sort of helps identify the gaps, which eventually leads to good arguments for why do you need the extra resources for headcount or software and so on. Now, what metrics can security provide? So with security, you could broadly divide it into different pillars, right? AppSec, CloudSec, and things like that. So metrics can also be divided on that level. So on the application security front, you could talk about your dependency security. How current are your dependencies in code? How many outdated or unmanaged dependencies do you use? What's the coverage for SAST and DAST? How many P1s or P2s do you have pending in your code security posture? If you're building containers and Kubernetes, then you could talk about, are all the containers being built based on a single base image or not? The percentage of containers that are not being scanned, and so on and so forth. Similarly, on the patch management side, you could talk about the ratio of systems with patches to without patches. You could talk about the metrics of hosts that are not on the latest AMI that you've provided. Next slide, please. And similarly, on cloud security, you could talk about the IPs that have been exposed to the internet, the trends of ALBs with or without WAFs. And on enterprise security, you could talk about laptops with EDR agents, without EDR agents. Is that number or ratio going up or down? Similarly, you could talk about operating system updates being applied or not, and use those metrics to basically drive the needle in the right direction for the security posture of your company. Cool. Now, I would like to give some context on how we do things at Twilio. And I feel that's important so that some of the terminologies that we use later on and some of the reasonings for why we have done things a certain way would be much more clear. So we have DevSecOps tools, SAST, DAST, container scanning, secret scanning, SCA, all of those good stuff. They are baked into our CI/CD pipeline. And all the results are filed in the engineering team's Jira queue. Jira is our ticketing system. And we also do manual reviews. Manual reviews like threat models, pen test, manual code reviews are ticketed in our, that is the product security team's queue. Think of it more like the task ticket, and all the findings are ticketed in the engineering team's queue as well. Same goes for bug bounty results, which go into the team's queue. So on a very high level, what I would like to point out is every task that we perform has a ticket in our queue. And all the results or the action items or vulnerabilities that come out of that task are filed as vulnerability tickets in the engineering team's Jira queue. We believe that it is easier to take action items and file them as tickets in the team's queue versus a separate queue, which they then have to monitor. It's just one way of doing vulnerability management. The other thing I'll point out is Twilio has the concept of business units. So a lot of the metrics that we talk about are kind of split across BUs or business units. You don't need to have BUs to sort of do something like this. You could replace BUs with products or features or anything you really want, which is sort of a tangible differentiator in your company's taxonomy. Cool. How did we do metrics before the automation we built? It was manual. We used to get an email from the office of the CISO every month. I was one of those who needed another reminder on that. With that reminder and maybe an annoyed Slack message, I would then dig out the Google Sheet, which had the metrics data, grudgingly go to every freaking tool that the team had, get the data, go back to Jira, get the data, combine those two sets of data, make sure they're in the time frame that we're looking for, then go add them into the G Sheet, make sure if there are any comments, I reply to those comments and why there's a dip or there's a spike, and then reply back to the original email saying, hey, the metrics are in there. And then I would just be miserable. Now, as much as that sounds fun, I didn't really want to do that. And we started talking about what was missing in the way of doing metrics. There wasn't any automation piece to it. It was super manual. And it wasn't ideal because we almost take pride in the fact that we are an automation-first security team in that sense. So doing metrics without automation was kind of contradicting ourselves. And the visualization wasn't that great. We had an Excel sheet with numbers, but we could do better in terms of visualization. There wasn't real-time data or even near real-time data. The data could have been 30 days old because we used to give these numbers every 30 days. So I could give those numbers today, and a week later, if someone was having a conversation based on that data, it could be stale. We didn't have customizability. We just had one set of data, and we could either make it super high level or super granular, but we didn't have the freedom to sort of customize and give different metrics to different customers in that sense. We didn't have RBAC. It could be a screenshot of a Excel sheet or the Excel sheet with Excel permissions, but it was hard to do that. And let's face it, Excel metrics aren't really that cool. And if we had a CFP for ShellCon saying, hey, we're going to talk about metrics in Excel, we wouldn't be speaking right now. And we also had a bunch of questions that were coming our way, which we really didn't have answers to. As an example, the CISO would come to us and say, hey, do you have scary data for me to go use as leverage with the board and get more resources? We didn't have an answer. The E team would ask, what do you think is the security posture of the different BUs? Who do I need to go talk to and tell them to do security better? We had company-wide sort of security metrics, but it was really hard for a company our size to sort of take action on such broad metrics. And engineering managers would come and say, good data, but how do I action on these? Can you give me more granular ways where I could look at data and from that go into the actual meaty information of the vulnerability that needs to be fixed? And product managers also had questions of, cool, we have 10 issues. Where can I see in this metric about prioritization? What should I work first? What should I leave for later? We didn't really have answers for all of those. Now, as I already said, I'm the one who takes credit for all the work others do. So I went to the team and said, look, we need to change this. Let's make this better, and then I'll take credit for it. And then Harini is going to walk all of you through what we did and the journey we went through.
Thanks, Yash. So we had this problem in hand and we had a bunch of unanswered questions with us. One of the first steps that we wanted to take before even solving the problem was identifying the requirements for the metrics that we were. The first requirement that we had was the leadership wanted a metrics dashboard, which not only would give them this 10,000-foot overview of the security posture across all business units within Twilio, but the metrics dashboard should also have the capability to show them what are some of the focus areas that teams should know about, and what are some of the areas that teams are lagging in terms of security. The second and sort of the key core component of our requirement for this new solution that we were building was to make sure the metrics that we were building was something that was easily consumable, something that was simple, something that told the executives, something that told leadership what action they should take based on the data that they were looking at. So some of the requirements that came out of that question was, what are some of the open vulnerabilities that are out of SLA within a business unit? And what does that trend look like in terms of all the vulnerabilities across all business units and also within business units? How many open like criticals or blocker severity issues are out there with all these business units that have not been addressed on time, still open for a longer period of time? And where are these vulnerabilities coming from? We started off with specific sources specific to product security. And some of the sources specific to product security essentially was all the capabilities that we as product security team supported. Capabilities that Yash covered, where he spoke about all the DevSecOps tooling tickets for us, all the manual work in terms of threat models, bug bounty, and all different sources that used to file tickets to different teams. Teams and leadership definitely did not want a solution where they had to go to another application or another tool to log in to view this metrics. They wanted a solution which was going to be very easy for them to embed in their engineering workflow. And one of the primary workflows, one of the primary applications that engineering teams here at Twilio use is Confluence. So they wanted something that could go with Confluence and make it easier in a sense that when they do planning, they can just pull it up and make sure security issues are looked at and prioritized the right way. When this was a requirement that came to us, we asked ourselves, if we are going to have this capability extended such that folks can introduce or embed these metrics within their workflow, how do we ensure we have some sort of control over the data that we are sharing? We didn't want engineering teams to actually change the metrics or have the capability to even like modify some of the things around the dashboard. We wanted to have that level of control to say only security teams had the capability to edit metrics or add to it, and engineering teams just consume that and work with us and provided feedback on what we are sharing with them. As we started solving this, we as product security took this initiative to solve it, but the idea was to have a metrics dashboard which data not just from product security, but from all different multiple teams within security space. So our solution had to be built out such that it was extensible and any security team was able to give us that data, or they themselves could just take that data source that they have and plug it into the metrics dashboard that we had built out. And the other thing we wanted to make sure was, because we had different audience and requirements come from different audience, from executives all the way up to project managers, we wanted to be able to have a solution that was flexible enough, which could create metrics catered to specific audience. And finally, just to reiterate, the theme that we had was to definitely keep it simple. We did not want to overcomplicate things, and we wanted to build a solution that was going to be easy to maintain from a product security standpoint. And the solution was also going to give the best results out to all the leadership that are looking at. So before we went on to implementing the actual solution, we had to do some groundwork. We had data just all over the place, even though our Jira was our source of data, where we got all the data information from. Even within Jira, we did not have the mapping to say which project belonged to which business unit and how that business unit tied all the way up to a team. So we first worked on getting all that information together and coming up with a way to say how we map all the projects within Jira all the way up to the business units. The second thing that we did was we set our baseline for our vulnerability ticketing process. So the process that we used to have before had used the concept of labels, where we had labels created for all different vulnerability sources as we filed tickets to teams. What we soon realized was with all these labels with Jira, it was the most messiest thing we got ourselves into, because labels in Jira is case sensitive. So we saw that for one, we had like 6 different labels at a point where, because of different casing, spacing, hyphenated words, all of that contributed to that factor. So what we decided was to sort of clean all this up and come up with a baseline for how we file tickets to teams. And as part of that process, what we did was we worked with the Jira team to come up with a specific format for vulnerability ticket types. So when we came up with the intention was to get rid of labels and move all of that concept into customized fields within the ticket itself. So we had multiple custom fields. What was the source of the vulnerability? What was the category of vulnerability? What was the business unit the specific vulnerability has to tie it back to? The vulnerability category was another key piece of information that we needed, which we are planning to use eventually to sort of get metrics around what classes of vulnerabilities exist within Twilio. So all of this data is what we needed, and we used the baseline to get all of this sorted out initially. And then finally, given that we had the old tickets with some of those tickets with labels, we had the new way of ticketing where we followed the right process, we had to make sure all the data was correlated and collated into this metrics that we were going to present. So we made sure we upskilled our JQL skills. JQL is the Jira query language, for those of you who are not familiar, and we made sure that all the data that had to go into the metrics were being collected in the right way. Moving on to the implementation. So like we mentioned, Jira is a issue tracking system. What we did was we wrote a Python automation that collected all of this data from Jira. And within the automation, we did a bunch of normalization of the data before even writing this data to Google Sheets. For those of you thinking why we still went back to Google Sheets, with Google Sheets, all we did was just write the data and use it as a data source. But the actual metric itself and for all of the information that we shared, Google Data Studio was our source. So we fed this information from Google Sheet and into the Google Data Studio and created multiple dashboards that team could use. And the reason we picked this stack was Python was something that the team was familiar with, and we had expertise in that. So we just went with Python, and we went with Google Sheet. It was a very lightweight and easy integration into Google Data Studio. And the reason we picked Google Data Studio of all the tools out there was because of a few factors. Google Data Studio is part of the G Suite package, which means it comes automatically for us for free. We didn't have to pay for any additional tool to come up with these metrics and figure out what is the process to integrate into those new tools that we bring in. And Google Data Studio definitely has a rich amount of features that we could use to build dashboards and show the data that we wanted to show. So now on to the fun part of doing a live demo and showing you what exactly this end-to-end implementation of. Well, I don't trust the demo gods, so I went with a live-ish demo. Yash definitely wanted me to have a live demo, but I didn't want to take the chance today. So I'll just play a short video here and walk you through the process of how we have this implemented. So just for an example, all of this data here is mocked up, and we have both the Google Sheet, mocked up Google Sheet, the Google Data Studio links set all the way to the end of this presentation. We'll be able to share that, and you'll be able to just make a copy of it and play around the data to just get a hang of what sort of metrics and looks like and how you can just build dashboards out of Google Data Studio. Awesome. So our automation based on Python, like I said, got all the data from Jira, and this automation was essentially a cron job that we ran the hour. So we were able to produce near real-time metrics because this job made sure that the information that we collected was all up to date within that period of hour. And whoever was able to take a look at the data within that time, they got almost near real-time metrics that they wanted to look at. So the automation runs and it actually adds the data to the Google Sheet. The way we structured our Google Sheet was, like I mentioned previously, we wanted some key pieces of information for all the requirements that we had to build the solution out. So one of it was the business unit information mapping that tied back to all the different Jira projects. So we collect that information, and within the automation, we load some logic to make that mapping and correlation as well. We also wanted information about all the open tickets within different teams' queue. What was the severity associated with it? What was the source and category that that specific ticket belonged to, when it was created, and information around the number of days it was old for, and the main data, which was out of SLA. So we wanted to show teams how many tickets were out of SLA for them, specifically how many P1 and P2 tickets were out of SLAs. And one last piece of information is actually the Jira ticket link that we added to the Google Sheet. So just pausing the video here for a bit. This is what metrics dashboard sort of looks like. Google Sheet has this, Google Data Studio has this cool feature where you could create multiple sheets within the same report, which sort of helped us with the requirement to solve the requirement of catering to different audiences. So we have one Google Data Studio dashboard, and within that one Google Data Studio dashboard, we created multiple sheets, which has data that could cater to different audiences. So the information that you're looking at right now is sort of the initial metrics dashboard that we share with executives and leadership. And the information that we have on this dashboard is specifically talking about how many open P1 and P2 information, P1 and P2 vulnerabilities are present across all different business units. What does that breakdown look like in terms of P1 issues? Do we have any P1s that are greater, or any P1s that have been open for more than 90 days, or any P1s even open more than between 30 to 90 days? Because that's not what we want. But in an ideal world, that's not what we want, is all the issues to be closed, but that's not the case all the time. So that's why we wanted to track this and show this as a metric to leadership to say, there are issues that are out there which needs to be addressed right away, but some of them have not been addressed. So here's that count for what that looks like. And we also have the option to adding how many new P1s were created in that specific week. So this data also was to convey to the leadership that how many P1s happen across different Twilio products over a period of time. Moving on, the last part to this is actually the chart which talks about all vulnerabilities over time. The way we had this chart broken down is of combining all the data with across all the BUs and showing that out. But within this chart, we also had a feature where we could specifically scope it down to a business unit to understand what their vulnerabilities over a period of time actually look like. So here, just showing some examples around how we can do this filter within the chart internally itself. Now, moving on to the next page. This sort of page with our metrics dashboard essentially talks about our metrics breakdown by different sources. So like I mentioned, different sources for now, because we have built out of product security data, essentially just talks about all the different capabilities through which these tickets have been filed. So as you can see, we have, as an example, we have just scoped down to 4 different sources that we have grouped into. And between the 4 different sources, we just share information about what this distribution sort of looks like. The last aspect of this metrics dashboard is probably my favorite and the best part. So this is the piece where our requirements from the product managers, project managers, and engineering managers were trying to be solved. So the idea is They wanted something that gave them detailed information at a very micro level to see how many issues were there across their business units, how was it broken down, what are some of the open P1, P2, P3, and P4 issues, how many were violating SLAs, what sort of that severity distribution looks like for them. And just in general, they didn't want to go back and forth between the metrics dashboard and to Jira to just correlate this data. So to just bring everything into one place, we also have a table which just shows them all open issues and actually the link to the Jira tickets that could take them to the actual finding that they could use for various purposes and address the issue. So the other cool feature of this dashboard is the way we have a control set on this dashboard. We have set a control on this dashboard based on business units. So anybody can just filter which business unit they want to look for. And based on the filter, they'll be able to just see the entire distribution of vulnerabilities based on that specific business unit. And like Yash mentioned, most of our products and our taxonomy revolves around business unit. So that's why we have this concept. This could be customized to whatever works best for how or when you design metrics for your application. And to just give a quick overview of what this looks like in the studio when you actually look at implementing these charts. So when we get this information from Google Sheet, the idea is to spend as much or spend as little as time within the Google Sheets itself to make any changes and leverage the power of Google Data Studio where we could create filters, custom fields, and a bunch of different things. So just to give you an idea of what I was talking about, filtering business units. So if you just see the business unit was created as a control filter. And if you just look at the table that we have down there, it's just table with different dimensions that will help teams make different decisions. We also have the capability, like I mentioned, within Google to create your custom fields. And when you create these fields, it's just taking some of the data from Google Sheets, with the formula for whatever information that you want to share, and then just creating a field out of it, which could be used to just present different information. That being said, one of the last requirements that we had was definitely to make sure the teams had the ability to embed this dashboard within their Confluence pages. So for solving that problem, Google Data Studio has a pretty neat solution. You could just use the option within the Google Data Studio where you can just say embed this report either as a code, as a HTML code, or you can embed this report based on just the URL that you have. So once you get that information, you can just go to Confluence. Confluence it's like our major workflows that we use. So we sort of use that as an example here. And within Confluence, you'll have multiple plugins which are available. Some of them are available by default, which you could use to basically add some of HTML content. And what you're seeing right now is that part where we add that content and the actual data reflects back in the Confluence page itself. This solved their problem of not having to go to multiple places, but they could have their own wiki space or Confluence space for their teams or organization or business units, and they could just embed this report there. So anybody within the team could take a look at this data. The other cool thing with this is the embedded report is also highly interactive. So the same filters that you would do on the Google Data Studio was applicable down to the Confluence embedded report as well. And one last part of the requirement was definitely how do we restrict this access for this? How do we make sure it's only the security team editing these dashboards or working on these dashboards and everybody else is just consuming this data? So we leveraged, again, Google's existing features to share with multiple people. What we did was we locked down the report essentially just to be able to share with write access to the security team. And using manage access, we just shared this report as a view-only option for teams outside of security. That being said, that's what our implementation looks like today. We do have plans to do more stuff to this, and I'll let Yash talk more about what worked with this, what didn't, and plans we have in the future for metrics.
Thanks, Hari. Now, this new process of metrics made my life definitely easier, but that wasn't the goal. The goal was to make metrics much more quantifiable, much more interactive, and easy to use for the consumers. So let's see some things that were a result of the new metrics. So the executives really liked it. The C-level wanted sort of information on the breakdown per business unit, and more than that, they wanted a trend over time to see if the vulnerabilities were reducing or not. Now, realistically, you can never get vulnerabilities down to zero. So it's never a 0 or 1 comparison. What you're looking for is, are the vulnerabilities going down over time? Are our capabilities of security tooling going up over time? So that kind of tells the story that the security posture of the company is moving in the right direction. And that message was clear with these metrics. So that was a win. The other thing that happened was I had an engineering manager come to me and say, look, you guys are great at security, but you suck at Data Studio. Can you give me the metrics, give me the raw data, and then I'll make changes and add it into our wiki pages. And that was the intention. I didn't tell him that though, but he took the data, made some changes and added it to their own wiki, which kind of had a ripple effect where other product managers found out about it, other EMs found out about it, and they started looking at it, working with us to modify things as they needed. And they were starting to use the metrics without us sort of publicizing it as much as we were going to. That, I think, is a really big win. Now, all said and done, the real metric of this in a meta sense is to see if all this work actually moved the needle on the security posture. And as people got access to this, we did see the number of vulnerabilities being fixed. So that in all, I think, was a big win for the team in general. And everything doesn't happen pretty smoothly. So I think it is important to talk about what didn't go well. Google Data Studio has its own sort of tweaks that we needed to know. There were things that weren't clear to us. Sometimes it broke. There's a race condition of sorts in the data syncs that happen from the G Sheet to Google Data Studio, where there's a 15-minute window where you have stale data, or sometimes it's broken, so it may need a manual refresh. But once we figured that out, it actually worked seamlessly, and we are pretty happy with that solution. So where are we going with this? As you realize, most of what we spoke about was having product security capabilities and data into the Google Data Studio metrics of security. The end state we want to get to is have a holistic security metrics dashboard, which has not just ProdSec metrics, but metrics from other teams like cloud security, enterprise security, wall management, and so on and so forth. So that's where we're going towards, is integrating all the data from different teams into a single pane of glass, if you will. And after that, so once you have all of the data integrated in one place, what we plan to do is sort of generate a risk scorecard. So every BU or product or even team can get their security risk scorecard based on open P1s, based on what tools are integrated in their pipeline, what are not, and anything really. As Harini showed you, Google Data Studio has this feature of inbuilt sort of formulas. So once you have all the data, you could pretty much write a formula to generate a risk score. And that can lead to really interesting workflows where you could even say, if your risk is more than 75, then you cannot deploy to production. So it has really interesting applications later on for us. The other thing we're working on parallelly is creating individually customized dashboards for teams. We do have sort of this generic high-level dashboard in our Confluence space, but we have also a security champions program, and through which we are working closely with engineers and engineering teams to create customized dashboards for each team, so they can have better visibility into how their sort of security posture looks like, and hopefully drive change in the right direction. So we spoke a lot, we showed you a lot. We have hosted all of the data and the slides that we spoke about on Box. You could take those links or you could take the QR code. I promise there's nothing malicious in there. And there's a Box folder with the slides, with the links to the Excel G Sheet with the data and the sample Google Data Studio report. All of those are open for you to use. You could make a copy, play around with it, and I definitely want to see what others think of it. And if you have any more suggestions or changes, we'd really be happy to sort of have that conversation and sort of see where this can go. With that, thank you for listening to us, and we'd be happy to answer any questions you have.
Wonderful. Thank you so much. So I do see one question in the chat that came up is, this is from Occupy EIP. I see one of the behavior detection examples are web-based or web scans, bot scraping. Can you give some more details on how these work? For example, if there's someone running GoBuster to enumerate files on a web server, what is the threshold on banning, blocking that IP? Do you block after X amount of 404 requests or some other way? I realized that was like 6 questions in one. So
I don't think that was for us.
No, did I miss that one? Okay.
I do see it in the main talk questions, but I'm assuming this was for the previous talk.
Oh, the previous. You're right. Okay. Well, it just came in, so that was why it was confusing to me.
I can try and answer it, but I'm pretty sure I'll get the wrong answer.
My bad. So in that case, I don't see anything else that's come up in the chat at this point. And you gave the links to where everybody can find you on your previous slide. I guess that's all for now, unless there was anything else you wanted to share.
Yep.
No?
Thank you.
Well, thank you so much for being here today. Really appreciate it. And hope to see you around at another ShellCon.
Thanks.
So with that said, it is the end of my shift here at ShellCon, and we will have another MC coming up next with the rest of the day's events. And just another couple of reminders that the CTF is going on. There's a lot of great things going on in the lockpicking village, as well as the career village, the Raise Me village. If you want to move your career forward, if you're just starting out in cybersecurity, or if you want to get to the next level in your career, go check out Raise Me. And thanks again to all of the wonderful ShellCon sponsors and organizers. It's been a blast being here and being a part of ShellCon today. And for now, that's me. Stick around for the top of the hour. There's another talk coming up soon.
Hello, everyone, and welcome back from the break. My name is Maggie, and I am taking over from the lovely Tabitha as your afternoon MC here. First, I want to thank our gold sponsor, Teleport. They create a Bastion host security and identity tool for secure access to multi-vendor clouds, and they are also hiring. So check out the Raise Me job board. That is on shellcon.io/raiseme/job board, a link that you can also get from our Discord if you're on there. And you can get in touch with them, as well as I am sure get that link again in written form in the Teleport Lounge channel on our Discord server. Don't forget to check out their raffle for a Sonos speaker. Also, keep an eye out for a discount code from No Starch Press, which we'll be announcing sometime today. Now that we are through the post-break announcements, I have the pleasure of introducing our next speaker, Freaky, and her presentation, BLE Device Assessment from Start to Finish. Freaky is a security consultant and researcher with a particular interest in wireless technologies like BLE, Zigbee, and Wi-Fi. She has spent the past 2 years working with companies to help improve the wireless security of devices found in millions of homes and businesses. And in this presentation, she will be walking through a complete Bluetooth low energy security assessment by focusing our attention on a single device from start to finish. Without further ado, please give a warm welcome to Freaky.
Hey everyone, thanks for that intro. Thanks ShellCon for having me. Thanks for spending your Friday afternoon with me. I'm Freaky, and this is BLE Device Assessments from start to finish, hopefully. I am gonna kind of interact with the audience a little bit. So if you want to jump into the main chat in Discord, feel free to shoot me some questions and I'll try to answer them. I have it open right here so I can see it as we're talking. So as mentioned, I'm a security consultant with IOActive. I finished a bachelor's of science in information assurance and cybersecurity in class of 2020. Unfortunately, sad face. I'm currently finishing a master's cybersecurity and leadership, where I'm specializing in BLE security research. Surprise, surprise. I also currently hold 4 SAN certifications. And if you'd like to reach out, after the talk, or you have any questions that you want to send me down the line, feel free to reach out to me on Twitter. Okay, so what are some of my motivations for giving this course? Kind of giving away some secrets, it feels like sometimes. If you follow me on Twitter, you might see some of my internal thoughts, but I've started coming across so many devices in the wild that it's almost impossible to try to set aside time to research and test them all. I also don't have the budget to try to purchase every device that I see. Sometimes they're $500, $600, $700, and I'm just like, oh wow, that would be a fun target, but I don't really have the budget, and I can't constantly be knocking on my employers or like, hey, I found another one, like let's throw it on the pile. And that budget would get fairly large pretty quick. So a lot of my motivation is coming from just the sheer number of devices that are out there. I feel like there's more than enough for everyone to get a piece of it, to sink their teeth into some BLE research. That and more voices into kind of bringing awareness into the security issues that BLE brings to our devices. A few people standing up and saying, hey, there are issues here with these IoT devices, or hey, there are issues here with Bluetooth. It doesn't get a lot of traction. I've noticed that there has been more interest in kind of previous years, in the past few years, a lot more interest in BLE security. So I feel like there are more voices that are growing, but I feel like it's kind of my responsibility to help maybe grow those voices. So the more people talking about BLE security, the better, honestly. That and as I mentioned, like there are just so many devices that are coming out now that have Bluetooth on them, whether they just facilitate one small function of a device, the onboarding or just some simple sensor readings. There's Bluetooth on an exceedingly number of devices now. And that's kind of backed up with legislation that we're seeing coming out. If anyone's kind of been paying attention to some of the news on the West Coast, among other states, California and Oregon have implemented the IoT Cybersecurity Improvement Act. And that's pushing for greater security insights into the devices that are coming into consumers' homes, but also government facilities, since this is dictated by federal regulation. Specifically, they're taking a lot of their direction from the NIST SP 800-213, which is still in draft form. So I think they might still be taking comments on that. I'm not sure. So yeah, we're seeing legislation start to back this up. So there's more formalized testing happening. I know we've been doing a lot more Bluetooth assessments than when I first started doing this. It seemed like Bluetooth assessments kind of came through every once in a while, and it was really nice to get into kind of the swing of what I do. But I've been seeing it a lot more. We've been getting a lot more requests, so I assume that's probably happening across the industry. So a little bit about what we're going to talk about today. We're going to split this into basically 3 portions. The scoping portion, which I feel like kind of gets breezed over. And if you're doing this in a professional setting, missing that step can really start to snowball as the test goes on, and can cause a lot of issues, whether that be with time constraints or whether that's miscommunication about technologies. I feel like it's some important things to talk about. And then the testing phase, I didn't finish the slide, but we're going to break the testing phase down into just 3 really basic parts. We're not going to go super in depth into testing. Basically just kind of at a high level, we're going to look at some potential issues and how they impact devices and consumers' safety and security. So we'll break that into 3 separate sections: initial scanning, abusing GAT, and evil twins. That's the other one. See, I didn't write it down. I forgot. And then the last section that we'll talk about as far as assessments is the reporting cycle, which again, I don't feel like it's mentioned a lot, especially in my talks, the talks that I've done. I don't talk a ton about reporting. So I feel like that's important, again, for a professional context to the talk. So just some basic learning goals, and really this a little bit of a filler slide, but just trying to convey professional approaches to BLE testing. It can be a little bit intimidating, even if you have experience as a consultant, how to start framing things, maybe some of your previous security experience. How do you frame that around issues that you find within Bluetooth? And sometimes, it isn't a direct correlation. So you have to kind of, okay, does this impact, information disclosure? Like, yeah, I guess it would, so finding where those pieces go. Hopefully this talk will help you kind of move that way, or at least shift your thinking a little bit. Okay, so let's talk about scoping. If you're not familiar with scoping, generally that's going to happen after there's been some agreement of contract between your client and your organization that you're going to go ahead with testing. But this is hashing out, the device specifics, how long are we going to be testing for? How many devices are we going to have? Is there destructive testing available or in scope? Will we have access to source code, that sort of thing. One of the big things when we started doing a lot more Bluetooth testing was making sure that the stakeholders that were doing the scoping calls understood the difference of technology between Bluetooth Low Energy, or BLE, and Bluetooth Classic. Anyone who has done any assessments on either one of these technologies, I think can attest to them being significantly different in how you approach them as far as testing. There are different tools that are available. With BLE, there are many more options. There are a lot of different directions that you can go with testing. So generally, I feel like those are a little more thorough. With Bluetooth Classic, I will say a little more thorough as relative to the budget. So you can get away with a really, really cheap BLE test and still have extremely significant professional findings, for very cheap. With Bluetooth Classic, if you're not using an Ubertooth, which can, that's still over $100, I believe, and you're, either renting or you're buying one of these purpose-built systems, that can run thousands of dollars. So your testing budget needs to be taken into consideration. The technology also needs to be taken into consideration. We use Bluetooth as kind of this catch-all term of, okay, there's a Bluetooth device and we're just gonna, test this and we have this checklist. And you understand what it is. And then, or anyone gets a device dumped on them that's not what they are expecting. Say they were expecting a Bluetooth low energy device. They've, got their Nordic boards out. They've got their NRF ready. And they're like, oh, actually it's Bluetooth Classic. Oh, well, now I got to switch over, try to get my Ubertooth to work. Maybe take some different approaches to testing. So I feel like that's an important, things have been going much smoother. That was a pretty quick lesson for us to learn, to just kind of be like, hey, actually these are separate technologies. So a little different time constraints. Bluetooth Classic, we generally allow a little bit more time, just because I personally have found the tools to be a little more finicky. Another good ask is there a companion application? And by that is there an application that goes on like a user's phone that's intended to be used with the device. Say it's a sensor or for instance, this thingy 52 here. Is there an application that the developers have intended for the consumer or the end user to utilize for device interaction? Are all of their device and security kind of eggs all in that one basket of that application? Or are they just relying on application layer security? So that can be an important part. A lot of times when we're talking about scoping, clients won't consider the companion application initially because, we've already had a source code review. So, we don't need the security of the application really, investigated. It's very hard to assess an entire system with just one portion of it. If you just give me the BLE device and say, okay, what can you do against it? I can bring up a scan and we can look at the device and what it's actually doing, but without the companion application, I can't then test the other side and say, okay, you're susceptible to evil twins, or, you're opening up GAT services on a user's device, or this and that. So that can be very important. There are also very small things generally that get missed in companion applications that can be easily, fixed within code. So, and sometimes they're not found in a code review because they don't stick out as being, particularly vulnerable code by any means. It's just the way that it's implemented may introduce a less than ideal security situation as far as your application and your device communication. And like I mentioned, do you have access to the source code? So this isn't major. You can definitely do assessments without source code. I've done many assessments without source code. The complication comes in that once I find a GAT service, once I find something that's vulnerable, I then have to spend an extra amount of time fuzzing values to the GAT service, or trying to attack the device in a way that basically I have a blindfold on. I'm trying to reverse device functionality just without, just kind of stabbing in the dark. The projects that I've worked on where I've had source code and been able to go through and look exactly, what the commands are that they're using on this specific GAT service. And not only that, but what is this GAT service? a lot of developers will use proprietary UUIDs so that they're not listed with the Bluetooth special interest group. So you don't know what the UUID does. A lot of times it's, a UART service. So they're opening up serial terminals over Bluetooth. So sometimes it's really bad. And you would know that if you had gotten access to the GATT service and didn't have to spend a bunch of time reversing things. So when possible, I always ask for source code just because it generally will help speed things up. Sometimes it can get you off lost in the woods, but yeah, the more information, the better. So source code. I think that's pretty much it for scoping. So I wanted to move to a small exercise. So I'm going to ask for a little bit of interaction, completely voluntary, of course. So if you're in the Discord chat, feel free to, kind of pop up your thoughts. But I wanted everyone to take a second to kind of reflect on the BLE devices that you have in your life. So, looking around on my desk, obviously I test a lot of devices, so I have quite a few around me. But, things like smartwatches, there's another smartwatch-like device over here somewhere, just thermal regulation. Thingy 52 is a stand-in for many different things. It has so many different sensors on it. What are some of the Bluetooth devices that are in your life? If you feel like popping some answers into the Discord. And then if you don't want to answer, that's totally fine. But think about this also. Where do you use them mostly? Okay, an EKG device. So that's, Bluetooth speakers, extremely common. So yeah, so you're using this in your house, Bluetooth speakers, you might be out in a park. What about your car? Your car has, yeah, AirPods, totally. Yeah, your AirPods you're using all over the place, heart rate monitors, totally. You can see that there are so many devices that have so much, insight into our lives that Bluetooth becomes kind of scary in a way. I know that there's kind of like this, like a bell graph sort of like where you fall in your paranoia of BLE devices. Yes, car scanners are very interesting. But think about where you use these devices. Some of them you're using at home, some of them you're using while you're walking around in public, and some of them are in your car while you're driving around. So think about your house. Like, even if you live in a house, maybe you don't live on, 20 acres and your neighbor isn't, 15 miles away or something like that. Most of us probably have neighbors within a reasonable distance, probably within Bluetooth distance. Yeah, glucose monitors. Those are actually really scary from what I've seen. But think about where our houses are. If you live in an apartment, even more so. This is something I try to talk to developers about. Where are their consumers using their devices? How much overlap are they going to have? In the case of Bluetooth speakers, are you going to be sitting in your living room and then all of a sudden you're hearing your neighbor's TV or they're playing something crazy through your Bluetooth speakers, right? It's too easy if they're in the floor above you, or even at your neighbor's house. Like I feel terrible for my neighbors. I know that they're probably not watching, but I'm sorry. I'm constantly scanning their devices, and I know, like when I run proto-molecule scans, I know it's reaching out and trying to hit their stuff every once in a while. And I try to keep things isolated, but sometimes you just can't help it. But I mean, that in lies the issue there with Bluetooth, is that it's everywhere. It overlaps. Your neighbors can see it. People walking down the street can see it. People driving in traffic next to you can see what you have in your car. So there's a lot of visibility into these devices. And while it may not be something that you can see from miles away, I can still sit on any street corner here and just have an open scan, and I can pick up all sorts of devices. Or I can just drive around town and I can scan, and I will pick up all sorts of strange, interesting things: thermometers, street lights, point of sale systems, Coca-Cola fountains, that sort of thing, headphones, and all sorts of things. And treadmills. I've found one of my neighbors has a treadmill. I can't find the brand. It seems like some strange Chinese brand, but yeah, I have a lot of telemetry coming from their treadmill about their workouts, and I can just scan that and see that. To me, that kind of violates those principles of what we've been taught for cybersecurity. These information disclosures, these bits of information about users and consumers that have determined are so precious within, say, a database. Why aren't they treated with the same kind of regard if they're just floating around in the air? So that's kind of where the shift in thinking has to happen, I think, personally. So that's kind of the point of this exercise. Yeah, exactly. Yeah, so SIGINT on the neighbors. This is interesting, and it may be a little bit of a sidetrack, but I think we've got plenty of time relative to my slides. But I'm kind of working on a project right now where I'm setting up continuous Bluetooth scanning and constantly reaching out, scanning devices, logging them. What do they do? What services do they have running on them? What permissions do those services have? Trying to attribute them. I'm trying to see everything. I want to know what's running on Bluetooth. Yeah. There's some good discussion here. Yeah, try to get an idea of how effective concrete floors are for blocking signals. You'd be surprised at kind of the power of modern Bluetooth devices. Most of them are made to push out to 300 feet sometimes. So if you live in an apartment, you can probably see your neighbor's devices. But yeah, a lot of the Bluetooth attacks that I envision, in an apartment setting, I tend to think of more of as digital delinquency, especially in the case of Bluetooth speakers. It's maybe not malicious. I'm not going to own your network with it. I'm not going to, grab your bank account numbers with anything like that. But, say 2 o'clock in the morning, I'm going to start blaring crying baby noises through your Bluetooth speaker. Like that's digital delinquency. That's somebody just being mean. So, just so that's what kind of this exercise was. Let's think about the things that are around us. What dangers do they actually pose to our security and our privacy? Because they're everywhere. Now, are you scared? No. Okay, so let's talk about phase 1. And generally, this is the same approach that I take for most Bluetooth low energy tests. Just initial scanning. So what I will do, and let me bring up the other window. Hopefully it hasn't gone away there. Okay. So generally what I will do is just scan with NRF Connect. That's the application that I'm using here. I don't think I put it in any of the slides, but if you would like to scan at home, feel free. Don't do anything malicious. I didn't tell you to do anything malicious. Look, don't touch. But you can download NRF Connect, Android or iOS. From what I understand, they've fixed a lot of the iOS functionality, so it should be working better. At least that's what I was told at DEF CON. So, but totally free. And what it allows you to do is have this powerful scanning device here. If I can open up the right window. Of course, I decided to do a live demonstration. So I'm going to actually hit refresh here. and do some scanning. So this is just my phone here, just scanning for the devices that are around me. Yeah, you can see there are a lot of just random names here. I'm not even going to click on some of them. But yeah, like, you know, here's a Sonos. I have a bunch of Sonos speakers. So you see a bunch of Sonos. This one is interesting. This one with a little heart on it. So this is a air purifier that I bought. That's smart air purifier. It's funny, for as much as I dislike smart devices, I actually tend to buy them because I want to test them. So I end up with a bunch of these smart devices. But it was an air filter that, you know, would tie into your phone, and it would tell you if the air filter was bad, or you could turn it on and off, or you'd set scheduling and stuff like that. But I found out that it supported this unauthenticated device rename. So I used a heart to rename it. And that's, you know, it's fairly, NRF Connect is the name of the tool. Here, I can type it in the chat. Oops, it's not the right window. NRF Connect. You can just search for that on you know, the application stores, whatever you're using, iOS or Android, and it should pop up. They have a bunch of different tools, but NRF Connect is kind of a tools. I guess it's not the tool suite. I guess the toolbox is the tool suite, but NRF Connect is the specialized tool for connecting and, you know, exploring GAT services. So this is the one that I use for just about, I'd say like 75 to 80% of my testing. I'm generally using NRF Connect. Okay, so like in the case of this air filter, if we wanted to look at this, I'd hit connect on it. And you can see it was discovering its services. We're connected, but we're not bonded. So we haven't attempted to exchange long-term keys with it, which means that, and a lot of times there will be a timer on it. So within the code itself, it will kick it out, or it will drop the connection if there hasn't been a long-term key negotiation after so long. So it'll start a timer and will kick you off. This is an effective strategy that I have seen in some devices, although generally when I see it implemented, they have a timer that's too long. So even if it's kicking me off, I still have the opportunity to connect to the device, open up a GAT service, and send a command really quick. So, oh no, you're not seeing it. Oh no. Of course.
I can let you know when it shifts back.
Okay.
Surprise MC jumping in here. As per usual, it did work during the tech check.
Yes,
I promise everyone in the audience, I have seen this. It does exist.
Let me try opening that up. No?
Still no. You might need to try stopping sharing and then resuming, or pausing the screen share and then resuming on the correct screen.
Okay, let me try that. Apologies, everyone.
Always an adventure in changing screens live.
Yes, yes. Okay, here we are. Let me try that one more time there.
I am seeing the screen share return, and I am now seeing your device list over top of your slides.
Yay, we did it. We fixed it on the fly. That's amazing. Thank you.
No problem.
The demo gods are smiling on me. Okay, so now you can see what I'm talking about. You're not you know, lost and think I'm a crazy person here talking about nothingness. Yes, thank you for catching that. So let me, hopefully this keeps working. So yeah, air filter, we have a little heart here for the name, if you can still see that. When I press connect, we have discovering services, and then we have a connected status, but we're not bonded. Like I was saying, we haven't exchanged long-term keys yet, so we haven't really paired in that manner. Oh, well, let's say a long comment there. I'll have to read that in a second. So we can kind of click through some of these and start to explore them. Oh, we already disconnected. So that was the timer that I was talking about. We went from a connected status to a disconnected status. And that's something within their firmware that is actually ending the connection if a long-term key negotiation hasn't occurred after a certain amount of time, which, like I said, can be effective if you decrease the time to an amount that I can't actually send a command in that window. So while we're disconnected, we can actually look through some of the services that are open on this, and you can see that it's quite a few actually. So we have read and write services on a bunch of these. Write services or write permissions are generally more fun, just for me, obviously, because then you can just start sending remote commands and seeing what happens. But that being said, read can be very important. A lot of times things will come over as hex values, so you'll have to convert them into ASCII or whatever it is, and then sometimes it'll be hashed from there, so you'll have to unhash it then. But totally, once you start seeing readable characters coming back, it can be very interesting. Let's see here. So I'm going to go back to the scanner and do another scan. I'm having to look around my mic here. And this is the target that I had intended to look at fully. If you watched the talk that I did for the Wireless Village during DEF CON, you will probably recognize this device. It was, or it is, it's still for sale on Amazon, which I'm amazed by, but it is intended to act as a remote car start and a BLE lock and unlock. Okay, yeah, so there's a tip there for anyone watching. YouTube defaulted to 480, so it's probably difficult to see the demo screen. So if you switch to 1080p, it's a lot better. Thank you. Yeah, so remote car unlock start. You tie this into your car, and you have Bluetooth connectivity with your phone. Sounds terrible to me. I don't want a Bluetooth app on my that controls my phone or controls my car. So in kind of doing more research about this, I was trying to find the application to do the companion application portion of this, and all of the apps that pop up don't actually work. So even the one that they recommend. So I don't know. It's $40 on Amazon. I guess somebody is getting $40 on Amazon. So yeah, it's a sad target. It turned out to be a sad target. But we can connect to it. We can see it's automatically trying to negotiate a bonded session. So we've just exchanged long-term keys with it. That may be because it still has my phone stored in its trusted device list. So it's just trusting. It's just giving me that permission level. But it is doing a disconnect, which is unusual. So one thing I can do is go in here, click this auto connect. So when that timer does kick on and it disconnects you from the device, it will allow you to, or it will allow Interf Connect to just automatically negotiate that connection. Another thing I like to do is come in and turn on all of these because it will just automatically negotiate to the highest level that it supports. And then a lot of times devices will have an unstable connection unless you enable these. So let's try this again. Discovering services. We can enable this CCCDS. I'm not sure what it stands for, and I'm sure somebody does. But from what I've seen, it enables like a real-time data flow from it. So in the case of like sensors or anything with telemetry, it will just automatically start streaming any information that it receives from the device, which can be very useful. Let's see. So we have some read. If we want to read all the characteristics, they just have this simple button here where we can just hit that. And it will attempt to read all the values on any characteristic that it sees. See, we've got this one back here, SPPWO. Since it's an unknown characteristic, we have no idea what it does. There again, if we had source code, we might be able to look at what their firmware is pointing to as far as this UUID. But we can also send things. I'll just send some random values to it. And it didn't change anything. So right now we're basically going through and fuzzing. So I guess I should change the slide. Yes. So yeah, as I was talking about aftermarket vehicle access via BLE, unlock, lock, trunk release, that sort of thing. But also can't find an application that works with it. So I don't know if it's technically a device, it doesn't work. But I would say that we're squarely within phase 2 now. Apologies for not shifting. But you know, we're asking ourselves these questions: what services are available? Are any of them like specifically listed on here? Can we see, you know, can we see any services that are running on the device that are already known, that are listed with the SIG, so that we don't have, you know, it takes out the guesswork. We don't have to go through and try to fuzz things and say, oh, okay, that runs the LED. When I hit it with this value, you know, the LED gets brighter or something. I've found that Apple devices are pretty good about having known UUIDs on them. I don't know if that's just because they're prevalent with, you know, filing their UUIDs with the SIG, but yeah, generally those are pretty well-known services. In our case here, we don't really have any that we can recognize just from the internal catalog within RF Connect. All of these are unknown services, and you'll see it disconnecting and connecting if you can still see the phone screen. And beyond, you know, what services are available, what permissions are we granted? Can we just read? You know, what information are we able to read, or do we have write? And to what extent do we have write? Can we just you know, fuzz 0, 1 to a value and turn the device off, sort of thing? Or is it going to be, you know, something where we have to, you know, send a specially crafted packet? I generally have a few just kind of fuzzing values that I have saved, where I can just, you know, select one of these real quick and try to send a huge long stream of things here. You would be surprised at what can happen when you fuzz these GATT services. I have seen devices where they will just totally deadlock for whatever reason. I don't know. I can't see their source code. I don't know what's going on with the device. To where you send these huge values to, say, the name service. So generally this device name, well, here's a great example of a known service. So device name. Sometimes that will allow for write, unauthenticated write permission. So anyone can just go around and change the name of a device that has write permissions on the device name GATT service. Sometimes if you fuzz a huge value to that name, it will cause the device to lock up. So it's a denial of service, you know, and that can happen in a lot of different GATT services. So that's something that I generally test for almost immediately when I see open GATT services. What happens when I hit it with a huge value, rather than trying to go in and fuzz through each individual command. So that can be interesting sometimes. And of course, you know, you can start crafting down packets. Sometimes you can find out what the service is, and the SIG has documentation on all of it, so you can break down the actual command structure. So it might not give you the specific command that a developer is using, but it might point you in the right direction, basically. So like I said, I tried to get an application to work so that I could demonstrate this evil twins portion of the phase or of the testing phases. But I couldn't find an application that actually worked with the device. So, or actually even scanned for devices for that matter, which I don't know, it's unusual. But basically this would entail taking my testing device and changing the GAT services on it so that it would mirror the target or the device that I'm trying to test or target, and then also changing my my device's name to match that that is broadcast by the target. In some instances, that will confuse the companion application enough so that it will attempt to connect with my malicious clone. And when that happens, you can start to negotiate pairing requests. Generally, and this is kind of the thought process or, you know, the place that I operate from is that if a user is connecting to a device that they have some sort of pretense for trusting, whether it's something that they recognize as theirs or whether it's something that they don't think is being malicious, when it tries to initialize that pairing request, they're going to be that much more apt to actually click on pair. So it's almost a social engineering in that context where you're actually trying to trick somebody into clicking on something. But yeah, that was something I was going to try to demonstrate, but obviously we don't have the capabilities this time. So we'll leave that as a exercise for the reader. But yes, just know it is a possibility. It's something that you should look for within the companion application security. Okay, so quickly on some reporting, because I do want to take time for some requests or for questions. So when you're reporting, try to think about things in two different contexts. And I know everyone has their own approaches to reporting. So, you know, take everything I say with a grain of salt. But when I approach Bluetooth testing or reporting for my Bluetooth testing, I try to think about two different groups. The stakeholders, which are the ones who are going to be on the call, the ones who are footing the bill for the development, you know, people writing the code, that sort of thing. You could argue that the end customers would also be a stakeholder, but in the context of the conversations that you're having with your client, they're not really an active stakeholder at that point. But then the other group being the end customer. And, you know, I want to be sort of, you know, careful about what I say, but often companies will not have maybe the greatest incentive to create the safest device that they possibly could. Have they taken safety precautions? Sure. You know, they've done things that were recommended to them or that they knew to do. But have they done everything that they possibly can or that they should, just within kind of the reality that is Bluetooth security? Sometimes not. You'd be surprised. A lot of companies maybe don't realize that certain, you know, hey, having a write permission on this GAT service is really bad. Maybe they didn't realize that. Sometimes, and I'll put expectations versus reality here. Sometimes Bluetooth findings can be knocked down in priority, knocked down in severity. And the simple reason being that, as I've listed here, limited impact. And I guess I need to close that right there. a limited impact. I'm not affecting 10,000 users remotely. I can't just hit a bunch of people's ports and start downloading their information, sort of thing. So in that context, it's kind of suffering from relative cybersecurity issues. Is it mass database leaking? No, it's not. But it's very pinpointed, right? It's very personal. If somebody's looking at that information, they're looking at your information. They're not just casting a net out and trying to drag everything in that they can. Well, I mean, if they're just doing wild Bluetooth scanning, maybe they are, but it's still very personal. Like they're still collecting bits of data about you. And in a lot of times it's difficult to fix. Computers are hard. Bluetooth is hard. Bluetooth development is really hard. If anyone hasn't looked at writing Bluetooth code, it's fairly difficult. A lot of it's in C, and a lot of it is proprietary libraries that you have to learn to work with. And in the case of like NRF, they have their own SDK, and you have to learn their own environment and everything. So there can be a learning curve to a lot of this. So obviously people are going to miss things. People are going to make mistakes. So sometimes, you're not going to get the greatest traction that you would like with some of your findings, but that's kind of to be expected in some cases. And another thing that I've ran into is devices being late in development. So they've already got warehouses stacked full of things. And, this is kind of their last stop in development of saying, okay, we just need a rubber stamp here of everything's secure because we know we've done everything right. And then when you come in with findings saying, hey, that's not the case. I can actually, I have remote code execution over BLE and I can make this and this and this happen on the device. Then they go, oh, oof, wow. And, to mitigate that, you should maybe have this hardware redesign. Oh, that's really expensive. We have all these models that are getting ready to go out. So, yeah, that's the same for a lot of testing. I feel like, whether you're testing a piece of code that's going out or a device that's going out, a lot of these are going to overlap, but, just to let you know that they still exist in Bluetooth testing. And so I'm going to try to move along here. And yeah, I try to throw this in as an example of just some of the initial findings that we would have had off of the car alarm system. It had a default pin of all zeros, and we read that from the box. It actually says that right on the box. But it also tells you to change that pin, but there's no application that works, so you can't actually change the pin. So it's just set to all zeros, which is, I mean, is that really security? It's the Cheeto and the lock. Yeah, meme. I didn't put that in there, but yeah, that's basically what it is. The other thing is it allows multiple bonded sessions. So, anyone could just connect to it, bond to your vehicle control there, and then they have that long-term key trusted negotiation or, trusted key pairing negotiation with it. Which obviously can create issues if somebody wants to open up your car. Exactly. Yes, that meme right there. Thank you. And then, we had some potentially risky GAT services. Is there an over-the-air firmware update? We don't know. It's in these unknown services. So it would take fuzzing or it would take a review of the source code to actually see what's going on. But those are just some of the initial findings. Those are some of the directions that we would kind of go with. If you saw my DEF CON talk, these are duplicate slides. So yeah, you're not crazy. You have seen this before. But yeah, those are the directions that I would start going with in the findings. So yeah, I've been talking a while about Bluetooth. So does anyone have any questions, or I'll turn it over to the MC and she can direct things up.
Yeah, thank you, Freaky. We are going to take some questions. If you have any final questions that you haven't asked yet, please get those quickly into the Discord channel now so that I can pass your questions along. We do have a question from Marco T, who asks, in your opinion, have things gotten better from OG Bluetooth to Bluetooth Low Energy?
Yes and no. So I think it is important to make the distinction that that what we consider OG Bluetooth is still around. It's called Bluetooth Classic or Enhanced Data Rate, EDR. And it's still around. Your phone still has it on it. There are probably still devices that you use with it on there, namely headphones. So if you use any kind of wireless earbuds or wireless headphones, generally that will do a Bluetooth low energy handoff to Bluetooth Classic EDR stream, because you can, pack bigger packets in there. That is probably changing though, because they're coming out with a new protocol for that. So, but that being said, have things gotten better? Yes, in the things that were pointed out by security researchers in the early versions of Bluetooth, things like weak pin pairing processes, very little security placed on packets being broadcast. Now you see, encryption is standard on Bluetooth devices, to where, the communications are just clear text just flying around. You can't just, hit all zeros on most things and get a connection to something. You can't really do like blue jacking anymore, or, read people's phone books and all that sort of stuff that you used to be able to do. So in that sense, it has gotten better. But I think in a lot of ways, the SIG, especially the Bluetooth Special Interest Group, has kind of rested back on that a little bit, and, kind of gotten lazy in a little bit, in a way, of saying, we fixed these issues. We don't really have to, worry about, these problems, and we fixed the things that were threatening our consumers. So in that sense, it's gotten bad again. So it's kind of like time is a circle sort of thing, like snake eating itself. But yeah, it's still bad. It's still bad. It's bad in a different way, I would say.
All right. Thank you, Freaky. Okay. That was another thank you. Seeing no more questions, let's give one last warm round of at-home applause for Freaky. Thank you, Freaky, for that excellent talk. Audience, please join us again at 3 p.m. Pacific time for Wasabi's upcoming talk on WMI, that is Windows Management Interface for Defenders. During the break, do make sure you check out our gold sponsor, Teleport. You can join them on our Discord in the Teleport Lounge channel and check out their postings on the Raise Me job board. They are also raffling off a Sonos speaker. You can find that link in the Teleport Lounge channel on the ShellCon Discord. So don't miss that, and do enjoy your break.
Thanks, everyone.
That was a great talk. Stay tuned for more talks coming right up.
Welcome back again to this afternoon's ShellCon. Thank you all for attending, and thanks to Teleport for their sponsorship at the gold level. Up next, we have WMI for Defenders presented by Wasabi. Wasabi is a security researcher who dabbles in the arts of system administration. He participated in CCDC, CPTC, and many CTFs as a competitor before starting to help organize cyber defense competitions himself. In his presentation, he will be talking about what WMI/MI is and what uses it can have for both administrators and adversaries. With a warm ShellCon welcome, please welcome Wasabi.
Alrighty. Hello, everyone. I can't see anyone. Unfortunately, it's still COVID, so you're stuck with me on a little screen. But here is WMI Stole Your Cat. The hope of this presentation is to be a little entertaining while imparting some wisdom on the Windows management interface. The Windows management interface is basically the thing that powers Windows for the past, I don't know, decade or more. I don't even know how long it's been. It's been an optional feature for a long time. So this talk is going to get a little in depth on that, but if you're a defender, if you do incident response, or you're someone looking at how this works with Red Team, this is going to be a very interesting talk. So I hope everyone has fun. So let's get started. And be warned, there are some very cheesy cat pictures here, and also very pixelated cat pictures. You know, everything you need for a presentation. So with that, let's begin. Alrighty, so as the wonderful introduction was given, I am Wasabi. I am sometimes spicy. All this has come about because of incident response consultation. I recently switched jobs. I'm no longer an incident response consultant, but I was an incident response consultant. And because of that, I got to see firsthand what actual threat actors, what the bad guys are doing on a daily basis. And it's not good, but it's also very fascinating stuff. You know, we always talk about making these tools that are really easy to use and powerful and, you know, handle errors. Their stuff is just run and hope for the best. And sometimes, as you will discover, that's almost better than a lot of the powerful tools because it just works. Except for maybe Cobalt Strike. Everyone seems to use that. I am also a perpetual volunteer. As was said, I help organize CPTC and CCDC, the Collegiate Pen Testing Competition and the Collegiate Cyber Defense Competition. That's enough about me. So let's get started. So you're probably here because you want to know more about the Windows management interface, or the management interface, and how it works, why it's there, and the background on that. You also are probably here because you're interested in understanding how this affects the security of Windows systems. You may be surprised to know that WMI, at least in the broad scope, is not only for Windows. And so some of these techniques can be repurposed for systems that are enterprise grade. And as such, some of these things, while they're probably not going to work the same way, they also have what's called WBEM enabled, and so some of that can be queried and actioned on, just like the stuff we're going to be going. And then, of course, like I was saying here, you're probably here also because you want to see how these attacks work and how they play out. What's the chain of events that take place? So, you know, that's all well and good, but let's start with that beginning. Let's start with the background. I am by no means the first person to present on WMI. It goes back to 2014, if not earlier. There was an amazing presentation from FireEye way back in 2015 on abusing WMI and building fileless backdoors. And it, you know, we always talk about in security fileless being, oh, there's no evidence. There is a file that contains all this information, but it's not a new file. It's not a new entry that's created. So there's evidence, but it's very hard to find. So that was a talk. Then DEF CON 27, minimal rights to gain Active Directory persistence, or DEF CON 23, why am I so sexy? Interesting talk title, but the content was very interesting on how WMI attacks work. So there is some background on that. And you know, it's good to see. I definitely recommend the Black Hat one. It's they also published a huge research paper on it, and by far is the most in-depth article about WMI, almost more so than Microsoft itself on their documentation, although you will see they have providing a lot of information on that as well. So what is the Windows management interface? It is a major component of Windows. It's basically been in existence since Windows 2000. That's where I was getting confused a little earlier. So 2000, 2001, 1999, roughly there, give or take a few years, but that's basically 20 years of implementation on this. Sure, it was an optional component a little earlier than that, but it's slowly built into Windows more and more. And what does it do? Well, it's like a SQL syntax that where you query, essentially the tables are called namespaces, and you're pulling information. This is not just arbitrary data that Microsoft said, hey, let's implement. Instead, what this is based off of the SIM model, or I guess that's redundant, but the common information model. And you'll see the SIM referenced a lot. In fact, WMI is being moved over, transitioned to the management instrumentation, which simply follows the SIM, the common information model of querying information. So WMI is the older thing, but they're still both used interchangeably. So what can it query? Well, I don't need to repeat, but processes, schedule task adjustments, CPU information, AV information, actions on all those. When you open up Windows or you see something that says your AV is active and you need to do an exclusion for the software, or you need to query the firewall and add this exclusion, what you're accessing is usually those underlying WMI queries where you can look into something and say, hey, I have this, or what's running on there. So it's fairly interesting. As each version of Windows, I think Windows 11 is coming out or just came out. It's depending on how buggy you want to have your experience be. It has even more integration with WMI than the older versions of Windows. But as new versions have come out, in 2008, they added PowerShell support for querying WMI and doing all those actions. In 2012, they added a whole bunch of integrations, namespaces, things that you could query, and they keep adding to those. And there are some real exploits since this was all theoretical prior to about 2010, but since then, Stuxnet and WannaMiner all utilize WMI to perform actions. Sometimes it's to disable AV, add exclusions, control different components, adjust settings. So it's fairly interesting, but it pops up everywhere with WMI, and it's fairly in depth on what it can do. You're probably bored out of your minds though, so let's get started with actual things. Once I get into this more technical stuff, what we'll be doing is pausing every so often and seeing if there's any questions as we go. My hope is that this will be more interactive than some of the other talks I've seen with online conferences. So please, if you have questions, please ask. Please, let me know anything going on, so it can be helpful for everyone. So when we get started, there are a couple ways to communicate with WMI. The legacy ways are the ones that most people see when you're using malicious tools in tech. That's VBScript and WMIC. And you can see side by side how this works. On the left side is WMIC, and on the right is task list. What is actually happening here is both tools are querying the same underlying information. In fact, when you do a lot of the embedded Windows commands like task list, task kill, and all those other things, it's in fact actually doing a WMI query, which when you have auditing enabled, can actually allow you to see that query. And so task list actually is just calling what's on the left side and formatting it in a better way. The more modern ways, of course, are with PowerShell. And so you have get WMI, but that's also old technically. What's even better is get SIM, that common interface model. And then there's, of course, external tools, which never age, like WMI Explorer. And why would someone be so interested in using an external tool? Well, quite simply, WMI Explorer lets you adjust, manipulate, search, and query the entirety of the database of WMI. You can take a look at the system and get all the trees and stuff of every component and their own namespaces, classes, and sub-elements, and update them depending on what you want to do. It's extremely powerful, but you're probably wondering, well, how do I know what these are? Do I have to use a tool to get all this documentation? You see on the description, it says, record log or this and how it works. Well, the reality is, no, you don't. Microsoft has basically documented pretty much all of WMI in some form. And a lot of it actually is repurposed. It's kind of interesting. This segment, for example, the scripting for WMI has actually been repurposed by attackers. They just copy and paste, update the settings that they need. For example, like task killing or process checking. They just copy and paste and use it. Why recreate something new when you can use that existing tool? Even if it's not necessarily reliable, it gets you what you need. So here's an example for that file-based persistence, the very novel stuff way back in 2015. It's actually documented on the documentation website for Windows Management and Instrumentation. You can see, create a sync, call a script. Here's the, impersonate, do the, run as this, do that. All the documentation is right there. And again, attackers generally repurpose this. The weaponized stuff is a little talked about, but it's definitely there. And a lot of these providers, when you take a look at these, we'll get to in a minute, called my brain just went away. These instant creation events, the event triggers, these are triggered much like on action. So in this one, when a process is created, you can also do triggers on like USB mounts or things like that. And so some of the interesting persistence that you can get can actually be, if someone plugs in a flash drive, automatically copy, things like that. So I'm trying to check for the questions.
I'm keeping an eye out for questions for you.
Okay. No, someone's just posting a cat. I approve of these messages. So with that, how does that all work? Well, there is a cool guide from 2016 on some of this stuff, on how to reconfigure WMI, but by default, the only requirement for security on WMI is authentication. If you act as an administrator, you can pretty much do anything on the system. And even then, some of that is optional. But basically, you can see the whole tree. The client communicates to the DCOM server. The DCOM server is an older component of Windows, but it still basically controls all the basically what are called COM modules. Those can be adjusted to be different security levels and things like that. From there, it actually is in the actual SIM database. That's where all the namespaces and things. And then these all communicate with each other to ensure, all the information is sharing. You query, get all that information. But the key part here is the DCOM remote protocol. This can be configured by default. It will run on an RPC port. So you can use port 1024 through 65535. Depending on the Windows version, all you need to do is query port 135, which is also used for SMB and all sorts of things. And then you're allocated a dynamic port. This makes securing and blocking WMI very difficult because if you use SMB, now you have to block SMB, in order to secure WMI. It can be easily reconfigured to use standalone mode, which is operating on an arbitrary port that Microsoft picked called 24158. This can be then blocked by a firewall and provided some mitigation. But on an out-of-box setup, which most organizations don't change, you're going to be allocated a dynamic port, which will result in people gaining access if it's malicious. And the attackers rely on this in many cases because they know that those ports are not generally blocked. So here is a screenshot of the DCOM interface. You can see all the components. You can see some of them are very obscure, WSearch and all these different UIDs, GUIDs, and you can adjust. Can a user, for example, Bob, do this? Can system do this? And you can deny the different user levels and groups to help make it a little secure. The most important thing is blocking network access. For example, if a system communicates from an authenticated administrator over the network, you're in the administrator's group already, which then causes you, especially if you have local admin, to have the full access of the WMI interface. So even though that user may not be able to necessarily log into the system interactively, if there's GPO blocks, they have WMI access and they can adjust those settings dynamically. So back to the communication part. When I mentioned WBEM earlier, that stands for Web-Based Enterprise Management. This exists on Linux. It exists on a lot of embedded systems. Essentially what this means is I'm losing my voice. Cool. Okay. Is WMI is not limited to Windows alone. While you will see it in Windows, it's the Windows management interface. The APIs and communication are on Linux as well. And it's super interesting, actually. A lot of not embedded systems, sorry, a lot of motherboards for standard systems, gaming computers and things like that, have WMI drivers that communicate. So if you're on a Linux system, they have to port the WMI capabilities over to Linux, not in their entirety, but WMI is this big standard that most people just don't pay attention to, but it's there. If you look at, for example, many NASs and power systems actually use WBM to communicate. In fact, even I think VMware has a module that can be used. So this communication is not just there, but it is fairly well documented, as we were seeing. And to start communicating to another computer, you only need one argument, well, two, a valid user and the computer name, both of which on a local area network are going to be there. You can just see in the environment. So it's fairly simple. And that doesn't make us very happy, does it? So communication, let's get some more exciting stuff. As I was saying, legacy is DCOM based, and that's bad. We've demonstrated why that's bad. But modern is based on WSMan, also known as PS remoting. If you've done modern Windows management, you probably have PS remoting, and you've probably turned it on, and you can use it to connect to PowerShell and all those other things. WMI can be configured to communicate over that as well, and it's easy to enable and disable those components, but you cannot just easily, as we were saying, disable the DCOM component because it's so interconnected. One interesting challenge to this, though, and this is documented on PowerShell.org when they introduced this way back when, is that WSMan WMI, which is the PS remoting one that uses more secure capabilities, does not support the advanced queries via SIM. So all the SIM queries, if you see something with a prefix of CIM, it doesn't support those. It only supports the legacy like WMIC, reverse. It doesn't support the legacy ones. It does support the SIM. Sorry, that probably just confused everyone. SIM new, sorry, that one got away from me. But it does not support those legacy communication protocols, which are heavily used. So it is interesting. So while Microsoft did make that effort to be more secure, not a lot of people who do actually use WMI are using that because of those challenges. So surprise. So you may be wondering, can't I just turn off WMI? And the answer is yes, you can turn off WMI. I challenge you, but excuse me, you will be challenged because WMI is used on everything from checking again your AV to task lists to the core Windows, like the Windows command line tools, those core utils, whatever you call them. Those use it. A lot of games and services like the actual service manager breaks in a lot of ways when you disable WMI. But also certain games cannot actually start because they check for WMI. They're doing queries to check the underlying system, and without it, they can't get that to start. So you will break things, but it is kind of interesting. It is at least worth an attempt. But now it's time to tinker a little and consider what we can do. So with WMI, the one that is most interesting is the consumers. Consumers essentially are actions when an event takes place. So, for example, you can write to a log file. You can do a command line consumer, which is what all the bad guys do. That actually launches just an arbitrary command. You can send a message, SMTP event consumer. The active script and script standard consumer are sort of similar. They use VB script more or less. I've not really seen them used, but they can be. It says arbitrary in the Microsoft docs, but it's really not arbitrary in any way. So just be warned. The logging is also useful because the NTV event log and the log event file can be used to actually monitor WMI events and log if something abnormal takes place. So now we're getting to this whole intrinsic and extrinsic. These are how Microsoft divided things. And intrinsic are internal changes. So these are pulled regularly. They take place within seconds. If an event is missed, you can't action on that. So for example, the one that we use a lot with WMI tinkering is like instant creation event. Now that's also listed under intrinsic, but querying the actual events that like you did the query, that's intrinsic. Extrinsic are generated more globally and are for things like the OS shutdown, process start. What other ones can we do? I'm trying to think of them. But you can see on like disk change, like USB and things like that. Those are extrinsic, and those are longer duration, but they're triggering for some other action. A lot of persistence actually uses the process creation event as a persistent mechanism because it'll always run and spread. A very good mechanism of persistence that way. Here are some of the tables actually that you can see on some of the events. So MSFT WMI provider, there's a whole bunch of submodules, but what these allow is you to see when a WMI event takes place, like create a namespace change or anything like that. It allows you to see that. The other ones we can see like class creation, instance creation. These are for those other events where something's created or destroyed. The Win32 volume change event is another interesting one. That's the disk monitoring actually. It's not actually like sound level change. So that one's when if you're monitoring for disks to be created or added and stuff, you can trigger on that. So I'm sure everyone's just like, wow, that's super a lot of information dump. So yeah, okay. So
we actually do have a couple of questions if you want to.
Yeah, I just saw that, so I stopped myself.
Yeah. So our first question from someone who is asked to be read off as someone with a cow emoji is asking, can WMI be used to control model water treatment plants?
I don't see why not. You would have to implement it. The WMI is dynamic. You can create your own namespaces. In each namespace, you can have components and control them. So you can create ones where there's triggers and things like that, and all the stuff that we were just looking at. Whoop, that was the wrong arrow. So just like these built-in extrinsic actions, creation, deletion, those will all be functional as soon as you create a new namespace, but you can also create your own events and namespace keys and things like that where you can store information and retrieve it.
Great, thank you. Another question from the same person. Also, remoting via WinRM versus SSH transports. Differences, pros and cons?
You know, I would, that's a little out of scope of WMI, but both use encryption. I personally prefer SSH because then you're not exposing a different protocol, but they're both fairly, they're a lot more robust than legacy.
All right, and this third question might be jumping ahead a little bit, but if you are not already going to cover it in the future, Moonbeam is asking, how might blue teams go about detecting malicious tinkering with WMI?
So this is where things come in useful. I will get to it in a minute, but these namespace creations, instant creations, event creations, deletions, these are all actionable. And so if someone creates a new WMI action or anything like that, you will see those there. One other thing I do want to mention, someone mentioned it in chat, was that Sysmon does have an event tracker. It does not suffice as an event solution for monitoring for badness. So if you're relying on Sysmon to catch you on badness there, you're going to have a bad time. It's one of the weaker sections of WMI, or not WMI, of Sysmon. So just so everyone's aware, we'll get to that in a minute though. So let's start with WMI tinkering. We'll do some basics first. In WMIC, it provides you the quick aliases for the common namespaces. You can see net login, net use, product. You can see registry, server, service, shadow copy, temperature, which is like your sensors, startup events, process start, stop, and all sorts of things like that. There are many more and much more information available from these when you start going into raw namespaces, which you can do from WMIC, but it's just a lot quicker with PowerShell. And so that's pretty fun one. There's also some special ones that allow for direct modification of things like the registry and things like that, but we're not going to really cover those too much. Here's a side-by-side of the old and new. Left side old, process list. New side, get sim instance class 132 process. You're actually querying the pure class name here. So that one is a little less clear. Even on a 64-bit system, all of them are prefixed with 32. It is what it is. WMIC NIC, get network adapter. So that one's a little interesting as well. It can give you some network information. You can't really set a lot of the network adapter settings on there, but you can set some. Most of it's just informational. Same with startup. This one's a very interesting one. Oh, sorry, scheduled jobs. Both of these are very interesting. They both are limited. For scheduled jobs, it does not create a scheduled task like you would expect. Instead, it creates an @ command. So the Windows @ equivalent, it creates one of those. So if that's disabled, you can't create those, and it won't show up in the scheduled task list. It's not permanent. The startups will only show you your native OS start. So if you have 32 launch processes on a 64-bit system, you won't see it. That's the main one. It's kind of interesting, but you know, that's what it is. So yeah, some good clip art there. So let's start running some examples. For this one, you can see where we're starting to use some SQL-like syntax. WMIC process where command line is like Notepad. And you can see that many of the components here have a create, set, delete action for them. So you can call it create to create a Notepad instance. You can call it a terminate to stop them. The one challenge is that the user processes they can't launch interactive processes as easily. So you have to actually, certain processes you have to launch via, you have to create a scheduled task to like an @ command version, and then launch it like a second later, because certain graphical programs won't show up. This will allow you to run all the console-based commands, but like opening up a notepad, it'll launch, but you won't see it. So that's why you need to use that at command. Some of these things have been nerfed. But when you do run the terminate, for example, where anything that contains the key notepad, you can see I've just terminated 5 notepad instances. Creating or deleting services, you can do the same thing. I've put my horrible password in there so you can see how the syntax works. This was just a dev machine. But the interesting thing here is you can see how easily it is to get into the system. There's no, real prompt. But the challenge here is when you're deleting a service, it will delete the service, but it won't terminate it. It also won't perform any cleanup. So sometimes you can get like dangling services, and that can cause problems. But if you're in a pinch or you need to create a service, as an attacker, or delete something from being running, that can do it. So there's some fun. As I was saying, all Windows components basically feed in here. So we can, in a normal Windows computer, we can see what the AV type is. In this particular case, I queried and I got that the system was a Windows Defender instance, and you can see the information about it. And this only works on Windows 7 and 10. Server editions do not query this information for some reason, but you can query it on a standard home edition. When you do this, though, we'll get to it in a minute, but you're using the Security Center 2, which was actually originally found in Windows XP. So kind of fun, but how they've transitioned it over. But tinkering, we can query and on Windows 10 and Windows 7, but on all versions of Windows, you can do some fun actions. This is specifically targeting Microsoft Defender, which is generally running on most systems. But you can see here, we do the local node, and it's called MSFTMP preference. And then we do a call, which is just executing. You can shorten this to just add. And then we say excluded path, and then do C. And this essentially creates an exclusion that is for a path exclusion recursively by default. So anything in the C drive and all subfolders is now excluded. The same thing can be done where we call exclusion extension, and now we've excluded any exe files from being bad. But wait, it gets more fun, because you can do, well, you can't. There's my mouse. Okay, so let's take a look here. So this command is running. You can see that it just ran. About a second later, virus protection is now disabled. But there's no prompt or anything like this. It just goes away. The only notification is that if you decided to take a look at your system and go all the way into the security center, you would notice that AV protection is disabled. But you can see how silent that was. Like if someone was remoted into a system as an attacker, a second later their AV is off. And you can do this in automated fashions, such as process create, just repeatedly exclude and disable AV. So pretty cool, right? So I'll pause there and see if anyone has any other questions.
We haven't received any new questions yet this time, so I think you're good to continue.
Okay. So here's another one. You can see here, antivirus is enabled, and all the information about updates, recursive scanning, and all those things that are how it's configured. So even on a system that you have not compromised yet, such as an external node that you're trying to pivot to, you can query this and see how the system is behaving and how it is secured before even trying to target it. So another interesting thing, you can do some recursive function lookups. You can start taking a look. Part of the trees that are on here is all your add remove programs are listed in WMI. You can get all the Windows updates and a bunch of other stuff. In some cases, you may want to just do a recursive list. So here is a way to do this in batch. It's a little different than PowerShell. The PowerShell one is a lot neater, But the first thing you have to do in batch, if you're just trying to do this, like you got a shell and you want to do something evil, WMI namespace root, you have to do the underscore namespace to get all the namespaces. You have to pipe it to a file, and then you take the raw namespaces.txt and take it to a new file. This fixes the formatting. Don't ask me why this works, but it does. And then from there, you can use a batch for loop to iterate through the namespaces and actually do like WMIC calls on them and do that. In PowerShell, of course, it's just an actual like function that you can make and query all that. But let's have some fun. And there's some pretty interesting areas that you can start messing up on this. For example, what happens if you want to just disable anything that contains the word auto as a service? So here we do the WMI service alias, and the commas allow us to set two things at once. The first thing is stop the service, because normally if you just delete, it doesn't do any of that. And then also disable the service from starting again. And so from this, you can see all the stuff that's been disabled, DHCP, event log, and just everything. And when you reboot, that system's going to be not as great shape. The other thing you can do is you can call a reboot and a shutdown. You can also change account names. You can't add account users, but if you do like a namespace add and a command line consumer, you can create accounts as well. So it's not all a loss, but you can rename accounts directly. But there is more. If WMI did not scare you enough, there are these object files, MOFs, that compile into what's called a BMF, and this is fun because both of those can be compiled and installed. They can create new namespaces and actions, and they're loaded into the object store. So for example, you can install a malicious consumer directly from that as a single file, and then remove it, or just do it in as fileless. So here's one. This is creating a malicious consumer. The our source and everything like that is the instance creation event. So for process creation, or not instant creation event, it's for logs, for any new logs that are created. And then from there, you can see we are registering an action, which is a PowerShell message. And so we can see every time a new log comes in. There are others. Here's one. The command line consumer actually launches PowerShell, and you can write a file, as I did in this one. And this creates a instant creation event for Win32 process. This is the one I was thinking of before. But you instant creation is that extrinsic one again, where anything that is taking place in WMI is triggerable. And the within 5 is looking for that timeout. So that's fairly quickly. And so then every time a new process is created, it will launch. This is how a lot of persistence takes place. And how do you protect, how you use PowerShell to remove PowerShell persistence? You don't. You disable PowerShell. You block it. And hope for the best. Here's installing the MOF. And it just says done. And from there, you can see our log filter is actually, this one's the one from earlier. You can see that it's inserted. The creator SID is obviously the creator SID. It's who created it. Doesn't matter much, but you can see the it's cut off, but you can see the consumer and then the trigger, and so you can run it on there, and that runs in the background. So someone not paying attention or not aware, they're actually running that even though they don't know they are. And it can happen very quickly and repeated. Here's an example where you can delete event filters, looking for a bad name. A lot of the miner scripts, the mining scripts, I should say, They use a similar name. It's like SCM Consumer 10 or something, that not quite right, but not completely wrong for the name. And then, so that is how you'd remove it. But what if you wanted to see if someone was doing something bad? Well, there's the object.data in C Windows System 32. It contains all the compiled objects as well as all the activity. It's a fairly large file, so don't just try to copy it off. And if you do find, it's going to take you a while. There is a parser for it, but I personally just do like type object data find, and it works just fine. So with that, we're probably drowning. Like, how do we protect ourselves against this? Well, you can turn on event logs. Here's those event logs. Remember how I was saying sysmon, event filter created, detected. So we can track on those things. We can see when an event consumer is running, but it doesn't really track what's going on. You can see, for example, this one, it just says something has run. So remote activity doesn't track on remote computers because it's not the origin source. So you don't see where it's coming from, just that a user launched it. The trace activity and the sysmon stuff will tell you a little bit more about the consumer, so at least you can try to clean it up. But if you're coming from if you're trying to do a containment, like it's a spreading worm, you're not going to know. You have to start building up a model of how that goes. And that's why the WMI stuff is so powerful, is because you don't know where this attack is coming from. So what can you do? Well, you can disable WScript in PowerShell if you don't use it. You can disable the WMI port for external access. You can't enable it again, as we were saying, internally, but at least we can lock it out remotely. App Blocker is extremely useful. And you can also, on the right side, you can see how to disable WScript. That has its own side effects, but at least it's something. The other thing you can do is limit the packet, or not packet level, the security level. So you can block out like administrators and only allow a certain user to do WMI, or you can adjust it so that the remote actions can not take place. So there are some security options that you can do, but in general, the best option is blocking WMI across the network, because 99% of the time people don't do that, and that will help limit your spread of an attack if it does take place. Alternatively, if you are an attacker, that's a good option to take a look at, because most people don't do that. So with that, I am at the end of my slides. I hope everyone had a fun time with this talk. You can follow me on Twitter at Spicy Wasabi, and I'm here for questions at this point.
Thank you very much, Wasabi. We have one more question in the Discord that you have not answered yet. Our friend with the cow emoji again is asking if you have any thoughts or experience on using PowerShell DSC to author MOF en masse.
I have not. MOFs are something fairly new to me. I have actually seen them used by attackers. Most of the time, it's jammed into a one-liner, and it's really badly written. I've not seen a legitimate use for MOFs yet, but I'm sure there is one. So yeah, I can't really answer that one. I just know that those can be used to insert direct malicious code.
All right, this is the last call for questions that are related to the talk, please. There is one question in the Discord that you can answer offline if you'd like, Wasabi. It is not directly related to the talk, and so I'm going to ask that one not be on the stream. But seeing no one else taking advantage of this last call for questions, I want to thank you one last time, Wasabi, for that enlightening intro to WMI for Defenders. Hopefully both the admins and the adversaries in our audience learned a bit about how to evaluate the other's use of WMI tools, and the defenders aren't too overly scared about all of these fun new tools and tricks that you've introduced. We are about to have another brief intermission, so everybody shake it out, grab a water refill, and then please rejoin us for the next talk coming up at the top of the hour, which will be Red Teaming macOS Environments with Hermes the Swift Messenger by Justin Bui of the Red Team at Zoom. If you haven't yet, check out our sponsors in Discord, especially the gold sponsor, Teleport. who make a Bastion host security and identity tool for secure access to multi-vendor clouds. Check out their job postings on the Raise Me job board. And if you haven't yet scheduled a career consultation with our Raise Me volunteers, be sure to get that in. Last year, I had them help me write the description of my current job, so I can personally recommend them as a satisfied end user. Otherwise, enjoy your intermission, and we will see you at 4 p.m. Pacific time for red teaming macOS environments with Hermes the Swift Messenger. Thank you and enjoy the break.
CTF is open. Watch out for worms on hooks.
Hello, everyone, and welcome back to ShellCon. Thank you all for attending, and thanks to Teleport for their sponsorship at the gold level. We hope you are all having a great time at the conference. Up next, I have the pleasure of introducing Justin Bowie and his presentation, Red Teaming macOS Environments with Hermes the Swift Messenger. Justin is currently a red teamer at Zoom and was previously a red team consultant at SpectreOps. In this presentation, he will be talking about the research, development, and usage of a new Swift implant called Hermes that can be used in modern red teaming operations. Let's give a warm welcome to Justin.
Hey everyone, thanks Margaret for that introduction. Like Margaret said, my name is Justin Bowie. I'll be talking about red teaming macOS environments with Hermes the Swift Messenger. All right, let's dive right into it. So a quick introduction on who I am. Like I said, my name is Justin Bowie. I go by the handle of @slydog. You can find me with that handle on most forms of social media, including things like Twitter, GitHub, or Medium. I'm currently a red teamer at Zoom, and I previously did red team consulting at SpectreOps. I also helped instruct their red team operations training. I've kind of done everything under the offensive security spectrum, including things like red teams, pen tests, social engineering, physical, web app, you name it. As of recent, I've taken an affinity to kind of macOS research, and that's kind of what spawned this talk. I spend most of my time either doing security research or out skateboarding with my friends. And this is a cool little photo that my old coworker, Brian, photoshopped of me on a Tony Hawk Pro Skater 2. So a quick summary of the presentation. It can be broken down into these 4 major sections. First, I'll be talking about the Swift programming language. I'll be talking about essentially what is Swift, how it works, and some examples of current Swift post-exploitation tooling. Next, I'll talk about the Mythic framework and how it can be leveraged for red team operations. After that, I'll talk about the Hermes payload and how it hooks into the Mythic framework. I'll talk about the development of the payload as well as the functionality, and we'll kind of dive into some implementations as well as some of the code. Lastly, we're going to talk about how to detect Hermes. We're going to do this with Apple's Endpoint Security Framework, or ESF. We're going to leverage ESF to attempt to detect different tactics, techniques, and procedures implemented within Hermes. So the first section is all about Swift. What is the Swift programming language? What are the pros and cons of Swift as a post-exploitation language? And what are some examples of current Swift tooling? So Swift is a high-level programming language that was developed by Apple. Swift 1.0 was initially released in 2014 and supported only macOS. As of Swift 5.3, cross-platform support was enabled for things such as macOS, Windows, as well as Linux. Swift was designed to be the successor to the Objective-C programming language. It was designed to be faster, more optimized, and safer. Objective-C is kind of an older language that Apple still supports, and you could previously use it to write applications, and it's also used to write parts of the operating system itself. Swift leverages the Objective-C runtime library. And what this means is that from a single program, we can execute C, C++, Objective-C, as well as Swift code. This is fantastic for attackers because that means if I write some Swift code and I need to leverage kind of some lower level functionality that's only accessible from Objective-C or C++, I can actually just load that code up into my single program. I'll mostly be talking about Swift for macOS, but it should be noted that you can also write Swift applications for iOS as well as tvOS. So Swift can be compiled and executed in a variety of ways. From the command line, if you have a Swift source code file, so in this case, shellcon.swift, if you pass in that Swift source code file to the Swift binary, the Swift binary is going to compile and execute this code, the code that's within that .swift file. Alternatively, if you've already compiled your code and you want to run it from the command line, you can just use / the binary name, or / shellcon in this case. If you've already compiled your code, you can also just double click it from within Finder, and this will also execute the Mako executable. So now I want to point out the image on the right side. We have the contents of shellcon.swift are to just print out hello shellcon to the terminal. If we pass in this shellcon.swift file to the Swift binary, of course, we are greeted with hello shellcon. Additionally, we can also use the Swift compiler or the Swift C binary to compile this source code into an executable format. Once it's compiled to an executable format or a Mako executable, we can set the executable bit on this Mako executable. and then we can execute it with /shellcon. And again, we're presented with hello shellcon in the terminal. It should be noted that the Swift compiler and toolchain is not installed by default. And so what this means is that if you attempt to run the Swift binary or the Swift compiler binary on the command line, the user is going to be prompted to install command line tools. Command line tools is a suite of tools to help developers compile code. While the compiler and toolchain are not installed by default, the Swift runtime libraries are installed as of macOS Mojave 10.14.4. Since these libraries already exist on disk, Swift applications no longer need to package them within the binary or the application. This results in significantly smaller payloads and smaller binaries. And this is a huge pro for attackers. So some different common languages for macOS post-exploitation are shown here. Notably, I'm missing some languages such as C, C++, Objective-C, and like Rust. I'm kind of listing out different pros and cons for all of these languages, but these pros and cons should be taken with a grain of salt. They're all kind of high level and kind of, I pick and chose the ones that really stood out to me. The first language I want to talk about is JXA, or JavaScript for Automation. JXA leverages a lull bin for execution. A lull bin is a living off the land binary. So this is a binary that already exists on disk that you can use to leverage, for code execution. In the case of JXA, you can leverage the OSA script binary. Additionally, JXA has an Objective-C bridge. And what this Objective-C bridge is, it allows you to call Objective-C APIs from JXA. So if you weren't able to do something in pure JXA, you could actually probably leverage the Objective-C under the hood to basically do anything you want on the macOS operating system. Some notable cons to JXA are that it's single-threaded, so you can't run kind of multiple concurrent jobs. I would say that the biggest con of all is that development has been completely abandoned by the Apple team. So the team that develops JXA has pretty much been abandoned, and it's kind of just this no man's land language that kind of exists, and it still works for now. Some examples of JXA tooling are the AppFill agent for the Mythic framework. This is a JXA agent for the Mythic framework. We also have Swift Belt JXA. This is a post-exploitation tooling, situational awareness tooling for macOS. And then you also have persistent JXA. This is a collection of persistence techniques written in JXA by Leo Pitt. Examples or links to all of these tools are going to be in the reference section. I just didn't have enough room to kind of put all those GitHub repos here. The next language I want to talk about is Python. Python also uses a lull bin for execution in the form of Python or Python 3. A notable con for the Python language is that Apple has stated scripting languages are going to be deprecated and removed in future versions. And so while Python is a great language to use for now, we don't necessarily know how long it's going to be on the operating system. Another con for Python is it's more heavily signatured by things such as Xprotect or malware removal tool. These are kind of defensive products on macOS. And this is more because Python has traditionally been used in macOS malware and macOS intrusions. And so they have kind of more indicators for those specific Python rats. Some examples of Python tooling are the Medusa agent. This is a Python agent that hooks into the Mythic framework that I'll be talking about a little later. The Empire framework also had a macOS agent written in Python. And then lastly, there's this Chainbreaker Python script that you can use to interact with the macOS keychain. The last language I want to mention is Golang. Golang is a fantastic language. It allows for cross-compilation to many different operating systems, including Windows, Linux, as well as macOS, to name a few. Additionally, with Golang, you can very easily integrate Objective-C, C, and C++ code. And so you can leverage all of the Objective-C APIs to interact with the macOS operating system. One of the cons of Golang is that generally the binaries that you produce are fairly large compared to other binaries. Some examples of Golang tooling include things like Poseidon, which is a Golang agent for the Mythic framework. And then you also have the Sliver framework, which is a command and control server and agent, both written in Golang. So you might ask the question, why would you use Swift for post-exploitation? Well, one, Swift offers multi-threading, so we can run concurrent jobs at once. Additionally, we have very easy access to all of the macOS APIs. We have access to APIs such as the Cocoa framework, the Foundation framework, the AppKit framework, as well as the OSAKit framework. In my opinion, Swift is easier to develop than both Objective-C and JXA. And I think that's because Swift is Apple is kind of pushing Swift as the modern language on their operating system. So you can find lots of documentation on things like Google, Stack Overflow, and Apple forums. Additionally, with Swift, we can call C, C++, and Objective-C by the use of bridging headers. So when we need kind of lower level functionality, we can leverage that with these bridging headers. Additionally, if the Swift compiler and toolchain are installed, we have an application whitelisting bypass, or a LOL bin, in the case of the Swift binary. Unfortunately, the Swift compiler or toolchain are not installed by default. And so since they're not installed, that means that Swift binary doesn't exist on disk. So likely, if we want to get Swift code executed on disk, we're going to have to drop binaries to disk. These unsigned binaries may be subject to more scrutiny versus like dropping something as a JavaScript or Python and then executing that with the appropriate LOL bin. Here are some examples of Swift tooling. I'm not going to go through all of them, but my coworker Cedric Owens has written quite a few Swift tools, notably Swift Belt. This is a kind of macOS situational awareness tool that's written in Swift. I've written Swift Spy. This is a macOS keylogger, clipboard monitor, and screenshotter, kind of all wrapped in one. And then on the defensive side of things, Richie Cyrus has written Venator Swift. This is a data gathering agent to aid threat hunting on macOS. And then Super Hacker Steve has written Crescendo, which is a real-time event viewer that hooks into Apple's Endpoint Security Framework, or ESF. In the last section, I'll be demoing some of Crescendo's functionality to detect Hermes. Here's an example of what it looks like to run Cedric Owens' Swift Belt project. You can see all of the variety of checks that we can perform from Swift code. We can do things such as pull data from the clipboard, list out running applications, list out users, look for launch agents, things like that. So in this next section, we're going to be talking about the Mythic framework. We're going to dive into Mythic. We're going to look at its architecture, and then we're going to look at some Mythic implants that you can use to currently target macOS operating systems. So from the GitHub, this is a pretty good summary of Mythic. Mythic is a cross-platform, post-exploit red teaming framework built with Python 3, Docker, Docker Compose, and a web browser UI. It's designed to provide a collaborative and user-friendly interface for operators, managers, and reporting throughout red teaming. So in a nutshell, Mythic is a command and control server with lots of neat features, including that web UI. It has kind of like user access control, as well as things to help with reporting. And these are just a couple of the many features that Mythic has. It's open source at github.com/itsafeature/Mythic. And you can find documentation for developers as well as users on docs.mythicc2.net. Cody's very good at updating his docs, so I highly recommend if you're using Mythic and you have issues with it, check out the documentation. Mythic is an extremely modular and customizable framework. It really allows the agent developer kind of full control over how the agent interacts with Mythic. Mythic also separates all of its underlying components into different Docker containers. Some of these Docker containers include things such as the main Mythic server, the database, payload containers, C2 containers, as well as documentation containers, to name a few. One of my favorite features about Mythic is that you can really just connect in with a web browser. There's no need to download some sort of client application to access the Mythic server. So here's a Mythic traffic flow diagram. I know it looks like a lot, but we'll try to break it down into a couple simple steps. So on this left side, we have the operator's browser. This is how we interact with the Mythic server. This is kind of how we issue commands. This is the front end UI that we see. On the bottom right, we have the agent calling back to the Mythic server. So once we've compromised an endpoint, this agent is going to call back to the Mythic server, and we're going to control it from the operator's browser. But how does this work all under the hood? So first, let's say the operator wants to execute the ls command on the user's home directory. That command and arguments are going to be passed to the Mythic server. Once the Mythic server receives the command and arguments, they're going to pass it to the payload container over RabbitMQ. This payload container is going to be responsible for any pre-processing of the command. So if we need to do any kind of cleanup of the user input or something. So like maybe the path has quotes in it and we want to strip out the quotes, or maybe the path has a space and we want to appropriately handle paths with spaces. We can do that all within the payload container instead of doing that on the agent. So it kind of removes that overhead from the agent. So by the time the command and arguments are passed down to the agent, All the agent has to do is execute and return the output. So once the command and arguments have been cleaned up by the payload container, that's passed back to the Mythic server over RabbitMQ. So now we have a cleaned up command and arguments ready for the agent to pick up. So now let's go down to the agent side. The agent is going to call back to the C2 profile container. In this case, I'll be talking about the HTTP C2 container. So the agent is going to make a web request to the HTTP C2 container. Within that HTTP request, there's going to be an encoded and encrypted agent message. The responsibility of the C2 container is to translate that HTTP request into an agent message that the Mythic server understands. And so that C2 container is going to extract an agent message and pass that to the Mythic server. The Mythic server, let's say that request was, hey, like I need some tasking. The Mythic server is going to respond with any tasking that it has queued up. So in this case, the Mythic server is going to respond with that ls on the user's home directory. That's going to go all the way back down to the agent, and the agent is going to execute that ls, retrieve all of that ls output, and send that back up to the Mythic server. And then once the Mythic server receives that, it's going to display that, and that's going to render in the operator's browser. And so that's kind of end-to-end how an operator issues a command to Mythic. It gets cleaned up, it gets sent down to the agent, executed on the agent, and then eventually the output is displayed back in the operator's browser. So here are a couple different Mythic payloads for macOS that currently exist. All of these payloads use the Objective-C API calls to interact with the macOS operating system. The first one I want to talk about is the AppFell agent. The AppFell agent is written in JXA. JXA is kind of like the poor man's PowerShell on macOS versus Windows. So on the Windows side of things, you can have a PowerShell IEX download cradle. Essentially, this is a PowerShell one-liner that pulls in PowerShell from the internet and executes it in memory. You can do the same thing with OSAScript and JXA. We can host up some JXA on the internet, and then using OSAScript and some JXA, we can pull down that JXA from the internet into memory and execute it. This makes it great for initial access. The next payload I want to talk about is the Poseidon payload. This is the Golang payload for Mythic. The Poseidon payload is slightly larger, but it includes many more features such as socks and threading. Remember that the JXA agent currently doesn't support threading. So this makes Poseidon a great second stage payload after you've landed initial access. The last payload I want to talk about is the Medusa payload. Medusa is the payload written in Python. Medusa also can leverage a lull bin for execution in the form of Python or Python 3. One really cool thing that the Medusa agent can do is it can dynamically load and unload all of its post-exploitation capability. So you can send down a very small agent with just the load command. And then when you need any other commands, you can load up that functionality on the fly. Like if you need ls, if you need print working directory, or whatever functionality, you can load those at a later time. Additionally, Medusa can run third-party Python scripts in memory, as well as execute Python code dynamically. This is really just a brief summary of all of these payloads. I'm really not doing them any justice. The developers have worked really hard on them. I would really recommend you go out and try them for yourselves in a lab environment. So as you may have guessed, Hermes is a Swift payload for the Mythic framework. In this section, I'll be talking about the development of the payload. And then in a follow-up section, I'll be talking about functionality and how it works kind of under the hood. So what is Hermes? Hermes is a Mythic payload targeting macOS written in Swift 5. It's been tested on Catalina, so macOS 10.15, as well as Big Sur, macOS 10.16. Hermes implements an encrypted key exchange for secure communications. In a nutshell, what this means is each implant will go through a key exchange to generate a unique session key. Hermes has various post-exploitation modules. So this includes things such as enumeration, file system access. We have the ability to upload files to the target, as well as download and exfiltrate data from the target. We have various forms of execution and job control. So before I dive into Hermes development, I want to talk about my main motivation for writing Hermes. I find that writing agents is a straightforward and fun way to learn operating system internals. You can start kind of small and you can write things that interact with the file systems, things like ls or print working directory, things like that. You can also write like process listings and things to interact with the TCC database. And then eventually, once you have all of these kind of post-exploitation modules, you can start to wrap them all together and then eventually implement like a job control system, command and control with some HTTP requests, encryption, so all of our data is encrypted. So the project overall was a great way for me to learn, one, a new programming language, and two, macOS internals. I had previously written a command and control framework for Windows called SkateRat and SkatePark. The agent was written in C++, and the server was written in Python 3. I started to write a front end for it, but then I realized that I was not a front end developer, and I quickly just dropped the entire project altogether. I realized that I, one, didn't like writing a front end, and two, didn't enjoy writing the back end. I really just liked writing the agent. And so Mythic was pretty much the answer to all of my prayers. I get to just write the cool part. I get to write the agent that gets deployed on target. So I want to start off by saying that cross-compiling for macOS is a huge, huge pain. My primary goal was to compile Swift code into a Mako executable from a Linux container. And the reason for this is because Mythic uses Docker containers under the hood. So I wanted to make it as easy as possible for someone to install Mythic, for someone to install Hermes, and then compile payloads directly within Mythic without setting up any form of external build systems. So the first thing I looked at was OSX Cross. OSX Cross is a macOS cross toolchain for Linux. This is how the Poseidon agent cross-compiles Golang to macOS. A quick look at the README, I discovered that this project didn't currently support Swift, so that was a dead end. The next project I looked at was Docker OSX. This looked perfect. This was Docker and macOS. If I could just run a macOS within a Docker container, I'd be golden. Unfortunately, after looking at the repository, I found out that you have to run this on a macOS host, whereas most command and control servers are run on a Linux host. And so while this wasn't the end all be all, I really wanted something where I could run it on Linux. Lastly, there are solutions such as AWS Pipeline or GitHub Actions. These are both kind of cloud solutions where you can quickly compile code in the cloud and then get your artifacts back. And I know that these solutions have kind of free tiers, but these free tiers are like limited by like X amount of minutes, or they have like limitations. And so I personally wanted a completely free solution that also kept payload config under end user control. And so what do I mean by that? Within Hermes, there's a file within the source code that defines sensitive information, such as the C2 callback domain, the ports, the encryption keys, and other sensitive info. I wanted to keep that out of third-party control, so out of like AWS or public GitHub control, and all like under red team control, basically. So Darling was the answer to all of my problems. Darling is a play on words. It's a combination of Darwin and Linux. Darling is an emulation layer for Linux. It's free and open source software, and they have a fantastic community on their Discord server. When I was kind of troubleshooting Darling and getting Darling working with Docker and then integrating that with Hermes, I talked to lots and lots of smart people that helped me solve my issues. You can think of Darling as Wine for macOS. So if you don't know what Wine is, Wine lets you run Windows software on Linux. Darling lets you do the exact same thing with macOS software. So with Darling, I could install software, things like Xcode and command line tools. I could run these programs. But the biggest thing of all was I could compile code. I could compile Swift code into a Mako executable. And so we're going to go through that process. And I want to show this example of cross-compilation with Darling. So to start things off, I run the uname binary, and this returns a Linux host. So I'm on a Linux host. We use Darling shell to drop into a Darling container, and then I'll run uname again. And then now it returns Darwin. So I'm on a macOS kind of emulation layer, it seems. And so now let's go through the steps of compiling Swift code again and see if that works. So we have shellcon.swift, and within that file, it says print hello shellcon 2021. Next, we'll use the Swift compiler to compile shellcon.swift into an executable, Mako executable. Excuse me. And then we're going to set the executable bit with chmod. After that, we're going to kick off the binary with ./shellcon, and output to the terminal is hello shellcon 2021. Perfect. We could compile code and even run the executable on this Darling container. So in the previous example, I was testing Darling on a Linux server. My next goal was to get Darling to work within Docker. And remember, this is because Mythic uses Docker under the hood for everything. So I need to get this working from within a Docker container. I ran into a couple tricks to get Darling and Docker to work nicely with each other. First, you have to ensure that you have the Darling Linux kernel module installed on your host. This kernel module is basically the core component of Darling, and it's responsible for most of its functionality and features. Next, once you have the Linux kernel module installed on host, you're going to have to load up that kernel module by running modprobe darling-mock, and you need to run this as root. After you have that kernel module loaded up, you have to run your container in privileged mode. And this is because privileged mode allows the container to access the loaded driver on the host operating system. And so with these 3 steps, Darling and Docker worked very nicely together, and I achieved the goal. I could compile a Swift code into a Mach executable from within a Docker container on a Linux host. So cross compilation was honestly one of the hardest parts of this project. It was just hard to find the tool that would help me do that. But once that was out of the way, it was really just writing code. And here's kind of the fun part of the project. In this section, I'm going to be diving into the functionality of Hermes and kind of the code behind it and why I wrote that functionality. So Hermes implements secure communications with an encrypted key exchange. This encrypted key exchange uses client-side generated RSA keys. We're going to go over this encrypted key exchange in excruciating detail in the next slide. But essentially, each implant goes through this process where they securely generate a unique session key per implant. And since this session key is unique, if the session key for a single implant is compromised, the security of all of your other implants is unaffected. Additionally, the encrypted key exchange gives us the benefit of forward secrecy. Forward secrecy is the concept that even if our long-term secrets, so Mythic and Hermes both start off with a pre-shared key, if that pre-shared key is compromised, that negotiated session key that's negotiated further down the line is not going to be compromised. And of course, the encrypted key exchange offers us encrypted messages. So that means all of our communication between Hermes and Mythic are going to be completely encrypted, as well as any upload or download traffic. So starting from the top, Mythic and Hermes both start off with a pre-shared key. This will be denoted as PSK. When you first execute Hermes on target, Hermes is going to generate an RSA key pair in memory. So it's going to generate the RSA public key, and 2, the RSA private key. It's going to encrypt the RSA public key with that pre-shared key that both Hermes and Mythic know of. Once this message gets up to Mythic, Mythic, of course, has the same pre-shared key, and it's able to decrypt this RSA public key. Mythic will then generate a new AES session key. This is what's going to be used to encrypt further traffic. So now Mythic has the RSA public key and this new AES session key. We want to get this session key down to Hermes, so we're going to use the RSA public key to encrypt that AES session key. Hermes, of course, has the corresponding RSA private key, and so it's able to decrypt this session key. So now here, Hermes will decrypt that session key, and then moving on to step 4, Hermes is going to gather various basic system information from the operating system. So it's going to gather things such as its IP address, its current process, process ID, and the user that it's currently running as. It's going to encrypt all of that system information, and then with the session key, and send that up to the Mythic server. The Mythic server is going to confirm this check-in as a new callback, and then send back down an acknowledgement message. It's going to encrypt that acknowledgement message with the session key, and then Hermes will enter beaconing mode. Beaconing mode is essentially where Hermes is going to reach out to the Mythic server and be like, hey, do you have any work for me to do? Mythic will give the Hermes implant work to do. Hermes is going to execute those jobs and return output to the Mythic server. And it's just going to run this on a loop. So here I want to talk about Hermes job architecture. So every command and parameter that are issued on the Mythic side will turn into a Hermes job. Each job is going to be executed in a completely separate thread, so we can run multiple jobs concurrently. Each job also tracks the thread ID. So if for some reason we have a job that's running and we want to kill it off for some reason, we're able to kill it off based on the thread ID. And since each job runs in a separate thread, Hermes supports long-running jobs or jobs that don't return immediately. This includes things like upload download, which happen over multiple C2 requests, things like clipboard monitoring, which I'll talk about later, and then like things like a while loop. Hermes also has the ability to perform uploads and downloads. All of this is performed in 512 kilobyte chunks over multiple C2 requests. Of course, all of these C2 requests are encrypted with that session key that we negotiated during the encrypted key exchange. And so how does it actually make these requests? It does this with the URL request structure and the URL session class. The URL request structure defines things such as the HTTP method, the headers, the URL, as well as the path. This structure is passed to the URL session class, which makes the actual web request. And so how does Hermes upload functionality work? So upload, to break it down, is how we upload files from the Mythic server down to the target. And so how does this happen? So the user wants to upload some binary down to the target. Mythic is going to take the file size of that binary, divide it into 512 kilobyte chunks, see how many chunks it's going to take to send down to the target, and then slowly start to send down chunks of that file. As Hermes receives these file chunks, it's going to incrementally write these file chunks out to disk. It's going to get 512 kilobytes, write it out to disk, get another 512, write it out to disk. The benefit of this is that Hermes never stores the entire file in memory at once. It's constantly just writing that file out to disk and forgetting about that data. And so theoretically, we could upload arbitrarily large files. Download works pretty much the same way, just in inverse. So download, we're trying to pull data or exfiltrate data from the target back up to our Mythic server. So Hermes is going to take the file that you want to download, again, divide that by 512 kilobyte chunks, and then slowly start to exfiltrate that data over HTTP requests. Once Mythic receives all of those chunks, the server is going to recreate that file and make it available for the operator to download. And so on the right side here, you'll see I downloaded this secret.txt. And when that was finished downloading, I had a nice little button that I could click to just download that to my attacker machine. Upload download can also be done from the Mythic file browser, and I'll show a screenshot of that later as well. Mythic has various different ways to interact with the macOS file system. Most of this interaction is implemented using methods from the file manager class. I won't go over all of these, but essentially Mythic has the capability to do like change directory. We can list the contents of a directory. We can copy files or directories to another location, as well as like remove files or directories. Like if we drop something and we want to get it out of the way, we can delete it. Additionally, the ls command and the rm command can both be performed from the file browser, which I'll show. So here's an example of listing directories on macOS through Hermes. So we issued the ls command on the user's home library, and you'll see it comes back in this nice table view. So we see all of the different files and folders within that directory, as well as the size of the files and folders. We have the owner, we have the group, we have the POSIX permissions, so like things like 777, things like that. And then we also have this extended attributes field. So we can pull back extended attributes such as things like com.apple.quarantine and other metadata that Apple might store in extended attributes. Here's that Mythic file browser that I was talking about. Here on the left side, we have the compromised host. We have Justin's MacBook Pro, and we have all of the different files that we've browsed through the file browser or through the Hermes agent. Here in the top right, you'll see that we can issue a list command. So if I click this list command, it's going to issue a file listing on this /fake directory. And then we can also upload directly to this /fake directory. Additionally, we can see the contents of the /fake directory down here. Within the /fake directory, there's this path file. If we click actions on the path file, we can perform actions such as deleting the file. We can task Hermes to download the file. We can task a file listing if we want to get like the extended attributes of the file. And we can also add a comment. So like maybe this was a juicy file. It had a bunch of credentials. We could add a comment that is stored server side on the Mythic server and say like, hey, like there were credentials in this file. So other operators, when browsing the file system, would see this comment and could respond. So what would an agent be if we couldn't execute things on target? Hermes implements this in two different ways, with the run command as well as the shell command. And you'll see that these are actually very similar under the hood. The run command executes a binary on disk with arguments. It does this using the process class. The process class is used to execute the binary, and then we redirect standard out with the pipe class to capture the output. So on the right side, I do run on /user/bin/who and you'll see that slydog is returned to me. The shell command executes a bash command with bin bash tac c. So this is actually very similar to the run command in implementation. It just uses bin bash as the actual binary and then tac c with whatever the operator wants to run as the arguments. This is extremely useful if you need input and output redirection. So maybe you want to pipe things into grep, or you want to write things out to disk. This is how you would do it using the shell command. So here's how the shell command kind of looks like under the hood. So the shell command, like we said, uses that process class and that pipe class. With that process class, we can set the executable URL. In this case, it's going to be bin bash. And then we can also pass any arguments we want to the executable. In this case, it's going to be bin bash. So we're going to have tac c. And then this job parameters is basically everything that the operator wanted to execute with that shell command. We're going to redirect the standard output to that output pipe for that pipe class we created. And then this last line down here is what actually reads the data from that pipe with this file handle for reading, read data to end of file. So this is a feature I'm really excited to talk about. Hermes supports in-memory JXA execution. Remember that JXA is JavaScript for automation. This is achieved with the OSAScript class. OSA and OSAScript stands for the Open Scripting Architecture. Open scripting architecture languages include JXA as well as AppleScript. And so using this class, we can execute both of those languages in memory. So let's first talk about the JXA command. The JXA command allows us to execute arbitrary JXA on target. In the example on the right, I have math.py, and you'll see that a couple digits of pi are returned. So what if you need kind of more complex JXA, like you need to load up scripts? Well, you can do that with JXA import. This is going to load up a JXA script into memory. And this works very similar to upload under the hood. It's just upload, but instead of writing it out to disk, we're going to store this script within the implant's memory. Once the script is stored within the implant's memory, we can use JXA call to call any function within that script. And now this is really, really cool because we can load up all sorts of third-party tooling this way. Red teamers have kind of been writing lots and lots of JXA scripts to help with post-exploitation, and now we can leverage all of it within Hermes. Some third-party tooling that I want to call out is It's a Features Health Inspector. This is kind of a situational awareness tool. Cody also wrote the Orchard tool, which is a way to interact with Active Directory from JXA. And then Leo Pitt has written the Persistent JXA project. This is a collection of persistence techniques for macOS written in JXA. And then my coworker Antman has written Print TCC DB. And this is a way to interact with the TCC database and dump out its contents from JXA. And so here on the right side, we have JXA import. We're loading up Health Inspector into memory. And then we're running that all checks function. And you'll see that that is working as expected. So Hermes has a couple different ways to list out processes. It can do this one with the PS command. The PS command is going to return all BSD processes. So this includes things such as Linux daemons. It does this by parsing the kinfo proc structure from the sysctl routine. Additionally, aside from gathering processes, we can also gather a list of running applications. And so this includes applications that might be on your dock. These are basically all applications within Carbon, Cocoa, and Classic environments. It does this using the NS workspace running applications. Additionally, we can also kill running processes. I don't have a native command to do this at the moment, but it's on my very near future to do. But for now, you can use shell or run and use the kill binary on disk and pass in the process ID. If you have the appropriate permissions, you can kill that process. And so in this screenshot below, I'm using the list apps command. We'll see that process ID, the architecture, the name. But the field I really want to point out is the frontmost field. We can see if this is the current application that the user kind of has highlighted. So like if maybe they're in Google Chrome or maybe they're in Slack, you can kind of gather additional information on what the user is currently doing with this frontmost field. Here's kind of how the process browser looks like in Mythic. On the left side, we have a process tree. And you'll see that most things are a child process of launch D. This is a very kind of macOS ism. It's kind of just how parent processes work on macOS. And then on the right side, we have various information about the different processes. We have the process ID, the parent process ID, the name of the process, the architecture, the user, as well as the binary path, if we're able to grab it. Not shown here, but we can actually do process listings. We can issue new process listings from this page. And there's cool functionality where we can actually diff between our old and new process listing. So you can see new processes that have spawned over time or processes that may have died over time. And again, this can give you additional user context on what the user is doing. So another way that red teamers can kind of gather additional context on their user is through screenshotting. The screenshot command requires the screen recording permission from TCC. But if we have the screen recording permissions, we can use this. How screenshot works is it uses the core graphics API to grab a screenshot of the display. So first, we can call CG get active display list to obtain the number of active displays. So if I have a MacBook and I'm hooked up to dual monitors, this is going to return the number 3. I pass this number 3 into CG get active display list again. But this time, I'm actually going to get a list of active displays that I can actually loop through. I'm going to loop through all of these displays and grab a screenshot with the CG display create image function. I'm then going to store that image within Hermes memory and send that image up to Mythic over C2. And so here's a screenshot of the screenshot command that captured a screenshot of me doing screenshot development. Very meta. Another cool technique on macOS is clipboard monitoring. Clipboard monitoring is great to get kind of user context, like a user might be copy and pasting internal links for their organization, or they might use a password manager and they might be copy and pasting passwords out of the password manager. With clipboard monitoring, we can snag all this data. Clipboard monitoring works by using the NSPasteboard class. The NSPasteboard class can be used to interact with the clipboard. The NSPasteboard class also has a change count property. This change count property is important because it increases whenever the clipboard ownership changes. And so on macOS, it's really weird, but there's no kind of clipboard event that we can subscribe to and listen to for when the clipboard has changed or been updated. So we have to constantly pull this change count property. And so when the change count property increases or changes, we know that the clipboard data has changed. So then we'll pull down the clipboard data. It should be noted that if you land in a privileged context as root on macOS, you will not have general access, or you will not have access to the general pasteboard. Within Hermes, we have also implemented some safety checks and some ability to enumerate the TCC database. We do this with the FDA check command. The FDA check command essentially checks if your current process has full disk access permissions. And full disk access permissions lets us do various things, such as kind of read data from the TCC database, touch protected files, and things like that. It's a very powerful permission. How FDA check works is under the hood, it's going to open up a file handle to the user's TCC database. If that file handle opens successfully, that means we do have full disk access. If we get access denied, that means we do not have full disk access. This technique was discovered and inspired by my coworker, Cedric Owens, or at Ced Owens on Twitter. He's also implemented it within his SwiftBelt JXA project. So what if we do have full disk access permissions? Great. We're able to use the list TCC command. This list TCC command is going to list out entries from the specified TCC database. The TCC database is just a SQLite database on disk. And so all this command does is basically read all of the data out of the SQLite database and kind of just parse it and kind of show it in a nice fashion for the operator. It should be noted that the TCC database schema changes across macOS versions. They'll like add or remove kind of different fields. So currently, this command supports Big Sur and above. So Hermes also offers plist enumeration. And so if you come from a Windows background, plist files on macOS are very similar to the Windows registry. They serve kind of as configuration for various applications, as well as portions of the operating system itself. And so as red teamers, of course, it's very helpful to be able to pull plist information. We can do this with Hermes using plist print. Plist print is going to return the contents of a plist file, regardless of if it's an XML plist file, a JSON plist file, or a binary plist file. We're able to parse pretty much all the types of plist files. And we do this with the property list serialization class. This class essentially lets us parse all of that data. And so in this screenshot here, I'm running plist print on this com.apple.universalaccess auth warning.plist. And so this plist file is particularly interesting because it lists out various applications and then also has a Boolean value of true or false. This plist file tells us that these applications have, if they have a permission enabled in TCC or not. While it doesn't give us the actual permission that's enabled, it still provides us additional context that we can use in our operations. The last feature I want to talk about Hermes is just environmental variable control. We can read out all of the environment variables using the env command. This is going to list out those environment variables. It does this using the process info class. The process info class has an environment field. And within this environment field, it has all the environment variables. Additionally, we can also set and unset environment variables. We can do this using the set environment variable and unset environment variable call from the Darwin standard library. It should be noted that if you specify an existing environment variable with the set env command, you will override it. So be careful not to overwrite any crucial or critical system environment variables. So lastly, I want to talk about how we can detect Hermes using Apple's Endpoint Security Framework, or ESF. So here we're going to talk about Apple's Endpoint Security Framework. If you're familiar with Windows, you can kind of think of this like event tracing for Windows. As of Big Sur, Apple actually pushed all third-party developers out of the kernel. No more kernel extensions. This put security products and security researchers on the same playing field. We could subscribe to the same system events, and we had access to the same data. And so what does the ESF, what does ESF expose? ESF exposes several different system events. This includes things like process events, so things like process execs, process forks, file system events, so file read, file modification, file creation, file deletion, things like that, and then also module and library loads. There are several free and open source tools that interact with Apple's Endpoint Security Framework and kind of bring this data to the end user. This includes things like Appmon by Xorier, we have Crescendo by Superhacker Steve, and we have File Monitor and Process Monitor by Patrick Wardle. I'll be demoing both Appmon and Crescendo to detect various techniques within Hermes. So here's how we can detect shell commands. So if in Hermes we ran shell tac ls, well, shell with the ls tac lih flag, on the target, we would see this process exec event. This process exec event will show the process that performed the process exec, so this Hermes process. It'd show our process ID as well as the parent process ID, and then show the username. Additionally, we also get context onto what the process exec actually was. So here we'll see that Hermes was trying to execute bin bash tac c ls tac lih. And again, this is the output from the Crescendo tool. So I want to talk about launch agents quickly before I talk about how we can detect them. So launch agents are background processes that launch whenever a user logs in. So like immediately as an attacker, I'm thinking persistence. Launch agents can be defined in property list or plist files in the following locations: /library/launch agents, or the user's home library/launch agents. They can also be placed in system library/launch agents. However, this last one is less of a concern because it's protected by SIP, or System Integrity Protection, on macOS. So what does a launch agent look like? Here's an example of an XML launch agent. Here we have this program arguments key. And then basically, if we place this launch agent or this plist in the right location, it's going to execute /temp/Hermes whenever the user logs in. So this is a great form of persistence. So how can we detect launch agents? Well, first, let's demo the attack. So to put a launch agent on disk, an attacker might upload their launch agent, or their plist, that com.hermes.plist, and we're going to upload it to the user's home library launch agents, so com.hermes.plist. And we'll see that that upload was successful. Now, if we're running Crescendo on the target, we'll see that there is a file creation event that fires. This file creation event is going to spit out the process that performed that file creation, as well as the PID and parent process ID and user. And it's also going to tell us the path of the file that was created. So if we monitor for file creations within these kind of specified directories that launch agents can be a part of, we can detect when launch agents are created. Here's the FDA check command. The FDA check command is how we check for full disk access. And remember, it does this by accessing the user's TCC database. Here's output from the Appmon utility written by Chris Ross. When we access that user TCC database, this ES event type notify open is going to fire. We have the timestamp of when this occurs, as well as the destination. Remember, this is the user's TCC database, and it is indeed that file. And then we also get information about the offending process, so the process that performed this action. So we have the process ID, the name, as well as the path of the process. Lastly, if the attacker has full disk access, they might also try to access the TCC database and dump that database. This is also going to fire an ES event type notify open, because the attacker is going to open the handle to the TCC database they want to dump. In this case, the system TCC database. And so we'll see that event, we'll see the timestamp. Again, we'll see the file that was targeted and the offending process. So that pretty much wraps up the defensive portion. If you want to go out and install Hermes to try out yourself, first you'll have to install Mythic from GitHub. I recommend you install it on Ubuntu 20.10 server. This is for compatibility reasons with the Darling Linux kernel module. Next, you're going to install the Darling kernel module. After that, once the kernel module is loaded, you're going to load up that kernel module with modprobe darling-mock. You're going to run that as root. After that, you'll use the Mythic CLI binary to install the Hermes agent from GitHub. And then you're going to use the Mythic CLI binary to kick off the Docker container. And if all goes well within your Mythic UI, you're going to see a green flashing light next to the payload, which indicates that the Docker container is up and running. So that's pretty much the end of my presentation. Here are a couple of references on the things I was not able to link directly in the presentation. And then just thank you, a big thank you to Cody Thomas, pretty much the developer of Mythic, or at its feature on Twitter. He's helped me endlessly when I ran into bugs during development on the Hermes side, as well as the Mythic side. Big thanks to my coworkers for reviewing my content. Thanks to my old coworker, Brian, for making that awesome Tony Hawk Pro Skater 2 Photoshop I use everywhere. Thanks to ShellCon for allowing me to share my work. And then thank you for everyone who came in and tuned in and listened. Appreciate your time. That's pretty much it. If you have any questions, you can find me on @Slydog on Twitter, or if you have questions about Hermes itself, you can find me in the Mythic channel in the Bloodhound Gang Slack. Thank you.
And thank you, Justin, for that wonderful presentation. I am going to give the audience one last chance to ask questions in the Discord channel. I'm watching main talk questions. So far, I haven't seen any, and every question I came up with, you answered immediately afterwards. So props on anticipating questions there. Thank you very much for that. Seeing no one by last call, I am going to thank you, Justin, for that super fascinating and very thorough talk on macOS red teaming with Hermes the Swift Messenger. It is time for intermission, so everybody stretch out a little, hydrate as appropriate, and we'll see you again at 5 p.m. Pacific time for our final main track presentation of the day, Silver Sparrow and the Tale of the Mysterious Insu File by Plug. Don't forget to enter our gold sponsor Teleport's raffle, which is linked from their Discord channel, Teleport Lounge, and check out their job postings along with all of the others on the RaiseMe job board at shellcon.io/raiseme/job board. Enjoy your intermission, and we'll see you at 5 p.m. for the last talk of the day on this track, Silver Sparrow and the Tale of the Mysterious Insu File by Plug. Enjoy your break.
This is a great time for snacks.
Are we all ready then? We're at time, I think.
Yep. Yep. Sorry, I was mute. Go.
All right. Hello all and welcome back from intermission. We hope that you've had a wonderful time during this first day of ShellCon. To wrap up our presentations for the first day, it is our pleasure to introduce Plug and his presentation, Silver Sparrow and the Tale of the Mysterious Insu File. Plug started his journey in computer security back in 1996. He is a senior member of the DEF CON Blue Team Village and currently leads the threat hunting program at a Fortune 20 organization. In his presentation, he will be talking about a key TTP leveraged by the malware authors. He will be talking about how it was found and how it was used to create new detections to monitor Silver Sparrow activity. Without further ado, please join me in welcoming Plug.
Hello, everyone. Thank you for being here. It's been awesome to be part of ShellCon yet another time. I wish I was there with the conference like all times, but it's impossible. So thank you for being here and staying this long. So today we're going to talk about Silver Sparrow. It's a malware that came early in the year, and this talk is mainly about threat hunting. So I'm going to tell you how we use threat hunt to kind of find Silver Sparrow before it was known as Silver Sparrow, and then I'm going to give you some tips about threat hunting for macOS. So again, welcome to ShellCon. Hopefully you're having a blast. The agenda for today is just really quick about us. Who are we? How is this talk made possible? We're going to do a simple recap of Silver Sparrow. We're going to talk about threat hunting. Then we're going to review Silver Sparrow from our perspective, right? What we did on our side and some of the takeaways. We're going to share some huntable things that you can use now on macOS or Linux. And then if there's time, we'll get into the questions. So really quick about us. So all of these research that you're about to see came from the Paranoise team. I'm part of the Paranoise, which basically is a team now within Yahoo. And so this talk is made possible by Agent K, which is a coworker of mine. He and I are part of the FIRE team, which is the forensics and incident response and engineering team within the Paranoids. And he's into network and analysis. So Agent K had a lot of work in this particular deck. And I go by Plug. My name is Carlos. I do incident response, and I currently lead the threat hunting program at Yahoo. And on my free time, I do synthesizers. You might see some of them somewhere in the back there. So what is Silver Sparrow? Well, to begin with, Silver Sparrow is the name of the malware that Red Canary assigned to. I really, really recommend, if you haven't read the blog, that you go ahead and read the blog that Red Canary created. And I want to say kudos to Tony, because this is some really good research they did. Why is this malware significant? Well, this is considered the first known malware to target both Intel machines and the M1 machine. So both of the hardware that Apple released as of 2021. And so it is definitely very interesting. So this all started around February 18 when Red Canary released the research, right, about this malware and how it was targeting these two devices. But there's a lot more. And part of what made it interesting is the things that it did and the things that it didn't do. So from our point of view, this sort of malware kind of hints to a larger ecosystem of malware that might or not be involved in some sort of like supply chain type of pay-per-click install scheme. You will see why. And again, this is not clear and we don't know, but in itself it's still very interesting and a good case for malware on macOS to dive into. So the main recap about Silver Sparrow is that it infected both Intel and ARM chips. There was a version 1 that was only infecting Intel machines, and then the version 2, it's starting to affect the M1 chip processors. At the time, when this was news, about 20 to 30,000 infected hosts were to be known. And so obviously this made the news. One of the key things about Silver Sparrow is that the activity started late in August 2020. So if you think about it, it started in August 2020, and it was until February when it finally became public. And I personally believe that was the right call by Silver Canary, Malwarebytes, and so everyone else that was involved, just because it was a ticking bomb. And you will see, if you haven't, why. You will know about this in a moment. And the reason is there really wasn't a payload. That's what made it much more interesting. So this is a malware that infected a machine. And when it came down to get the secondary payload, it never really happened. And it was, again, a clicking bomb, time bomb. So very, very interesting. And this is why it has, puzzled many of us. In addition to that, there is this notion of a mysterious Insu file. And we'll talk about what that Insu file is and how that kind of yield to some, incorrect count of infected hosts. So in order for us to talk about the mysterious Insu file, we need to do a detour and talk about threat hunting. By the way, the picture you see right there, that is the picture of literally my coworker. He just dresses in black all the time. So let's detour for a moment. One of the things that I like to do when I talk about threat hunting is to explain a very valuable concept that, in my opinion, it is worth to understand and know about. And is this concept of the known and unknowns. To get us to understand that, we need to quote Donald Rumsfeld. This is a quote that they did, I believe was during Desert Storm. And it basically goes like this. There are known knowns. There are things we know that we know. There are known unknowns. That is to say, there are things that we know we don't know. But there are also known unknowns. There are things we do not know we don't know. Now, at this point, you might be wondering, but what? I don't get it. And you might not be incorrect. Like, it really is kind of confusing. So I'm going to try to break this concept down and make it a little bit easier. And hopefully you see the value of why this is worth it for us, especially when you do threat hunting. So in my opinion, there are 4 criteria on these known and unknowns, and they're kind of broken down in here. So you go from known unknowns to unknown unknowns. And I'm going to break each of them in a way that you can understand them better. So let's begin with the known knowns, right? So what are those? So known are the things and by we, I mean you work in cyber defense. So these are things you know on the security team. But they're also the things that the adversary knows. So we know about it, and the adversary knows about that. An example of this is we have a firewall on the Office X, right? So we know about that firewall, but the adversary knows about that firewall because they conducted some network scan recon, and through that, they were able to determine there's a firewall. So we know about the firewall, and they know about the firewall. Then we get into this other interesting concept, which is the known unknowns. Now, in this case, these are the things that we know. So that the security team knows about it, but the adversary does not know. Now, this is important because up to this point, the balance is in our favor. We know about it, but the adversary doesn't know about it. And a good example of that will be maybe the security team uses application X to protect the company. We know about it, but the adversary has no idea that that application is at play. So the balance is in our favor. This is where things get much more interesting. When we get into the unknown unknowns, and as you hopefully might expect by now, the unknowns knowns are the things we don't know. The security team might not know about them, but the adversary knows. What will be a good example of this concept? Well, imagine that an employee left a set of credentials on GitHub, right? And we are not aware of that yet. So someone put some credentials in there. But maybe the adversary has been keeping track of that employee activity and they know about it. So they know, we don't know. The balance has tipped towards the side of the adversary. This is something we really don't want. And then we get into the most puzzling of these known unknowns, which is the unknown knowns. So what is that? The unknown unknowns are the things we don't know. The security team doesn't know about it, but an adversary might not know about it. What will be a good example of this? Imagine that an employee made a change in a firewall and inadvertently set up the wrong ACL. So they now expose things to the internet. Now, we are not aware of that yet, but maybe the adversary is not aware about it. They don't know about that yet. So that's an important thing. Both of us don't know about it. Another example is maybe you have an antivirus and it's not working on a particular office. We don't know yet about that, and the adversary doesn't know about it yet. But in this particular case, the key is that there's a race condition. Whoever gets to know about this faster gets the upper hand. And this is why it's very important to understand this concept. You want to always be in a position to know all the unknowns. So hopefully now that we talk about the known and unknowns and we understand all the different combinations, then the second question is, well, Plug, how do we find about the known and unknowns? And the answer is threat hunting is one of the ways, not the only, but one of the good ways that could help us uncover these unknowns and help us tip the balance in our favor. Before I get into that, we need to define what is threat hunting, right? So according to Wikipedia, and I read the quote, it is the process of proactively and iteratively searching through networks to detect and isolate advanced threats that evade existing security solutions. This is cool and it makes sense, but to me it's a little complex, and I want to kind of simplify this. And since now we know about the known and unknowns, the definition of threat hunting that I propose to you is just threat hunting is a methodology to proactively look for unknown unknowns. Remember, our goal is to tip the balance in our favor. It's a race condition. Threat hunting through a methodology will help us get there. So that's all cool. How do you do that? Well, the simple way to understand what threat hunting is basically a hypothesis. And normally the way I do threat hunts, they're hypothesis based. I come up with a particular idea in my mind, and the goal is to prove it or disprove it. Is this happening or not happening? By definition, a hypothesis is basically a supposition or proposed explanation of something. And your goal is to, is this true or false or not, right? And the way you do that is you conduct some investigations, you collect data, and the data allows you to prove or disprove something. So how do we do that in threat hunting? Well, you create a hypothesis. The most effective way to create a hypothesis is by using the 6 W's: who, what, why, where, when, and how. If you use them and use them well, like the way I kind of propose these, and I've done a talk, I think I did it also in ShellCon some time ago, but you can find it. It's about hypothesis-driven threat hunts, where I explain more or less how to use this methodology. But so you come up with a hypothesis, and the only other thing you need to do is just develop queries, right? And your queries basically are trying to answer all of the questions that your hypothesis proposes, and the answers through the data basically will be the data that will help you prove or disprove your hypothesis, right? More or less. So in a nutshell, threat hunt is just that. You create a hypothesis and you create queries, and your queries help you answer the hypothesis. And really, that is it. That's all you kind of have to do for the most part. And if you don't know where to start, that's what you want to do. And if you do that, you will get an upper hand on finding those unknowns. Remember that race condition. So with this, we kind of ended the tour about what threat hunting is and the value of the known and unknowns. And I hope that this is of use to you and you use it on your career. Now, what I'm going to do at this point is I'm going to walk you through how I use threat hunt and this methodology to uncover a particular TTP that ended up being tied to Silver Sparrow. And I call this P is for persistence. In order to understand what is happening here, in macOS, you have a concept of launch daemons and agents. Now, all of that is driven, oops, what did I do here? By plist, which are just basically configuration files that allow you to, that have some settings, whether to stop or start a particular application and other conditions within that. Now, what happens in macOS is you have what is called launch daemons. And for the most part, these are the, the daemons run when you start a machine, right? There is no user interaction, there's no GUI interaction, And for the most part, they're storing the paths that you see in here. These are very important processes. Again, they kick in as soon as you turn on your machine. And what you see in this other screenshot is the representation of a plist file, which is just an XML file that has a set of instructions. Another thing you have is launch agents. The agents, unlike daemons, they're associated with the user. So the moment you log on into your machine, that's when the launch agents will actually trigger. They will trigger based on the plist configuration. Normally, there is some sort of GUI interaction, and they're stored in slightly different paths. Overall, for both launch daemons and agents, it's very important if you're doing thread hunts on macOS that you're aware of where these paths live and what is supposed or not to be inside them. The best way to understand what launch daemon or agent is analogous to runkeys and Windows services, right? So basically, it's very similar to it. So in order for me to look and research for persistence, I wanted to basically, use some of the existing data out there. So what I did is I went to MITRE, a track framework, and what I did is I loaded it up, and then I started to look for things. I just wanted to zoom into macOS. So first thing I did is get rid of everything that is not macOS. Now that I'm zooming into macOS, I was interested in understanding, plist persistence, what I can do with plist, right? Knowing that they're key for launch agents and daemons. So what I did is I searched for plist on the MITRE framework. What you see in here is the result of that search at the time, and I color-coded everything so I could have a map of all the different things that I can use in here. And for the most part, what you have is tactics at the top, and then the columns will be the techniques, right? So with this information, I started to look into all the different things that connected plist activity, and whether there was something out there that could be unique that I can thread hunt for. So in the past, I had come across plist body doing other hunts, and plist body is kind of common, and you will see it. So one of the things that I like to do is read man pages or any documentation. And so in this case, what you see is, the man page screenshot. And plist body is basically a built-in tool that is part of the macOS operating system, and it can be used to create and edit plist files. And the keywords here, you can create playlists with this tool or edit them. So at this point, I zooming into plist body. How can I use this one for malice or abuse, right? And what I came across is that at the time, there were no lol bins or GTFO bins that related to plist body. So nothing for me to dive into. So the other thing is, when I started looking further, I didn't find any offensive security blog posts that talk about plist body. And when I went and did some searches in GitHub to see any tools was using plist body, I came across to none of them being offensive. But as you can see in the screenshot, there were notes about plist body being used for administration purposes. And it got me much more curious into it. So how can we use plist body for persistence? So taking that little research that I did and knowing that plist body was interesting, I came up with a hypothesis. Adversaries might be leveraging built-in operating system tools like plist body to create persistence in order to avoid detection when running, copying, or installing plist files. Very simple. All the W's are here, and that is the way that I'm going to conduct my threat hunt. So looking into the research, right, there are some flags in here that are of interest to me. So one of the first things that I noticed with plist body is that there is a lot of software that leverages plist body, right? There's no malicious intent. It's just day to day. And if you do a threat hunt right now on macOS, you'll find that it exists all the time. But what ended up happening is plist body has certain operations that with high level of confidence signal abnormal activity. Very rare. So we're going to talk about those. Now, in order for me to conduct some tests, what I wanted you to do, sometimes what you do when you threat hunt is you develop test cases. You want to, come up with a test case to prove or disprove your hypothesis. And in this case, what I want to do is use plist body to create a plist. Remember, it can allow me to create a plist. So what you're seeing here is all of the different commands that are run in the terminal that basically step-by-step are creating a plist, right? So as I'm doing this, I'm learning about it. Now, what you've seen here is that I was actually using plist body to create persistence, and I was basically using Python to install an Empire shell. I had a beacon and so forth. And so in this case, what I'm doing is I'm basically creating a plist that is gonna trigger my Empire agent, and is gonna run as soon as the user logs on, because this is an agent, launch agent. Now, what you see highlighted in here, the plist body -c at run and load, is the key command. So one of the things that I did is I created those commands, and then I reviewed the output of that. And to review the output, you basically run the command line in here, and what you see is you get an XML, or you can run it and see it in JSON. So everything looked fine. This looked like a traditional plist file. And so what you do after that, you manually create a plist, you verify that it's working. The next thing you want to do is you want to trigger. So think about that is you created a service on Windows, and the next thing you want to do is just basically click start. So to do that in macOS, you can use a tool that is called launch control. So these are the commands that you could use. And in this case, that's what I did. So basically start this plist or this application. And the moment I did, you can see here through some logs that it fire up. So my plist that I created for persistence is working, and it triggered my Empire payload, which is running, the parent process is Python, which is another unique thing that you can thread hunt on macOS. So now that I've done this and I walk you through it, the key takeaway is that all of the other commands that I did were more or less normal, but this one, run and load, wasn't. And it's required for me to create a plist that it will run the moment I log on to the machine. So this one seemed very interesting. So what can we learn from this? What I learned from this hunt is that plist run and load is a great way to create persistence. There was no reference at the time of in any offensive blog post about it being used for offensive operations. I have never seen malware that had used this technique before. And from my opinion, that was a success hunt. We did research, proved my hypothesis, and it turned out that plist body could be used for persistence. So, yay. So, yeah, totally. We nailed it. So the key takeaway in here is that we discover a new persistence option that at the time had not been made public yet. So Silver Sparrow wasn't known yet, and no one, as far as I knew, had made or talked about it from the offensive side. So that was cool for us. That allows us to create a detection, because now that we knew about it, it was a matter of time that someone might use it. So why is plist body important? Well, plist body is important because it became a key TTP, right, that will help us uncover what will be known as Silver Sparrow. Silver Sparrow leveraged this technique to actually create persistence. So that's pretty awesome. Now, a few months ago, a group of us got together to do a macOS workshop for DEF CON 29. And in that, we emulated Ocean Lotus. But we also wanted to do a set of data sets that will be for the participants to go and hunt on their own, and kind of like a mini CTF. And we created another simulation. And for that, I basically came up with this thing that I call OMG Buddy. And so I'm going to explain you what that is. It's not to do with Silver Sparrow, but it kind of highlights the power of plist body and what you want to be aware of it. So for those that don't know, I use an OMG cable, and then I use plist body, and therefore you get OMG Buddy. So OMG cable is an awesome cable that you can actually go and purchase right now on Hab5. And basically, it looks and feels like the real thing. It's perfect for covert operations. You can leave it behind. It has a bunch of built-in features. You can do keystrokes, you can do keystroke injection, keylogin, and you can actually control it from far away because it has a built-in Wi-Fi interface. In addition to that, has some advanced features that I really like geofencing. It has a long range Wi-Fi range. I believe right now it's kilometers in range, and it can self-destruct. So that is actually pretty neat. You can basically take this cable use your payload, and then it will self-destruct. Not that the cable will burn. Basically, it will no longer be functional. So it makes it very difficult for forensics, and it's kind of interesting. This is why you want to be aware of that. So what I did basically is I created a payload where I'm using peerless body to create the persistence. I'll probably create a little blog post and I'll share this so you can play around with it. Some of the values that I use and for this demo are pretty on the sleep timer are pretty high because it was the only way for me to record it and allow you to see it. So hopefully this plays out well and you kind of get to see the demo. So let's see if it does play out well. So what is happening here is, I'm connecting the cable, right? This is my target machine. And the machine that you see in here is just a virtual machine. So I'm basically doing on a virtual machine. At this point, I'm using the sleep values that are a little delayed, that take a longer time, but this attack runs in 20 seconds, super fast. I got a slow network, sorry. So there it is. We got a shell. Now we're just going to test to make sure that we got our shell. And the previous talk, it was pretty awesome too, because he was talking about shells, and he was basically same awesome tool, Mystic. So this is a good way to connect the dots. But what you can see here is basically that this attack works fairly well. And peerless body, if you're not hunting and creative detections, is one of the easiest way to actually run this. So what I just did right there is I created, So what I did in there is I inserted the cable, I created a peerless, right? And you can see it in slow motion. What is happening at this point is my C2 got the payload downloaded, which is a JS file, right? And then I get my beacon in on Mystic, and then I'm able to then list the users. So this is running user level, and it took less than a minute to basically get my persistence. Pretty neat and awesome. So there you go. This is why, you definitely want to look into peerless. So now that we've done the research and we learned about it, how does this connect to Silver Sparrow? So let's talk about Silver Sparrow. Now, for us to understand what Silver Sparrow is, we need to take you back to the analysis we made. So when we were looking at macOS malware, we had 3 different clusters. And so we're going to explain you what those clusters are. But basically is CL1, CL2, CL3, cluster 1, 2, and 3, right? So the first cluster is what we call overlapping techniques. So these are machines or infections that took place, and these happened prior to Silver Sparrow. And in this case, they share similar IOCs, but it's not linked to Silver Sparrow. And then you have another cluster, which is infections that are basically linked to Silver Sparrow and are either targeting Intel or the M1 chips. And then finally, we have a cluster that we're probably going to talk about it here, but it was pretty funny and interesting because it basically had both the Intel and the M1 infections run at the same time, and it was super funny to see kind of Silver Sparrow killing itself. Hilarious. So let's talk about the first cluster, because this cluster for us provided key information about what Silver Sparrow was, and other things that became very interesting still now. So first is this Insu file, which is the topic of here, right? What is the Insu file? Now, the only reason why we're mentioning Insu file is because it was brought up on some of the research, and it wasn't known what the heck was that file doing and what was the value of it, right? So in our first cluster, when we're looking at these overlapping techniques, we have subclusters, and one of them is called the Insu cluster. That's how we label it. And basically, these are infections where we saw that Insu file being created. From our research, we only saw that activity from July 14, 2020, right? So in this case, it wasn't clear what is the purpose of that mysterious file, right? But what basically happened is the Insu file is an artifact that was often left behind by other malware. In other words, a machine got infected, this malware came and infected the machine, and it left that file. So the Insu file is just basically an empty file that got created during infection, And according to our telemetry, remember, we're not a security company, so telemetry is basically based on what we can see, right? It's much more limited. So from our telemetry, we only saw the first signs of that file back on August 14th. So one of the interesting facts about this Insu file is that the malware that kind of connects to the Insu file is very interesting. And what you see in here is if you have bytetotal, you can look for these B hashes and you're going to find clusters of malware that basically are kind of connected. What's interesting is when you look at these names, 1, 2, 3, you'll find that the word search and find are kind of keywords. So this cluster of malware, what it had in common is that when they infected a machine, the names often use search or find. So random names, and that's what they all had in common, which is very interesting. And there's a lot of them, a lot. Okay, so that's why search everywhere. Now, as far as that cluster is very interesting in itself, and I think that it will be subject to a different talk. And there's also been research about it by other companies, on the connection of this malware with other things. So from our point of view, this cluster has been active for months. In other words, the cluster that infects machines that use the search and find, wording. But we only find that during August 14 through October 9th, the Insu file was left behind. Why? It is unknown, but it only happened during that period of time. So why is the Insu file relevant, and how is this connected to the Silver Sparrow malware infection? Well, one of the interesting things is that Silver Sparrow, when it infected a machine, it will do one check. And the check is, as you see in here, it will look to see if the Insu file existed, and if it did, it is stop infecting the infection process, and it will then attempt to auto-delete itself. If the file was not in the file system, it will proceed with the infection. So this was done by Silver Sparrow to confirm the presence, right? But in this case, what we can tell is that, in our opinion, this file was misattributed to Silver Sparrow. In other words, it has nothing to do with it. It is left behind from other malware, and Silver Sparrow, for one reason or another, was checking for it. This is why Silver Sparrow becomes very interesting. Why was it looking for this file? Does this mean that the previous malware that we saw on the cluster 1 is connected to Silver Sparrow? Is it the same framework? Is it the same developer? Very interesting questions, right? So once we eliminate the Insu file from the equation, one of the things that happened at the time is that there was the news about a lot of infections, right? And so this is where we get the 30 to 40,000 number of infections. What you see here is a screenshot courtesy of Malwarebytes that was released at the time. And as you can see on this count, most of the infections are attributed to the Insu file. But as you now know, Insu file is left over from other malware, not Silver Sparrow. So if you account for that and you basically eliminate that, what you end up having is you basically have a much number of infections, which is about 2,000 to 3,000 infections. Now, one of the things that happened is about a week ago, there was a conference objected by the C. And during that conference, I saw a talk by Thomas from Malwarebytes, and he covered a lot of the malware statistics of macOS. And one of them was Silver Sparrow, in which they revisited the numbers and they did a similar thing. They basically removed the Insu file and they arrived to the same conclusion. Now, why is this relevant? In my opinion, the fact that there were much limited amount of infections in Silver Sparrow makes it even more interesting. Because remember, one of the things that makes it very unique is that the secondary payload never kicked in. And as you're going to hear, there's a lot of tracking about decline in the machine. And so it begs the question, who was behind this, and were they waiting to do something much more nefarious? I believe that it had the potential to be very bad. And I believe that the decision to make it public by, Red Canary was a perfect call and at the right time. So kudos to them for doing that. So with that said, we basically resolved the mystery. We now know what the Insu file is. And basically, it's a file that was left behind by other malware. So there's another thing interesting about this. On this cluster of overlapping techniques, we also have another unique cluster. We call it the King cluster. And that is started around August 20th. Now, what happened is before August 2020, we identified the King cluster, right? And this was the first cluster that actually used Pilis body. So this was great because for the first time we had threat hunting, we found that Pilis body could be used for like abuse. And here's the first time that it actually happens. And this is a unique cluster. What makes this cluster unique is because at the time, I was very curious about it. And now that months have passed by, there's been other research by other people about other malware. And in my opinion, it is definitely connected. And I think it's worth to have its own talk to kind of go and get to see an overview of that. And I look forward to do more research and then bring that talk in the future. So what ended up happening is that these sort of kind of happened in parallel to Silver Sparrow, but is very interesting. So what ended up happening is this: on August 20, you see for the first time, at least from our point of view, telemetry, it was the first time we saw Pilis body used for persistence. And then on August 28, the King cluster goes away. We don't see it. It's gone. Was this like a test run and then it became Silver Sparrow? I don't know. But what ended up happening is Silver Sparrow kicks in and I don't see the King cluster anymore, which is kind of interesting, right? So why is all this pre-activity important? Well, because it gives us a nice timeline and it allows to basically say the Insu file is not related to Silver Sparrow. There's a King cluster that is leveraging for the first time this technique, and then Silver Sparrow kicks in. The question is this all connected? Is this all the same developer? Is this the framework? Is this the same operation? We don't know, but it's fascinating. At least to me, it is. So that's why we're presenting this. So let's talk about Silver Sparrow. So Silver Sparrow basically started to use Pilis body for persistence, right? And again, we know that it targeted M1 chips and Intel chips. And for that, you definitely want to read the blog post that Tony did. And kudos to him, kudos to Katie Nichols. We had a nice conversation, and I learned quite a bit from threat intelligence and naming clusters. So Katie, if you're watching this, thank you so much for that. It was a good lesson for me personally to learn about. So because there's a lot of information about the host, we wanted to cover what we did when we hunted for this, and we did analysis from the network side. We're very proud to basically have an open source tool called Archime that you can go and download now. I encourage you to do that. Archime basically is a network tool that allows you to look at network, collect PCAPs, and you can do hunts and a lot of other stuff. So let's see what Archime tells us. Now, we did a blog post that is under the Paranoes. You can go and read, and there's a lot of details. So I'm not going to cover everything, and I'm going to try to be very fast on here. But what you see in here is more or less from the network side, the infection kill chain. So let's kind of walk through it, right? There's a lot of URI parameters that have important information, but we're only going to concentrate on a few of them. So the infection begins with a user searching for a key term, and there's this Q parameter that basically tracks the keyword that has been searched, and then there is this PQ parameter that collects a unique identifier for the client machine that did that key search. This begins at the CDN level, and at that point there's a redirection that takes place into this domain, a standard connection. That domain was labeled in some of the reports, and what you can see in here is that a few GET commands. We kind of block a few things because there's some information that might be valuable, and so we want to keep it outside. So that's why you see some things that are blurred. So one of the things that's interesting is that in at first appearance, it looks like nothing is happening on that redirection, but in reality, there is information things that are happening here. And so what is kind of happening is a series of checks to determine, hey, is this client, worth for an infection? Let's collect some information. And what you can see in here, there's a few things that have been collected and crumbs that are being passed on. So you get the query that, where it came, what search command landed the redirection, and information about the client ID and a few other things. So if all that criteria is met, then you're redirected to an S3 bucket, where then you will be downloading the payload. Basically, at this point, your target for an infection. Notice that we went from HTTP to HTTPS. And so at this point, what is happening is, again, there's another redirection that is a bit misleading. But one of the key things in here is that this domain in particular at the time, and I don't think it was never made public, was actually applied, and it is very significant. Again, we go from HTTP to HTTPS. Validfunction.com collected stats. Now the stats come from the infection. So the machine gets infected, runs a series of commands that basically collect data, and it's sent to, to this valid function site. One of the things that gets collected is the DL click value. Basically, if the user click and download it, that gets collected. So, one of the things that are interested in here is that there are all these values that are actually collected. So at this point, you're collecting information about the client, and you have a bunch of other information that provides value. These STU value that you see here on the screen in red is basically encoded, but it's tracking information about the machine. It's tracking, I believe, the referral. How is that you landed in here? So why all of that is kind of interesting, right? So once you decode those values, you actually see how there's a lot of tracking going on. And for me, this is important because this speaks to an ecosystem of pay per install type of thing, right? Why otherwise you will be tracking client information and infections, unless you're looking for particular targets, which this is why it makes Silver Sparrow very interesting, right? Are you looking for a particular target and you're tracking all this telemetry so you know who you're going to target? Possibly. So very interesting things that were happening behind the line. So after you go through the infection chain, right, you then go through these other update site on Amazon. This is another S3 bucket. So at this point, the browser, the client did a search, the client is redirected, then the malware is installed, it starts tracking, right? And the infection now is taking place. So this is very interesting because it gives us also some information. And what you see in here is this get. So get stats, or that particular URI, is very interesting. You can actually take that and go and hunt it. It was one way in which you can keep track of the operation of this particular malware. So it was a very good TTP for us to zoom into it. And as you can see in here, there's a lot of things that are being collected that are tracking. It's not very highlighted, but there is the DL click in here. So that statistical information is being collected. And so here's other things. Once the machine is infected, there is this post beacon activity. Internally, we didn't call silver sparrows. We used to call this cluster the pickle cluster, and Will's going to explain you why. So after you infected the machine, then the machine will start doing curls to go and try to fetch activity, right? Try to look for things. And what you could see is that the URL parameter that is used is PKL, so pickle. And this screen you see in here became a very huntable thing at that point. It was a good way to track activity. Again, now you're back on HTTPS. You see that there's a post, information is being passed into it. There's also this parameter mnpk install. And there's also an M, the M in here is a machine ID. So when the malware gets installed, it does a command ioreg and other commands that collect client information. And so this is basically what is sent to what will be the equivalent of a C2. So there is also information about a U value that basically contains the final URL and a lot more details that we don't have time to kind of cover through. The most important thing is that if you're doing threat hunting, you could have literally looked for crawl activity and start understanding the beacon activity. And that really is what the value is, right? And this is also very important because this is the part where we were expecting the secondary payload that never came. And that is very interesting. So now that you know about Silver Sparrow and how we discover it and how it had the possibility to be really nefarious, let's do it really quick. Let's go over some other threat hunt ideas. So again, the Red Canary blog did awesome and they provided you with a lot of information. And if you kind of just go through it and you break it down, there will be some things you could you could have hunt or you can still hunt for that will be of value. So I want to share those with you. So the first thing is curl to temp. So anytime you see any sort of curl activity, right, especially when in this case the file is being downloaded into temp and is JSON or anything else, that really becomes very interesting. So depending on your organization, curls to download temp could be or not common. From my opinion, it is not common and is much less common whenever you see a file downloaded in temp that is JSON. But hey, your might vary, and maybe you have developers that do that. So, be aware of that. So one of the things that is important is that when you see curl activity, the question is, what else can you see? And in the case of silver sparrows, there was a beaconing going on. So the fact that you were to hunt for curl activity, you will see this beacon, which was happening every hour. Curl going to this particular URL, checking for the version information. Basically, it was looking for, what do you want me to do next? What do you want me to do next? What do you want me to do next? And is doing that every hour. So very good way to hunt for things and an easy way to find a beacon. Now, another thing that the malware did is it leveraged this tool, PLUtil. And basically, PLUtil is a common use tool, right, for legit operations in macOS. But based on the statistical analysis, in our opinion, that particular portion of the command, it is not as common. The -r basically is telling to read that JSON file and convert it into an XML format. So based on what I know, is likely rare, and it provides a high confidence and detection opportunities. In other words, if you go right now and you look for PLUtil-convert XML-R, chances are you might find something of interest, especially the -r. It is a little bit rare. And remember, when you do this type of hunts, you need to count that arguments could be in many different positions. So sometimes you need to do, a query that uses regex to accommodate for the variations in which a particular argument could be. So be mindful of that, right? Another thing that a lot of malware do, and Silver Sparrow was, no different, is to basically tap into the SQLite database that basically tracks quarantine events. So macOS has this way to track where a file has been downloaded and whether it met the criteria to be quarantined or not, and a few other attributes. And so in this case, Silver Sparrow was actually making queries. And one of the telltales on that is that not only did it do those queries, but as you can see in here, it saved the output of that into a particular file. So pretty odd and definitely very interesting. So TLDR, a lot of malware will do this, and there's a few software out there that is legit that does it. So, keep that in mind, but definitely worth for you to look into it and hunt it. So one of the best takeaways from Silver Sparrow is the installer. So in macOS, there's, you involve an installer process. And if you follow it, you might find very interesting activity. So Red Canary can look into the installer activity, the installer itself, right? And so I recommend, if you do threat hunting in macOS, that you do analysis on the installer activity and what they're up to. So one of the key things in here is you want to zoom into the installer activity, but account for the fact that PK install sandbox will create a lot of noise and likely is legit. The key thing is that most malware or software that will try to do some sort of abuse will involve the temp directory in ways that is not expected or common. And so hopefully by now you kind of notice that there is a trend in here, and the trend is that temp directory it's present all the time. So we start diving into the temp directory and we just start looking at what is happening in there. You can uncover lots of activity that becomes very valuable. So one of the most threat hunts that you want to do in macOS is look for activity under the temp directory, because you will find very interesting stuff. And if you do hunts like that, or if you would have done hunts when Silver Sparrow was taking place, you would have uncovered it right away. So the installer and the temp directory is basically a gold mine of events, and it is very, very valuable and worth for you to look into it. As you can see in here, we're able to see a lot of interesting stuff, and many of the things that I kind of comment to. Just this screenshot in itself has totally multiple detections that you can create that I'm not covering, but use this screenshot and you can develop at least 5 to 6 detections that will help you identify very interesting activity, whether it is malware or not, abnormal activity. So in here, we can actually see how plist body is being used, and we're able now to connect the dots on everything that I just presented. So there is plist body, there is our crawl activity, and this is our convert command, right? So everything I just shared to you, looking at installer and the temp folder, boom, here we have them. So at this point, let's do a recap and some takeaways, right? So one of the things that it's important to know when you do threat hunting is it allows, in our case, to know about the TTPs way ahead of time. So if you threat hunt similar things, or if you would have done this, or if you do now, you might come ahead and you might find very interesting stuff, and it gives you the upper hand. Remember, unknown unknowns. You want it's a race condition. Tip the balance to your favor. So threat hunting will help you do that. In our case, the plist body threat hunt was a good way to create persistence. We found that there was no reference on blog posts at the time, offensive blog posts. We know that at the time, no malware had used it. And so for us, it was very successful. But it was the key to help us detect early on, really early on as it happened, silver sparrows, right? So the other thing that is a takeaway is through this work, we were able to basically identify that the Insu file is not related to silver sparrow, and it was just left behind by other malware. We now know, and we confirm, that our approximation of infections is actually that number, 2 to 3, maybe 4,000 infections, which in itself is very interesting. And again, now that you hear what silver sparrow could have been and all the things that it was tracking, I do believe that it's worth to think about what this could have been if it would have gone to the second stage. In my opinion, it had the potential to be extremely bad and very targeted. And that's what it makes these not only very puzzling and interesting, but very significant. So last part of the recap, if you can, clustering is a good way to kind of break things. So when you threat hunt, you want to kind of break things apart, see how things kind of connect and how they don't connect. In our case, we were able to create, 2 different clusters within one cluster, subclusters, the Insu and the King cluster. And the King cluster in itself is a very unique one that I hope that I can get to do a talk about it and dive in a little bit further into it. But we're able to create a timeline of the events, and we know more what happened. So through this, we were able to solve one of the mysteries, and we were able to determine all the infections were lower than expected. So with that said, I've reached the point of the end of the talk. I hope this is of value. I hope that you can use some of the techniques that I presented to you so you can go and hunt. I want to give, some props to, first of all, the Red Canary team. Kudos to Tony for all the awesome work on that blog post. Thank you, Katie Nichols, for, the chat that we had and for talking about how to cluster. If you haven't read that, she's got a really good blog post about, how you do threat intelligence and how you cluster. Highly recommend it. I want to say thank you to the ShellCon team. I wish I would have been there in person to hang around with some of my buddies and friends. But thank you so much for, allowing me to be here. To the DC 560 crew, they're always awesome and they're local. Andy Week and at least, they actually are the developers behind Archemy and the Archemy community. And all the pioneers, my teammates that get involved, especially Daniel Collins, which did some awesome research, and Agent K, which is basically the packet connoisseur and my teammate that allowed me to work on this, and Sean Esposito, which is a wizard of words. And with that said, I want to say thank you to the Fire team and thank you to you for watching. So let me know if you have any questions.
Hello, thank you, Plug, for helping us end very strong with that enthralling tale about your work with all 3 of these malware families. Not seeing any questions in Discord, and I gave people a last call, so I think we're good, and you already covered everything that the audience was wondering, so extra thank you for that. This was the last talk of the day, but it's not all over yet. There will not be additional closing remarks after this, but next up is ShellCon After Dark on Twitch. You can catch DJs for most of the night starting at 7 p.m. Pacific on twitch.tv/ShellCon. If you forgot that link or didn't write it down, the link is both on the shellcon.io website as well as in the Discord channel. Don't party too hard though, because we will be back tomorrow morning with our second day of talks. If you are registered for a workshop tomorrow morning, we may see you bright and early at 8 a.m. Pacific time, and otherwise talks will resume at 10 a.m. Pacific time on Saturday. Here on the main channel, we will start off with EDR evasion with D/invoke, and the Raise Me track will resume tomorrow with a talk called Congratulations, You Are Almost Hired. I hope that you enjoy the DJs tonight and the talks again tomorrow. Thank you very much for joining us, and thank you for attending ShellCon.
That was a great talk. Stay tuned for more talks coming right up.